Hello and welcome to Chapter 1 to RH134, 41 RH134 training course. So Chapter 1, it's all about, they call it improving the command line productivity. That's kind of the official chapter name. But basically, this is going to be a short introduction to scripting. I'll tell you more about it in a second. And also the introduction to the grep utility. But stay tuned. Let's roll the intro and just go to work. And that's quite enough for the intro. So let's go direct to our console here. Here we go. So we have here the same machines we were using on the RH124. Let's just set up the microphone here. Yeah. So these are the same. These are the same machines we left off with the RH124. And let's carry on. So like I said, this is Chapter 1, improving command line productivity. So in simple terms, you're going to learn how to set up simple bash scripts, okay? And also give you an introduction to the grep utility or the grep workflow in a way. You have seen me use the grep utility previously. Yeah, it's not the first time you see me using it, but let's just kind of get an official outcome to it. So put it in the official chapter, so we can just stick with it and carry on with our lives. All right, so simple scripting. So the way I see it, it's that in the script we will just put things that you want to do in repetition. So in the script, we basically at this level, at least at a very simple level, we are going just to put in the text file actions that you want to do, that we do in a more daily fashion, that we do in a more repetitive fashion. So instead of just typing the command in the command line, we're going to put it on a text file, that it will make it easier and less prone to errors when we want or need to repeat that task multiple times. Okay, so that's exactly what we're going to do here. We are going to learn how can we get the script going and do some simple tasks with it. And then maybe in the future, we will be able to kind of develop more about this subject. But let's keep it really simple at this point, and let's just dive into it. Let me just fix this. I have a wireless mic. I have a lapel mic here. I don't have it at handy, but maybe I will use it instead of this big one. But we will see. Okay, so here we are in our usual machines. Okay. And we just this is just where we left off, and I have here a folder called scripts, nothing special, and I have here two scripts. So what makes a script a script? It's pretty simple. Okay, so simple that I have here a text file called simple. Let's just get into it. It's just this. So what makes a script a script? Well, two things. What makes a script a script is that it's a text file, and the text file starts with this line. This is called a shebang. It's hashtag at the bank. So simply terms, this is hashtag and exclamation mark. This is called a shebang. And then we're going to tell the system what is going to be our shell, our interpreter. What does this mean? This means that we are going to instruct our shell to tell him or tell her, it depends, it doesn't really matter, to tell the shell which utility, which binary is going to be used to interpret the following commands. Okay, so basically, like I said, and I'm going to use the word basically a lot, but just bear with me. So you're going to instruct the system, in this case our bash shell, which is going to be the executable that is going to interpret the following commands. Okay, many things can be put here, but you're going to stick with the bash script. It's usually called a bash script because it's going to be our bash shell that is going to interpret all of this. If you want to know more about the bash, more bash shell details, you can go to the playlist about the RH124 training course, and where I discussed more about what the bash is. But basically, it's our bash shell is going to interpret commands, and we are going to tell the system which is going to be our shell to interpret the following commands. So if you create a bash script, it's going to be a bash script, because there are other shells. I will not discuss the other shells because you can just go to the RH124 and check it out. But if you build a bash script, it's going to be interpreted by the bash utility. Okay, so if you build a bash script, it's going to be built by for the bash utility. Okay, and that's what's going to happen. So if you use a script built for another shell, it will probably fail. But I digress. Since we are using the bash terminal here, it's going to be the bash, the interpreter. Probably there are two common ones. You have the bash and the shell, the sh. Never mind, I'm digressing again. So this is going to tell us who is going to be our interpreter. And in this case, we are going to instruct telling, okay, this is a bash script. Please use the bash utility or the bash binary to interpret the following commands. And a script, in very simple terms, which is the ones I'm going to use now for this chapter, is that these are just basically in sequence commands that we can use multiple times, and we can just evoke this. Instead of typing all of this in the command line, we can just put it in somewhere that can be very easily reusable. And that somewhere, it's a text file. So this is a simple text file that's created. I call it simple.sh. Don't forget that in Linux, file extensions do not matter. Okay, in Linux, file extensions do not matter. So which means that this .sh here, it's just irrelevant. But it's like human beings, we put this so we can know what we are dealing with. So this is a shell script, and the shell is the bash. Okay, so you don't have to put it .sh. This is completely optional. You don't have to do this. But I mean, we are basic human beings, and this makes our lives a little bit simpler to know what type of file is. So it's a text file. I just VI'd into it. I don't need to VI into this because we have discussed VI in the RH124. Go back to that. I have an entire video about editing text files where I include the VI utility and the VIM and much more. Go and check it out. And like and subscribe, it really helps. And we're going to, this is a simple text file, just VI'd into it. And that basically, the trick, it's two things. You just put this line as for your first line. This makes this a bash script because it's going to be the bash, the interpreter here. And there's another thing. We need to set up permissions, but we'll set those in a second to be an executable. So I don't have the execute permissions yet because I want to do it for you guys to see. But it's easily confirmable because usually executables show up as green. In this case, it's not. So it's just simple yellow because I chose yellow as my font color. But yeah, it does not have the executable permission, and that's fine because I'm going to set it later. So I want to show you guys how to set it or remind you guys how to set it because at this point, I highly recommend you when you go through all the videos on the RH124 so you guys can get more in depth into that. But I digress once more. So this is a text file, okay, and this text file is going to include some instructions, and you probably know some of these. Some commands here are going to cover them in this training. So on the RH134, so get subscribed to get notified. So here I'm going to do some actions in the scripts, and the following are as follows. I'm going to use the echo. We know what the echo does, but let me just do this without being inside the script. So this is going just to echo to the screen an empty line. And you should go to the RH124 training course that I just have in my playlist. This is going to echo to the screen something that is an empty line, but I'm using these two bigger than lines. I know for the English speaking people, this is not bigger than, but I like to say bigger than. So I will just keep saying bigger than. So two bigger than signs. This is going to output the output to the file on my home folder, which is called output.txt. So this means this is my home folder. Once again, to go to the 124 course to get more information about what this means. But in simple terms, this is my home folder. and it's going to be put on the file called output.txt. Okay, so as I'm starting with an empty line, I don't have to start with an empty line. I just want to create a file with some data into it. This is just cosmetics. Then I'm adding some hashtag lines. This is cosmetic. You will see what I mean when we see the final result. This is just cosmetics to make the file prettier to look at. Then I just type a header. So this is going to build a block of a header of a file, and this is going to append to the file called output.txt. And again, a new empty line. So all of this is just going to create me a header, something to be pretty to look at, to organize information. And don't underestimate the power of information organization, because this is going to make your life much, much easier in the long run. Then finally, I'll do the lsblk command, lsblk. This is going to, we are going to export this command in the RH134 training course, this video series. Like get subscribed to get notified. And this is going to output my storage information output. So instead of just putting this to the screen and losing the information, I'm actually putting this into a file that I can keep and check out later on. This one is going to make again a new header here. This is just a header to be organized. And then I'll just do the df-h. Let me show you this one. This is going to show me my free space on my storage, and this is going to be put on the file too. Okay, so this is going to generate something similar to, I can just show you guys here. This is going to generate something similar to this. This is the result. Okay, let me just put this a little bit bigger so you guys can see. So this is the content of the file. Again, I have here a header, and I have here a footer. So this is my decoration. This is going to show me what's coming next. This is my information about my block devices. This is going to show me what's coming next. This is information about my free space, and then ends with an hashtag line. So, like I said, this is decoration. That can make our life much easier and much more comfortable to actually look at. Okay, this is for visual comfort. We never underestimate visual comfort. Because it can actually make your life easier. And this is going to generate this type of file, okay, which is quite nice. Okay, so this means that we are actually getting an output or a series of commands that, instead of going out to the terminal and getting lost in time with no ways to get it back, I'm actually storing this in the file for future use. Okay, so this is a simple way to get the script going. Let's just check it out one more time. And this is kind of my header of following information, extracting information, and put it to a file. So that said, that were two things that would make a script a script. One, it's creating a text file and giving it these contents here, which is the case. And the second thing, it's making it an executable. So let me just remove this file to create a fresh one, okay? And if I look to my simple file, it's still not an executable. So one way to execute a script is to do the current folder / and the file name. This is going to execute this as a script /. And this is going to give me a permission denied. Why? Because this is not set as a script. So in order to set this as a script, I just need to give it an execute permission to the file, and now I can use it as a script. There is no output because you guys know the answer. So let me just show the script again and let you guys think about why this is not getting any output to the screen. 3, 2, 1. It's not getting an output to the screen because it's simply put, it's getting all the output to a file. So that's why I'm not seeing anything to the screen. But if I check the file where I'm outputting to, you will actually manage to see the results. So this makes these actions, maybe I have to do this every single morning to check my server storage or any other reasoning around this. So I can do this every single time. It will be very repeatable. I will not fall into syntax errors or human errors because the script will just manage to do this the same way every single time. Very nice. This is a very simple script, but you can just tailor this to your personal needs. But there is more that you can do with the script. For example, I have here a thing called simple loop. Let's check this one out. And here I'm doing a simple loop, okay? And what is this loop doing? Let's analyze this. So we are telling the system to use the bash shell, which makes sense, okay? And one thing I did not mention in the previous ones. So if you start this with the hashtag, this is a comment, which means that it's not going to be interpreted as an action to execute by the script. It's just something like notes. It's like note taking. The exception is this one because it's a shebang. It has an exclamation mark right next to it, right? So this is kind of telling the system, okay, this is not a command to execute. This is a comment. So it means that I'm stupid. The system is going to look into this and it's going to be interpreted this as a comment. This is a commentary, which means it is just for humans to read and the system will ignore this for the most part, okay? So this is me telling myself, because the next time I watch I'll read the script, I probably won't remember why did I build it. But anyways, this is telling me that I'm going to execute this script for this following for the reasoning, and this is wrong. I typed this wrong exactly, so I can force myself to edit this out for you guys to see. So this is not the action that I'm doing. So I'm going to edit this out and execute this for the I'm going to correct this because this is not the reasoning. This is going to execute ping commands for my servers. Okay. Then I just save and quit and we are done. So this script, it's pinging my servers, okay? And my servers are called Rocky1 and Rocky2. So I could just ping by the command line. I could put here a simple script, something of this sort. I'm not going to save this. I don't want to keep it, but let's call it ping.sh. I could do the shebang if I wanted to. bin/bash. I can do ping blah blah blah, ping blah blah blah, and this will do this every single time, but I want to be a little bit more fancy because I'm doing a cycle. Okay, what is a cycle? It's a for cycle. It's a loop. It's a simple loop. Why I'm doing this? Because I can do for host. This means I'm going to set a variable called host, and the contents of that variable are going to be my server names Rocky1 and Rocky2. Okay. Then I will instruct the system what to do with these set variables. So now I have two variables, Rocky1 and Rocky2. What do I do with them? I'm going to ping those variables. The symbol, the money symbol here, the dollar symbol here, means please read the contents of this variable. So I just set the variable with these two values, and this is going to extract the variable data. So in simple terms, it's going to ping Rocky1 and ping Rocky2. Pretty awesome, if you ask me. Why am I putting this C1? Because this is going to ping it once. Because if you remember, if I use the ping command in Linux, it just tends to ping forever. It's an infinite action. It's going to ping until I break. So if in a script I do not put how many times to ping, it's going to keep the ping going in the background forever. So if I run this script 40 times, I will have 80 pings going. So that's bad. So don't forget, if you are scripting or automating the ping command, don't forget to set how many pings you want to execute, or else it just keeps going forever unless you program some type of break. It's a really pain in the ass. So just don't forget to set up the amount of pings you want to execute. So this is going to ping Rocky1 once and ping Rocky2 twice, or twice in total. So one ping to Rocky1, one ping to Rocky2, and we can just see the result. So let's experiment this. So let's say let's ping simple loop.sh, and I have here one ping to Rocky1 with success. Sorry, here one ping to Rocky1 with success, and one ping to Rocky2 also with success. So I pinged Rocky1 once, and I pinged Rocky2 once too, and both of them were successful. So I'm happy with this. Of course, this can be a little bit more complicated. I can get into these situations of testing the results, if it's positive, if it was a good result or bad result. How do I do that? With the exit codes. Okay. Exit codes can be set or just interpreted. Okay, for example, I can do echo and spit out the contents of the variable $? This variable here, it's a system variable. You don't have to set it, it's set automatically. This is going to show what was the result of the previous command. So for example, if I do ping and I do something that doesn't not exist, you can see I have the resulting error code 2. If you go to the main page for the ping utility, you'll find that error code 2 means something went wrong. Number 1, it's host not found, or ping expired in transit. So there are many. You can go from exit code 0 to 255, where 0 is always success. So if I do ping Rocky1, I have success. So if I spit out the variable that registers the result of the previous command, being ping, being any other, 0 was success, which means like it was a successful command. For example, if I do an ls or a cat, in an echo, cat had no error, so error code 0. If I get a file that does not exist, the error code will be 1. So 0 is always success, and 0 is always success. You can go to 255, but what 1 means, what 2 means, what 3 means, it depends on the command itself. But anything that is not 0 is an error. So if I see 0 as a result, it means that the previous command ran successfully. But don't forget that in the script, I can set my exit code, which means every time this script runs, it's going to return as a success. Even if it was an error, it's going to return as a success. That's just an option of you guys who can just set if you want what exit code to get. But in this case, every time I run this script, it's going to return with the success command exit code. Now I can just edit this out. For example, I can do simple loop sh. I can add here something like, I don't know, and execute the script, and this is going to include a ping to the 8888. Okay, so success for Rocky1, success for Rocky, the other way around. Success for Rocky1, success for Rocky2, and success for the 8888. So I just have to add to the list, and the simple loop will include that value on the list and ping it too. This is very nice. This is very tailored, which means you can edit this out and add hosts or remove hosts, and the ping will just carry on doing its thing. You can do this for package installation to check if installation is set, it's not set, and everything else. So it's pretty great. So now you know. Let me just review this. You know how to do a simple script, which is basically put on the text file some common actions. Then you can do a simple loop with the for. With the for command, for this, do this. Pretty simple, and it is very useful for the most part. And or you can also do more. For that, let's just do this in a more theoretical fashion. I don't know why my screen is not getting captured. Oh, sorry. Oh God, I want this one, man. Let me just see why this is not working as expected. Okay, it's fixed now. There we go. So here I have some other examples of things you can put on the script. For example, these are all bash things. Bash can do this. There is no need to install anything else. You can do this directly on the command line, or you can put this in the script format. So here I have some tests. Test means it's going to compare some values. It's a test command. And here we are just checking the end result. So greater than, if this is greater than, then it returns a 0. If it's not, it returns a 1, which means that 1 is greater than 0. Let me just clear this out. So basically, is 1 greater than 0? Yes, so no errors. Is 0 greater than 1? No, so it returns with a quote-unquote error. You can also do the same thing with square brackets. You can just do similar things with square brackets. You can compare strings. This is all bash stuff. This is nothing that you need to install. You don't need to install this. It's there for in the bash system for the longest time. Okay, and you also can use what we call the else's, the if then else sequence. I'm just going to mention this really briefly because this is not really needed for the EX200 course. A simple script, it's fine. You may get away with you may need a for cycle, maybe, but I don't see it being really needed. But you can just check this out in your own spare time. So this is an if. An if it can be useful if you want to compare stuff, if you want to test stuff even further. So in this case, I'm doing something really simple. In this case, I'm using the systemctl to test if a service is active. If you don't know what the systemctl is or how it works, go and check out my RH134 playlist and like and subscribe there. So I'm just trying to see if the service is active or not. And I'm going to output all the outputs to add to the dev null. So I don't want this command to produce any output, just the error code. Okay. Then I'm testing to see if the error code is different than 0. Because, you know, if it's 0, it's going to be a success. If it's different than 0, it's a non-success. Okay. So, which means that if it's started, let it stay started. If it's not started, stop it. I know it's kind of dumb, but it's just an example. So this is going to test if the service is started, let it be. If it stopped, start it. I mean, it's kind of dumb. So if it starts, stop. If it stops, start. I know it's a little bit dumb, but it's just an example. So again, I'm testing to see if the service is active or not. Okay. If it's started, stop it. If it stopped, start it. It's kind of a dumb thing, but it is what it is. In this case, I'm testing multiple systems because I'm testing to see if MariaDB is installed or is active in this case, and Postgre if it's active. Since this I run the command twice. I'm setting the variable of the error code, of the exit code in a variable. So the execute variable for MariaDB it's set on a variable called MariaDB, and the exit code of the Postgres is set on a Postgres variable. So basically what I'm doing here is comparing. So if MariaDB is active, then it means that MariaDB is what installed. So if the MariaDB is active, then start MariaDB. If it's not MariaDB, it's MySQL. If it's not MySQL, it means that it's SQLite. So as you can see, these are the 3 most common flavors of databases in Linux: MySQL, Postgres, MariaDB, or SQLite. So these are kind of the most common flavors. But here I can test to see, okay, if it's one, then I'm just testing to see which services are active, and if they are active, then install them. So I just start over the active state or inactive state of each service. Then I can start the service, trying to guess which one is installed. Well, it's kind of again a little bit very simplistic, but it works. So if it's MariaDB, then start it. If it's Postgre, then start it. If it's not MariaDB nor Postgres, then must be SQLite and start SQLite. So it's kind of a dumb thing, but it works. So it's a way to get things done and get things working. So if you want to go back, that camera there. So if you want to go back to this last part and rewatch it or pause the video, I highly recommend. But to get ready for the RX200, just go back to my simple scripts and my simple loop, and you should be pretty good to go. Just to finish up this chapter here, let's just discuss a little bit of regular expressions in a very, very simple manner, because I'm going to be using and reusing regular expressions a lot throughout. So I'm going to be using it a lot. So let's just introduce this. So in the end of the video is going a little bit long now. So very simply put, regular expressions are ways to find a pattern in a very big mess. So in Linux, what is a mess? Well, text files are a very big mess. So in Linux, text files can be very messy. So what we're going to do here is going to be using we're going to use regular expressions to find a pattern in some mess. For example, let's check the simple script. It can be any text file really. So let's say I want to find this, for example, this word here, okay? What I can do, there are many ways to get this, but the way I do it is, one way to do it, is to get the file and redirect the output to the grep utility. The grep utility is one of many utilities that can deal or use regular expressions, okay? If you don't know what this output redirection means, go back to my playlist on the RH134, check it out. I have a whole chapter about this, and go and check it out and you can get more details. But basically, I'm getting the output of this file into the grep utility. Now I can use regular expressions. Regular expressions are a way to find patterns in chaos, especially in text. So, I'm sorry. So the easiest way to do this is, for example, I want to find the word bash. I just type bash. Pretty simple. Okay, and now I can see that bash it shows up in 2 different lines in the same file. That's basically it. Of course, regular expressions can get really complicated really fast, but I will not get into much details about regular expressions for 2 reasons. First, I'm going to be using it a lot throughout this training session, throughout this playlist of the RH134, and it's something that is just going to happen. So I don't need to be too much detailed at this chapter yet. We can leave it for the chapters in a more natural form. Okay. So don't forget that regular expressions are also case sensitive. So if I do this, it will not find it unless, and this is a grep thing, a grep nice thing to have. I can do -I, which means case insensitive. Okay. So if you do the -I on bash, it's going to be a case insensitive search. So it doesn't matter the case, this is uppercase or lowercase. And another thing I like to do is when I do this, see, I can see that he found bash in 2 different situations, but neither of these 2, it's very obvious because he just found something in the big mess. So what I like to do is I do this and I do print the previous 3 lines. Sorry, the next 3 lines and the before 3 lines. Okay, this is going to be print what you found. Okay, but also print the previous 3 lines. I'm sorry, the previous 3. I said 3 and type 2. The previous 3 and the before 3 and after 3. So the previous 3 lines and the after 3 lines, which means it's going to give me some context about where this found. In this case, they are just one next to the other, which is, well, it is what it is. Let's use another file. For example, this guy here. Let's find for the word Rocky 2. For example, let's just do a simple like this, Rocky 2. There we go. I did it. Of course, I'm just getting the wrong file. So let's get the correct file. And this one here. You found Rocky 2 here, but if I tell him, okay, print me the previous 2 lines and the after 2 lines. Now here I have some context. Oh, okay, so you found it here, and the context is as follows. So by printing the previous lines and the next lines, I can actually see whereabouts the actual file or the actual keyword that I found is at. So I can get some context, or instead of being just a random word on a random file location, okay, I just get some context about where was this found, and at least for my mind, it's going to make things more easy to read. Sorry. You don't have to do the cat pipe. You can just grab the file directly. So this is not, there is no right or wrong. This is just a matter of comfort. Okay, there is no right or wrong. I like to do the cat's grep. I like to do it because that's the way I've been doing for years now. But you can grab the file directly. You just grep your pattern and then the file to grabs, and there you go. It's exactly the same thing. No problem. You can do the same thing, and you don't have to do the cat pipe. So one way or the other, it's fine. Never mind this one. I did a typo. The file it's in the end, but you can do the redirects or grep directly, and you should be good to go. There are many other grep things you can grep. but we will discuss more regular expressions as we go along. No needs to spend all the poker chips on at this phase. We will do it as we go along on this RH134. Let's jump in immediately to our terminal, and this is what we're going to work with. So just to keep things a little bit as a summary, we are going to discuss, well, a few tools. Let's discuss first the AT utility, then the cron tab utility, and last but not least, you're going to talk about a little bit of systemd timers. Okay, so this is going to discuss here in this chapter, and this is going to be the AT utility, the cron tab utility, and the systemd utility timers. Then these are the three main subjects of this chapter. As always, as I always recommend, don't forget to test this out yourselves. Don't forget to experiment with this. Don't forget to open your terminals and do your thing and test all of this out yourselves, because it's all about experimentation to get ready, and get ready not only for the exam, but also for your day-to-day life and tasks. So let's start with the AT command. So the AT or AT, you can call it one of the two. So AT because it's an A and a T, of course, or the AT because at a specific time. So when you are telling the time, you say at. Okay. What? Okay, cool. So AT because it's an A and a T, and at because when you are telling the time at a specific time. So you can leverage the meaning, whatever the meaning, or the best way you think you can. But this is the AT command and the at command. This is call it whatever you want to call it. So the AT command, it's a very simple command, but that does not mean it's not interesting or useful. It's just very simple to use. For example, let's say I want to run the command today at 4 o'clock. So at let's say 1600. Well, you can first things first. Let's go to the AT command man page, which means that you can go here. It has a few examples. Let's see if I can find. It doesn't have examples. Well, this man page does not have example, but it usually does have an example, several examples. But it's okay. You can check this out, this section around here, more or less, or well, somewhere around this section. You can well, it doesn't have an example section, but around this zone here, you can get some ideas on how you can use it. So, for example, it's a very simple way to use it, because you can actually use simple English terms in a way. So, for example, you can say at 1800. Let's use an example directly from the main page, just to make everybody's lives a little bit simpler. So then you can just go crazy. So let's say at 1 p.m. today, or you can even simply put tell the time. So let's see what time it is in my server. Time date CTL. This means that we are, well, it's the correct time. Cool. So let's say at. Let's put this in a few seconds ahead. And we can let's just touch hello from at in my home folder. Am I going to be I'm being too slow? Let's just do hello. Control D. And I'm never mind. I just typed up a time in the past, so it's going to happen tomorrow. That's what it's telling me. February 4th is tomorrow. So let's put this at the 39-minute mark. Let's put today, even though it's not necessary. Let's say touch. Let's call this at.file. Oh god damn it. Let's start this again. Let's say AT was here. Control D to actually schedule this at today at the 39-minute mark. So if you do ATQ, you can actually see the queue, the literal queue. So tomorrow, this is the one I just created by accident, and this is going to be run today at the 39-minute mark. So let's check what time it is. We are almost there, so let's just wait a few seconds, and hopefully it will just run. It's going to run now. Okay, AT was here. So the AT command, and if I go to the ATQ, it should be gone. The one that was executed successfully, it's gone. Oh, sorry. I can do the TRM to remove that that job. I didn't have to remove it. I didn't have to remove it. I just did, so I can see how it's done. So it's a very simple command. You can also use things like, for example, AT at tea time. Today at tea time. I don't have to put today because it's by default. We can just do again touch tea at time. Control D, and it's going to be scheduled for 4 o'clock. So tea time, it's usually 4 o'clock, right? So if there are any British people watching this, tea time is usually at 4 o'clock. Am I right? I may be wrong, but AT thinks that tea time is at 4 o'clock, and we're not going to argue with AT, are we? So at tea time is going to be. You can also have at noon. Not noot. At noon. Let's do to touch. Hello. Control D, and it's at noon. It's going to be at noon, which is midday. So with AT, you can actually do things like this. You can easily use a simple language, right? You don't have noon tea time. That's simple English, which means that you can actually almost talk to AT like a person, and he can understand for the most part. So ATQ, there you have it. Let's remove the ones you don't want to. ATRM, remove 3. ATRM, remove 4. And we should be good to go with that, which means that our queue should be now gone. So yeah, AT, it's a very, I'm going to say this, but don't take this the wrong way. So AT, it's an older utility, but it does not mean it's less good. So even though it's older, it has its use. And if probably some of you guys are wondering, is this going to survive reboots? And yes, this is going to survive reboots. Okay, which means it's a permanent action, which means that everything I schedule with AT is going to be kept permanent, which means that I can reboot the server and the scheduled tasks are going to be kept. No, I don't have to be root to schedule AT stuff. I'm just using root because I was logged in as root, so I stick with it. You can schedule tasks with non-root users, but of course the non-root users are limited to what they can do using the non-root user, right? But they can schedule their own things. They can schedule their own tasks and with their own accounts. So they have limited possibilities of actions that they can do with those accounts. But that's kind of a given. But they can schedule their own tasks even though they are not root. The next one, it's a cron tab utility. The cron tab utility, it's an utility. It's a little bit more fancy, okay? Because the AT utility, it's also called the one-off utility, which means that you can create one-off tasks, which means that it's a little bit harder, even though it's not impossible, it's a little bit more harder to create reoccurring tasks. So everyday tasks, every hour tasks, every 5-second tasks. So with the AT command, it's a little bit harder to do so, but the cron tab exists exactly for that. So the cron tab utility is going to be used to create more reoccurring tasks. I keep forgetting which camera I'm on, so I'm here now. So you can actually, with the cron tab utility, it's easier to create recurring tasks. With the AT command, it's also possible, but it's a little bit harder to create recurring tasks. But with the cron type utility, you can actually create recurring tasks more easily. So this is I'm going to show you how a little cheat to remember yourself how to use a cron type utility. So first, we're going to check a file called etc cron tab. I will come back to this file in a few seconds, but for now, let's just use this file to have a little bit of a sheet. How can you schedule tasks using cron tab? You'll understand this a little bit better in a few minutes. Just play along with me. So I'm going to get this information. I'm going to highlight it. Then let's say I want to create a task using the root user. I'm using the root user, but you don't have to be root to create these cron tab tasks. It can be any user. So let's do cron tab -e, for example. And the first thing I will do is to paste this header here. I know it's not very visible with my color scheme, but it's going to be the header. Just put your screen a little bit brighter. I can get this out a little bit. So I'm going to remove this part here, username, and I'm going to write and quit, and I'm going to basically cut the file I just saved, and the file is saved at etc spool. I'm sorry, the other way around. Not etc. Jesus, var spool cron root. So this is the file that I saved using the cron tab. So basically the cron tab utility allows me to program the schedules to be used with cron tab. This is going to allow me to schedule the cron tab schedule. And when I save it, and I do the write and quit, it's going to save a file here, okay? And it's going to get the name of the user that saved the file. So if it was the student user that saved the file, it will be var spool cron student and so forth. So this is my cron file now. It's still a little bit sad because it has only this commentary, but this commentary is going to be kept there, so I know how can I build my future tasks. Okay, so basically this is going to explain the syntax on how the cron tab works, or the cron tab utility, or the cron tab system works. Yes, I can go to the main page. I can go to the main page and get and extract that information. Yes, I can, and I will, but this is going to make my life simpler for the long run. So the first parameter I will put is when to run in terms of the minutes. The next one when to run in terms of the hours. The next one when to run in terms of day of the month. The next one and when to run the month itself, and the day of the week if needed. You can say the minutes in numerical fashion, which makes sense. You can say the months in like this, which also makes sense. Or you can say the days of the week like this, or with the days. So take your pick of which one you prefer. It's the same thing. So let's just create a task for today. So let's go back to the time date CTL. And so it's a minute 40. Let's put this for the minute 49. Okay. So to see if we have time. So since he's telling me this is what minute to run, which means I'm going to put this running at a minute 49 minutes. It's at the top of the hour, the 10 hour. Day of the month, I don't have to put it in because it's going to be run today, but today it's the 3rd, just to make things a little bit more interesting, of February. And the day of the week, I just don't care. It's just whatever the case. Let's put the star here. And there we go. And then we'll just finish up with the command to run. So I can put the free command just to check the free space on my hard drives. So it's just a matter of just following along. Which minute, what hour, day of the month, which month, day of the week if you want to, or just say whatever the day it is, and a command. That's fine. So I still say we still have some seconds to spare. So I can also do something like this. This will going to tell the system to run this every 5 minutes. And I'm going to tell it between 10 and 11 every day. I'm just making things as I go along the free command. So this is going to run the free commands between 10 and 11 every 5 minutes. Okay. So I'm going to save this. And a good thing to know about the cron type utility is that if I try to save, but there is some syntax errors, I will not be able to save. So the cron type .e is only going to save if the file is healthy. It's only going to save if there are no syntax errors on the file, which means that this file is good to go, because if it had an error, it will just be reported. So right now, all we have to do is wait for the minute 49 to make sure that things just went smoothly. While we wait, basically you can discuss the original file. I lost it. Let's type this again. So etc cron tab. So the difference between the etc cron tab file and the cron tab, the regular cron tab, is that you can see here I need to specify a username to execute the task. So the cron tab -e is going to create that farspool cron file, and this is considered the user's cron table. So usually it's reserved for the user to execute its own personal stuff, and this file here is going to be used for the system stuff. So the cron tab -e is going to be used for the user to run its own personal stuff, not quite system stuff, even though root could do that with his own account. But to keep things separate, one thing is for the root account to run stuff, other thing is for the system to keep himself healthy. It's the etc cron tab file. So in the etc cron tab file, the syntax is the same. It's basically the same service. It's the cron service checking this out. But you can put here a username, which means that this task is going to be run with the different user's context, not the root user, if you prefer that. Okay? So usually this file is used for system stuff to keep the system running, and the cron tab -e is going to be used for the personal stuff for the personal user. And yes, of course, root is entitled to do that for himself, which is also fine and dandy. So etc cron tab -e is going to be for personal stuff. You can work around this with the root user, of course you can. And the cron tab -e, or the etc cron tab, sorry, is going to be for system stuff. So now you have two ways to schedule your tasks. The AT, it's kind of the most traditional way in terms of age. It's a more aging tool, still good enough for some tasks. And the cron tab, it's more tailored to get things running at with reoccurrence every 5 seconds, every half an hour, a specific day, a specific date, etc., etc., etc. There are some macros that you can use. Let me see if I can find them really quick. Let me see if I can find them. It's somewhere in the man pages, maybe on the 5. Let's see. Yeah, there it is. Okay. This is also how can you get remind yourself how to build a file, even though I think the trick of checking the etc cron tab file actually works great. And you also have some macros that you can use. I think they are somewhere around here. Yeah, they are there. They are. These macros mean a specific point in time. So after every reboot, once a year, January, usually the 1st January, at annually, which is kind of the similar approach, at monthly, at weekly, at daily, and hourly. So you can actually do at hourly, and it will be run at the top of the hour every hour, at daily every day at midnight. So you don't have to type this out yourself. You can, there's no harm doing on that, but you can just type your macros like this, and it's pre-programmed to work, to behave like this. So you can type it yourself or use the macros for your own benefit. You can just use the one or the other. So the AT, it's a more simple tool, but still yet it can have its uses. And then you also have the cron tab, which is better for reoccurrence and things to occur at a certain frequency. It's easier to do that with the cron tab than it is with the AT command, and you should be good to go. Last but not least, something I will reference in a more shorter fashion, because I just want to reference for you guys to know that it exists. I will not dive too much into it because it's not the time to do so. And if you can make yourselves really good and fine with the AT and cron tab. The other one is the systemd tempd. Let me see if I can just quickly show you. So let's try to investigate the etc. For example, dtc temp the files, and for example, well, you don't have to cat it. Let's cd into it. Okay, so basically this has no much things. So let's go to the usrlib. I don't like to go to the usrlib that much, but let's dive into it because it's a very simple installation. Now there should be a bunch of files here. So basically this is not the AT, this is not the cron tab, this is a systemd system embedded recurrence mechanism. If you don't know who systemd is, go back to my RH134 playlist and check more details there. But basically systemd is kind of our master process that keeps the system running. And one of the tasks it does to keep the system running is to manage temporary things with a cycle. Okay, so let's check just as an example the tmp. If you are old enough, you probably remember an executable called tempwatch, tmp watch. It's kind of a cousin of logwatch. What this script used to do was to keep an eye on the temp and vartemp folders to avoid that them don't get overflowed. That script is, even though it still exists, it's not used by default because systemd is now doing its job. And by doing that, I can see here two parameters that is kind of checking the presence of the two most customary temporary folders, the /temp and vartemp. What it's going to do here, it's going to create the folders if they do not exist, and they're going to clean the folders in the case of the vartemp. In case of the /temp, it's going to clean them every 10 days, and in the case of the vartemp, it's going to clean them every 30 days. So just check it out, this folder yourself in your own time, and just tap in all the conf files there, and you see that there are many things happening in the background that you actually don't really need to temper them ourselves. It's here, they are here for a reason. I rarely touch these files. I think I had touched them a couple of times outside training, of course, because the defaults usually are pretty good enough. They do their job. Maybe you need to kind of tweak a little bit how more or less frequency in terms of checking how big the folders are and cleaning them, but usually that's the case. But what I want you guys to retain here is that right now, for the longest time we had the AT and the cron tab. Now we have AT, cron tab, and systemd temp files. Systemd temp files is slowly creeping in and becoming the norm, but still far from that. So for now, if you want to create your own schedule tasks, stick with AT or cron tab. If you want, and leave the systemd temp files to do its thing. It does its thing very nicely, and it's great. So just train yourselves with the AT and the cron tab. You'll be perfectly good to go. Just take a quick gander at the systemd temp files so you don't find it too strange if you want to run with them. But AT and cron tab, it's the way to go to get your system up and running and keep things under control, and to get your scheduled tasks up and running. So let's jump right in. So basically nowadays we have two ways to check our logs, to facilities, to authors, to mechanisms, to whatever services, if you prefer to call it like that. You have the traditional and the one that's been with us for the longest time, which is the system, kind of the de facto standard in a way, which is the syslogd. And what do you mean by that? So you know this for sure. You go to the varlog folder. You go to the varlog folder and you find all of these files. For example, you have the just these type things. I've just blah 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 blah. You have the varlog messages file. It's one of the many files you can check in this folder location. You have the messages, you have the cron tab, spooler, whatever. And for the longest time, this been like this. So you have here when the event occurred, the machine name, the event writer, the author, and you have here the process ID of that process. Okay, so that's been like this for the longest time. Now it's a good opportunity for you guys to use the grep utility to get that going, and that's pretty standard, man. You just know, appreciate, and understand these file locations and how it works, and everything is just pretty great. How are the files written down here? Who is putting the files here? Well, it's the systemd service. Let's gander all together on the config file. So etc syslogd. I'm sorry, it's called rsyslogd.conf. So there was a switch from syslogd to rsyslogd. This switch happened more than 10 years ago, but I'm still there, you know what I mean? So let's go into that. I'm not going to bother you much with many details, just, you know, for you guys to understand how this works and you have success in your exam. So let's go here to this section called rules. Okay, let's go to the rules section, and this is going to contain, guess what? Yeah, rules. So these rules are going to tell or instruct the rsyslogd service where to put the files and why. So in here you can check, you can see you have two pieces of information. You have one piece of information and two pieces of information. These are called facility and severities. Let me get that information for you guys. I'm just opening a Google page. So facility and severity syslog. And there is a Wikipedia article that you can check out, and Shazam. So if you go to I just Googled for it, you can find it anywhere. But this page and Wikipedia, it's worth what it's worth. So I'm just going to show you guys a couple examples. Let's check the severity first. So if I go here, you see that you have here something that is called info, for example. Other examples can be like emerge, crit. What does this mean? Well, every syslog message is categorized. This has a category, English, that is going to tell us the level of importance, in a way, of the message. You can go from 0 to 7, obviously. 0 is emergency, 1 is alert, 2 is critical, 3 is error, 4 is warning, 5 is notification, 6 is informational set, 7 is debug. So 0 emergency, 1 alert, 2 critical, 3 error, 4 warning, 5 notification, 6 informational, 7 it's debug. So this is going to allow us and the application and the service to give a category to the information, to the level of seriousness, in a way, of the information. Emergency is really bad. Notice is just informational. 6 is information. 7 is just information. So I would say that anything below 4 requires attention. Anything above 4, it's just for information's sake. So that's exactly what this means. It means that emergency messages are going to hear. This means everywhere, every telnet session, every SSH session, every console session, everywhere. And now you kind of get the gist of it. So this is where the files are getting written down to, where, and the type of category it has. So every informational message is going to do messages. Every mail related, because the left-hand side refers to the facility, and the facility is the author of the message. Here I have some examples: kernel, user, mail daemons, and some customizable stuff. So don't forget something. I don't think I said that, so I say it now. Syslog, it's a very standard logging facility or logging mechanism. It's syslog, it's the same for Cisco, Microsoft, whatever the case, Linux, blah, blah, blah. So for example, for Linux, 4 is a warning. For Cisco, 4 is also a warning, and so on and so forth. So this means the same for any vendor. So all of this means the same whatever the vendor is using it. Here, there's some flexibility of the author. but it's always the same thing. When you see a syslog message, it's the author dot the importance level, severity level, which means that these type of messages are going there, these type are going there, these type are going there, etc., etc., etc. So mail messages are going there, cron messages are going there, emergency messages are going everywhere, and critical messages are going there, and all of that good stuff. So they can go to 2 different files. So everything goes to the messages, but except the criticals that go to a different file. You can tailor this as your liking. You can tailor this as many times and as detailedly as you wish. Do I touch this very often? Actually not. No. I think at the production level, I think I touched this a couple of times. Just something really specific to something. I don't remember what it was in detail, but because syslog is also an internal mechanism. Okay, syslog is also an internal thing, which means that a service can write to a log internally or through the kernel. So it doesn't have to actually have something written down in this file to be able to write log files through syslog. So I think I have touched this a couple of times in production. The defaults usually are pretty decent and pretty good to go. All right, pretty simple stuff. I rarely or ever touch it, but I will show you a couple of things that can be interesting. For example, syslog allows us to write through the network, which means that I can write to a remote server. I mean, for example, this is my Rocky 1 server, and I can write this to Rocky 2. Let's do it the other way around. We have not used Rocky 2 all that much, have we? So let's go to Rocky 2. Let's get ourselves some root privileges. Of course, I mistyped the password the first time I tried to write it down. Cool. And now I am on the Rocky 2 server, and let me just set up my Rocky 2 server so that every syslog messages is copied through the network to Rocky 1. And the procedure is done as follows. So I'm going to the same file. This I don't have VIM installed on Rocky 2, which is fine. And if you go to the very end, this is not correct. This is not the correct configuration. But you have open a line. You don't have to put it in the end. You don't have to put it in the end. I just like to put it in the end because I'm like that. So let's create a common firewall reference, remote logging. You don't have to do this. This is just for comfort. Okay. And now this is what we do. We're going to put, for example, star.star. All information, all severities and all facilities are going to be copied to Rocky 1. I could be a little bit more care and more detail about this, but I'm going to send everything that I can just to make things a little bit simpler. Then you can have a 1 @ or 2 @ I'm going to put this as a comment. 2 @ is a TCP connection. If you put 1 @ come on, it's a UDP connection. And if you don't know what TCP and UDP is, TCP it's a reliable connection. UDP it's a non-reliable connection. And since this has little to no cost in my systems, I'm going to use TCP. It's fine. Then I'm going to type in my host, the other one, the Rocky 1's host name, and I'm going to type in the TCP port 514 is the default one. Okay, so this basically means that Rocky 2 is going to send all facilities in all severities to the Rocky 1 server through port TCP, TCP 414. All right, that's as simple as that. Very simple configuration. And I'm going to write and quit out of this. Now I'm going to the Rocky 1, which is the receiving server. On the receiving server, I'm going to find the section that's called let me see. There you have this one here. Provides TCP syslog reception. I'm going to uncomment these 2 lines. These are going to enable receiving of remote syslog connection. So Rocky1 is writing to, Rocky2 is writing to Rocky1. Rocky2 is, I'm telling Rocky2 to write to Rocky1, and Rocky1 is accepting those connections. Now I'm going to write and going to quit. I'm just going to ping Rocky1 just to make sure that the network it's okay. I know it is, but you never know. So Rocky1, yeah, everything is pinging fine. Now, since I have changed configuration file on both servers, I need to restart the service to apply the changes. So systemctl restart rsyslog. Oops, sorry. There's a queue there. I don't know why. Cool. So systemctl restart rsyslog. I don't have autocomplete on Rocky2. That's why I'm not being able to complete with the tab key, which is fine. So they are both restarted, which means that I'm telling Rocky2 to write to Rocky1, and I told Rocky1 to accept connections from Rocky2. So I didn't say Rocky2 specifically. I said just accept connections, and that's fine. I could if I wanted to, but I'm not. I'm accepting connections from everywhere else, which means let's check the varlog messages. So the last message is this one, blah 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 blah. I don't know. I don't care. So let's force a new logging line with the tool called logger. I'm going to say hi there. The logger utility is going to write logs. Okay. Sorry. So the logger is going to force a log entry, and by default it's informational. That's why it's going to messages. And getting this message is cannot connect new route to host, which means that I'm writing to my local file, but it's impossible for me to write to the remote file. I'm unable to connect to my remote syslog server. All right, and having this connection, which means that I will not see a Rocky2 var log messages. I'm not seeing the hi from Rocky2, but there's an explanation, no route to hosts. So Rocky2 is giving me an error saying that I cannot connect to Rocky1 with the no route to host message. So I'm going to give you guys a few seconds if you want to do that, or else just fast forward to the solution. You can just think about what you think is causing this no route to host. Okay, what do you think is causing this no route to host message from Rocky2 to Rocky1? I have made the changes. Okay, I have made the changes, and I'm getting a no route to host when connecting from Rocky2 to Rocky1. So the service is trying to connect, but I'm getting a no route to host. What do you think is causing this? All right, let me share with you the solution. It's the firewall system. So let's go to firewall cmd minus list all zones. You have seen firewall in the previous chapter, so go there and go to RH134, like and subscribe, and see what I'm doing this. I'm grabbing the public, and I'm going to do the before, the after. Let's go before 10, after 10 to get the context. And I don't see the Firewall for TCP port enabled, so let's do firewall cmd minus add port 514 TCP permanent, and reload. Firewall cmd minus reload. There we go. Let's try this. Let's see if we can get anything. And there we go. I typed hi there from Rocky2, and on Rocky1 I see the hi there message. Now most messages that are getting written down to Rocky2 system folder are getting copied to Rocky1 system folder, or log folder, better said, sorry. Which means that if something is to happen to Rocky2, if something wrong happens to Rocky2 and he dies, I have a full copy in Rocky1. Now, we can tailor this a little bit better. It can go to a separate folder, yeah, this can be worked for to be more efficient. Yes, we can, but I will just leave it as that. Now you know how Rocky1 or the other way around, you can mirror this configuration and they get kind of a cooperation going between the two. And so if one server dies, you have a copy of the system logs on the other server. So you are actually, it's actually nice to have a copy of the log files on a different physical server, so you can actually recover the log files and see what causes the issue in a different server. All right. Nowadays, you also have a thing called systemd log files. So let's use a tool called journalctl. Journalctl is going to show me also a similar syslog, rsyslog system log. It uses the same facilities and severities, but it's written down, it's maintained by a different service. This is not maintained by the rsyslogd. This is maintained by the systemd himself. Okay, so which means that it's a different architecture, a different thing getting the log files. They are getting written down to the run log journal folder. I'm sorry, which means that this utility, it's getting its information from here, not from here. Okay, so basically we have two people now writing and showing us logs. You have the systemd log files and you have the rsyslogd. We have these two guys doing that for us. Okay, so they should have similar information, but getting written down by two different facilities. rsyslogd writes down here, and they are simple text files that have been with us for the longest time. All is fine, all is great, all is dandy. Okay, but rsyslogd now, which is part of the syslogd subsystem, it has its own logging scenario, or his own logging stuff. Okay, the thing is, these files that are written down here are not text files. Okay, this is not a text file. This is a binary file because it was, or it's being maintained by the systemd, and because the reason is this tool here, it's much more effective than the text files. For example, here I'm searching for every message that has severity level 5 or 4 or 3 or 2 or 1. Good thing we don't see 2s or 1s, because if you remember, they were kind of the critical ones. But this is a binary file. This file is binary because it's tailored to be very searchable. Very searchable. Okay? While the other ones that are on a var log message folder, for example, are text files. Very hard. I'm sorry, not this one. Where is it? This one. These files are text files, which means they are very hard to search and to use as a baseline for searching stuff. You can use grep, awk, and all of that stuff, yes, but it's very hard to to find a thing or occurrence in a text file. While the other ones, the ones that are maintained by the journal, are binary, which means they are formatted to be searched. For example, searching is just an option of other things. So even though they are binary, which means they cannot be edited or manipulated by text utilities, they are very optimized to be searchable. Okay, so at this point you have the choice to use either one or the other. You are good to go. You are fine. You are okay. There is there's a possibility that our text files are going to be replaced completely by the binary ones, but at this point are just rumors, but it may happen in the future, maybe on the next 15 years or so, something like that. I think to be noticed, they're going to make this in a format of a question. By looking at the location of this file, if you went through the RH124 course, you should remember this. If you don't, go and check it out, the whole playlist, and come back here. And of course, like and subscribe. You check this out here. By being on the run folder, what idea does this gives you? By being on the run folder, what this gives you as an idea? What you think it can be a possible consequence by being on the run folder? 3, 2, 1. By being on the run folder, it means that the run folder is cleared on every reboot, which means that the systemd log files are getting, the binary ones, are getting deleted and recreated in every reboot. So every reboot will cause a rewrite of the run folder. Every reboot will cause a rewrite of the run folder. Okay? Which means that it's a new fresh log every time. You don't have it can be configured to be permanent, to be written down to the varlog message, not the message, sorry. It can be configured to be written down to the varlog folder to be permanent. I will not show you this because it's just a procedure. You would go to a file and swap some values and you are done. I will put this in the description down below so you can keep it as a reference. But you can get the systemd log file to be permanent if you wish, and it will survive every reboot. But the most common action to do it nowadays for the most common system admins is that we will stick with the text files for more long term, and for immediate search we do the systemd journald, but that's just me. I will put the procedure down below. You can follow it along. It's pretty simple, and you have a permanent log file also on the journald, systemd log files. That's quite enough. Yep. So let's jump into the console here, like you already know. And we have here the usual suspects. And we're going to set up here a time synchronization. What I mean by this is we're going to, let's go to Rocky 2 because Rocky 2 doesn't have enough love. It's always Rocky 1 to have the highlight. So let's focus here on Rocky 2. This will work just as fine in Rocky 1. And what we are going to do here is we're going to make sure that Rocky 2 or Rocky 1 will be the same thing. If I remember, I will also do Rocky 1. So we're going to set, I'm sorry, here we go. I'm just doing a Google search. I should have done this before the video, but I forgot. Okay, then here we go. Okay, I have all I need right now. So we're going to make sure that Rocky 2 can get its most accurate time from an NTP server, and NTP means Network Time Protocol. So this is, I mistyped it, protocol. So I'm not going to be very detailed about what NTP is or what NTP is used for, but NTP is used to maintaining an accurate time. So it's a network protocol that will make it possible so that a client can get its time from a server, so that the client is always with this time accurate, hence the name, maintaining an accurate time or maintain an accurate time. So I'm going to make sure that Rocky 2 is going to get informed about what time it is from an NTP server. So this makes sure that Rocky 2 has its current time correct. And the other thing is, if every server in my network it's getting it's obtaining its time from the same MTP server, it means that everybody gets it has the same time. So the logging and the automated things, the program things, the AT things, the cron things. So the logs on Rocky 2, if they say it happened at 2 o'clock in the afternoon, In Rocky 1, it says it was at 2 o'clock in the afternoon. It's the same 2 o'clock. So everybody has its time synchronized, which means all the events are synchronized, are they being events log related, timing related, whatever the case may be. So everybody has the same time all around. In some cases, companies or networks or whatever, they have their own private local NTP servers. That's actually recommended for some situations. So you have your own local NTP server to give you the correct time for your network. That's one thing you can do. But here we are going to use just an internet time, the time coming from the internet, from a public NTP server. So this is not the best way to go if you're looking for security and absolute time synchronization for the nanosecond. But if you're looking for something cheap to get your time from, you can do this. There are dozens of NTP servers on freely available that you can use. Most likely your Red Hat servers, Rocky servers, or any other servers of Linux servers for that matter, because this procedure it's the same all across the Linuxes. It's not only a Red Hat thing; it's all across the board. So most likely it comes already pre-configured for a free and assigned Linux free server. But I'm going to show you how can you do a quick procedure to change it if you want to change it. So let me get root access here, because most likely the time it's already set correctly and we are already getting an accurate time from somewhere. So let's do that first before I make any changes. So let's check and see if our time is already close enough, and if you're getting time from somewhere. So this is my recipe. So you just do time.ttl, hit enter, and think this is my current time. So this is perfectly accurate, and you can see here that we are actually getting some time from some NTP server. Okay. So see, I did zero effort, and my time is already synchronized from some server on the internet. Let's check which one it is. So let's do renice. I don't know if Rocky 2 has this installed. Yes, it's a minimal install. So sources -v, you can do this, and we can see that I'm getting time. I get my accurate time from these NTP servers. So NTP servers can follow along some sort of hierarchy. That don't bother yourself too much on the details about what NTP server is and how it works. The only thing you need to know for now, and if you are getting ready for the exam, it's just check the current NTP server and change to one NTP server they specify you to change to. So that's what we're going to do here. We do have some NTP servers already configured, but we are okay. But let's change for a specific one. So it's just, the procedure is quite simple. So on Rocky 2 or whatever server it is, you just go to a file called etc and crony.conf. You have here a line. In this case, it's my line. You are pulling the config from a pool of servers. That's why you're seeing multiple servers. So if you want to get your time from a specific server, you just need to comment this out, okay, and then just add this server. Specify which server is yours. I'm going here to use, probably if you are Portuguese like me, you know this guy here. This is one of the NTP servers from a place called Observatório de Astronomia de Lisboa. So these guys, for the longest time, they have been providing an NTP server for everybody. So let's type iburst here. You don't need to be too worried about what iburst means. iburst is just a performance tuning you can do to get your time faster. Don't worry too much about it. So now you're going to write and quit, which is nice. If you go back here, you probably see that you are still using the old configuration, because as you know at this point, at least I hope, in order to apply new configurations, you need to restart something. So this is my recipe. You just go to time.ttl. I highly advise you to set your time zone correctly. Okay, I need to specify the time zone, so I would specify. Okay, I'm specifying the one I am already at, but well, you specify the one you want. This is a minimal install, so if I had the bash completion, well, I can show you here because this is a full install. So time date, set time zone. If you have bash completion installed, you can hit the tab key twice, and you'll see all the time zones. So you don't have to memorize. But Rocky 2 does not have autocomplete. I should have installed this by this point, but I keep forgetting. So you do you. Okay. So anyways, here you have it. You can hit the tab key twice to get the list of all available time zones. You don't have to get them all memorized. But well, if you have bash completion installed, you can actually get that information using hitting the tab key twice, which is fine. Here I don't, but well, I'm sticking with the same one. Then you also do set ntp true. It's already true because it's already configured. So, but if it was not, you just set it to true. So you need to set your time zone. You set ntp true. If you want, it's to make things a little bit smoother. You can also set your time. Okay, you can also so you can just get your clock as close as possible to the correct time, just to make things smoother and faster. Just look at your watch and just get it as close as possible. Then, so NTP true, set time zone, NTP true. But if you check at this point, you are still pulling information from the old configuration. So let's just restart systemctl. Restart chronic. I really need to install. I really need to chronic. Sorry, it's chronic D, not chronic C. D for diamond or demon. I really need to install autocomplete on my Rocky 2, so I missed my tab key. So we have restarted. You can go back to the time.ctl just to make sure that everything is synchronized. It should be, and then you can just go back to chrony, the sources, and you can see that we are actually pulling the time from our newly configured NTP server. So just to make things a little summary, you go here. You can comment out what you don't want to use, what you want to keep as a memory, as a reference. You just type server and your server. Type iburst if you want. So this is a performance thingy. Don't worry, just type it out and you'll be okay. Save and quit. Set your time zone to the correct time zone. Set it to the time zone. Set your time to the correct time. Set NTP to true, like I did here. And then just restart chrony D. Where is my restart command? Come on. Come on. After you start chrony D, you just need to make sure that you are pulling your time from the correct source by doing chrony C sources minus V. And you should confirm that you are pulling the time from the server you just have configured. So that's how you call it, maintain a current time. Let me know if you have any questions. Down below. So let's go here, and I have here a challenge for you guys. You may, if you want, you can pause this if you wish to just get your bearings and try it yourselves. But the challenge is as follows for chapter 4. Using only man and minus help. Google is not allowed. Google is not allowed. Imagine how to resolve the following question, and following its I mistyped following, spelling, bam. On Rocky 1, use the tar archive and compress the home folder, okay? Use tar, I'm sorry, I cannot read. Use tar to archive and compress the home folder and its contents, okay? So use the tar utility to archive and compress the contents of the home folder on Rocky 1. Then copy all its contents. I'm sorry, and don't forget to archive and compress with the bzip2 parser. Then use either SCP or rsync. I'm going to show you both, but you can pick the one you feel more comfortable with. To securely, and how the hell I am mistyping everything so much, and securely copy the file to the VRTMP folder of Rocky 2. Okay? And then on Rocky 2, extract the file on your VRTMP. So Rocky 1 and Rocky 2 are my test subjects, my text servers, not text, my test servers, but you can just use any pair of machines to do that. They don't have to be Rocky 1 and Rocky 2, obviously. So if you want to pause this here right now and try it, then come back for me showing you how to sort this. So pause this now. And now the solution. Cool. Let's pull this to the side. Let's pull this to the side. Get things nice and ready to go. Okay. Cool. So, only blah, 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 blah. Okay. First of all, I need to go to the home folder. And now I need to use the tar utility to archive and compress. Why do I say this in 2 words? Because the tar archives, the tar does not compress. Yes, there may be a little bit of space saved, but that's for other reasons. Because the tar does not compress, the tar archives. Archiving means getting a bunch of files that are scattered around and put it in one central location. So archiving means get a bunch of files that are just scattered around and put it in the single file all together. That's why you may save some space, because I'm condensing all the files into one. But tar does not compress on its own. So that's why you need to use the busy parser to do so. So if you are going to use the tar to archive and compress, you need to have the tar utility installed and also the bzip installed at the same machine. So let's see what happens in my case. So to do so, I'm going to quickly show you the tar man page just to see it's a huge one as usual. But this is my recipe. So tar minus. Cool. So I'm going to specify here that I'm going to compress the file to be verbose. So before I do that, I forget something. Let's find for zip here, because I forget the switch. It's a -j. Okay, it's j. I keep forgetting the -j here. So let's do tar. So compress. Please be verbose. Compress with the bzip2. And I'm going to specify the file name. So this is going to create. Well, C is not compress, it's create. So I keep messing around, but whatever. Create verbose compress and file. I'm going to call it homes.tar.gz.bz2. I know that file extensions do not matter. We already know this, but it's useful for us. And I'm going to compress the home folder for. So I have a bunch of stuff because I have used Firefox. So it's, and I have also Google Chrome there, the RPM. I'll forget about that one, but that's fine. So by having there the Google Chrome thing, it's just going to delay. It's just going to delay a little bit things, but it's just a matter of time. So blah blah da da. So I have quite a few things there. I was not expecting this to be so jam-packed, but it's fine. Yeah, because I have used Firefox to browse. So, and now it's creating the file. And I should not have created the files, the busy file on the folder I am compressing. I'm just, I was not thinking too well. So this is compressing itself in a way, because I'm creating the file on the folder I am compressing, and I am creating the file. Okay, that's why it's getting this message, because it's trying to compress itself. So, but it's fine. The file is there. So don't put the resulting file on the same folder you are archiving. Don't be me. Put it somewhere else. But it's there. It's fine. LS, LA. Yeah, it's fine. Okay. First part, it's done. We have compressed. Now we need to copy it to Rocky 2. I'm going to use SCP. SCP means secure copy. And this is going to copy through the network using SSH encryption, which is quite nice. So I'm going to say copy this file to Rocky 2. And wait, since this is using SSH, I cannot use the root user because the root user is not authorized to connect through SSH to remote servers. So SSH, I'm going to try to do this like this. So I'll copy the file. I'm sorry, not this one, this one. So copy this to students at Rocky2, and put it on the var. What did I say? Var temp. I said var temp. Okay. Var tmp. Yes. Password for the students. And he's copying. So since root cannot connect through SSH, I have to use the student user. Now if I go to the var.tmp folder here, hopefully I have the file there. There it is. Copy through SCP. So second part, it's done. I have copied using I will show you rsync in a second. I have copied using SCP the file to Rocky2. It's there. Now to uncompress it, before I do, I will do tar. Let's do the ft. Ft means file, T means file, F it's file, T is test. That's okay. TF. I'm sorry. TF. What? Exiting now. You cannot exec such file directory. Okay. Okay. So basically the thing is probably on Rocky2 I don't have bzip2 installed. That's what's causing this most likely. So I'll probably have it here. Let's check. So let's do rpm. RPM. Come on. RPM. Cannot type RPM. -QA. Grep zip. And I have the bzip2 installed here. RPM. -QA. Grep zip. I do have it installed. Interesting. Oh, I have the bzip lib, so I don't have the bzip executable. So that's the reasoning. So let's install it. So dnf install bzip2 -y. Now hopefully now I can list it. There we go. We didn't have bzip2 installed on Rocky2. That's why I was not able to extract, in a way, quote unquote, extract the file, because I didn't have the parser there installed. And everything is fine. So I'm going to cancel this so I don't have to wait for it. So to uncompress, I just do tar. Okay. So I'm going to do extract. Okay. Extract the file. Let me add the V for verbose. And this is extracting. So while this extracts, because it takes a while, in this case, let me use rsync. So rsync is as easy as SCP, just to rsync. Let me put this in a different location, like let's put this in the home folder. Okay, in this case, I would advise you to put a -v, because the -v it's going to give us a verbose information, or else it's just silent. Okay, I have an error. Okay, that's also I'm glad I got this error, because this means that rsync requires to work. Rsync to work requires rsync to be installed on the origin and on the destination. Okay, so I have rsync on Rocky1. I also need rsync to be installed on Rocky2 for this to be installed to be successful. So this isn't compressed. It has a home folder, a complete replica. So dnf install -y rsync. I mistyped install, of course. Now it should work. You need to have rsync installed on both machines for it to work. It's copying it. It takes a while. It's a relatively big file, and it's copied. It's the same thing. Now if I go to the home student user folders, it's there. Pretty much the same thing. Okay, the only thing to be aware of is that for tar to unzip, you need to have bzip to xz, whatever, so you can extract, which makes sense. And for rsync to be able to copy files within two systems, it needs to be installed on both systems. That's also to be expected. So if you see any of these errors, make sure you have the zip parser installed on both machines, in this case, and also rsync installed on both machines, so that rsync can actually copy files to one another. Because I'm not going to bore you that much with rsync, but rsync has many features. For example, we can copy only files that were changed. For example, not if the file is the same, it will not copy because the file is the same. Well, I can show you. If I do something like you can do something like AVP, for example. So, okay, and I do this. He will copy it once more, just to create a kind of a checksum. But if I try it again, and the file was not changed, as you can see, it copied nothing because the file was not changed. Let's use a different example. So let's create here file1.txt. Let's put it here, change 0. And I'm going to copy not the homes file, but the file1. He will copy it, A-OK. If I type the password correctly, of course. Miracles, not today. But if I do not change it again, if I try to copy it, it did not change. But if I change the file, then it will change. It will copy it because it has it's a different file now. If I try to copy it again, it won't change. It will not copy it because the file suffered no changes. So you can copy only the files that were changed. Files that are still the same, the changes will not occur. Just take a note of my channel name and my email if you need to contact me. And we'll just progress directly to the terminal. We're going to do terminal for now, but I will draw a sketch in a second. But for now, it's okay to stick with the console for now. And I said for now quite a lot for now. So yeah, so I'm going to choose either one. This will work either in Rocky 1 or in Rocky 2. Or RedHat 1 or RedHat 2. You should know this by now if you are watching this from the beginning, and you should. Check out my playlist for the RH124 course, then progress to the RH134 course, or just pick your chapter that you prefer. That's fine by me. Just don't forget to like and subscribe because it really helps. Okay, so and also comment down below. It also all of those interactions really help the channel to grow here, and I'm counting on you to help me out. So here we're going to cover chapter 5 or the RH134, which is tuning system performance, and I'm looking down to my notes because I need to check some details. I don't have it on the top of my head, and that's just fine. Okay, I'm going to use Rocky 1 because in Rocky 2 I did not install yet the autocomplete, but I can do it now for your viewing pleasure. So let's get some root access here, and we are root, and let's go and do yum. Let's go and do provides complete. Let's see what can we get. And I get no message found. Okay, so let's do the what provides. Nothing, and I know what I want to install. Okay, but let me do this for the long way so you guys can see my possible thought process. Okay, so let's see if the complete thingamajiggy shows up. Is it installed? Did I install this already? Maybe I did on a previous video and I forget. So let's check it out. Complete. Let's search for bash. No, so let's compare this with Rocky 1. This is a possible thought process because I know Rocky 1 has the complete package installed. Let's search for bash. Completion. See, it's completion, not complete. Okay, so completion not installed. So let's go back to the what provides completion. Let's just copy paste it to make sure that we are not doing anything especially bad in terms of typing. Okay, so let's check the provides thingamajiggy. nothing. So it's a search. So let's search for completion. And we have it here. So that's one thought process you can follow along. I'll just use our own. This is how I think, and I just wanted to share it with you guys. So the nf install. Let's do the bash completion. So you can use Rocky 2 more effectively. So this is updating all my caching because you saw this message here saying no message found, blah blah blah, try specifying blah blah blah, and saying that it was saying somewhere here that our database was too old, blah blah blah. It should be fixed now. So let's go to completion. It's there. So I think now we have all the goodies that the bash completion can give us, and this may come into play. So the first thing we're going to discuss here, it's a thing called tuning profiles. And tuning profiles, I'm going to say this like this. Some of you guys that may be a little more, I don't know how to call it, but you understand what I said in a second. I'm going to say this is like the power management profiles on Windows. I know if you are maybe if you are a little more strict with your wording, you will not agree with me. That's fine. This is just tuning profiles. This is like the power profiles on Windows, like power management, full power, AMD power, blah 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 blah. All of that good stuff. I know it's slightly different. I know it's a different approach. I know that. That's fine. But it's a way for people who are a little bit less trained on Linux systems to understand a little bit better what that means. And what we're going to do here, we're going to set a thing that is similar to the profiles on Windows. Power management, no full power. I forget the exact names, but you guys know what I mean. So that's one way to see it. If you disagree with me, put it down in the comments below. This is an open discussion, and I really want to hear from you guys. But let's make sure that you have a service installed on Rocky 2 or Rocky 1, whatever you prefer, called tuned. Okay, this is the one we want to make sure that it's installed, and install it if it's not installed. So let's do dnf install tuned. It's not installed. Let's install it. Let's see. Let's just for curiosity's sake, let's see if it's installed on this one. dnf install tuned, and let's let it update all the goodies and all the stuff and blah 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 blah. It's not installed on either one. That is fine. I don't want to install it on Rocky 1. I'm going to install it on Rocky 2. Well, I'm being stubborn, am I? So let's install it on Rocky. Since it's already here, let's do it here. So this service is going to allow us to apply profiles, and this can be applied using either the command line, like I'm doing it now, or you can use it installing. You can set this up, setting with Cockpit. If you don't know what Cockpit is, go back to the RH124 my RH124 playlist. There I have a video all about Cockpit. So if you go there, it's like running remote servers or something like that, and you can check it out, that chapter, or just since you are there, check out the full playlist. Okay. But in the short version of this is that Cockpit, it's a web interface that allows us to set up a lot of things on Linux servers that have Cockpit installed, of course. So it's installed. Let's enable it. systemctl enable -- now tuned. So I don't have autocomplete running fully right now because I need to reopen my bash terminal, and I don't want to do it now, but you need to reopen the bash terminal or just kill your SSH session and reopen a new session so you can fully use the autocomplete. But I will not do this now because we are in the middle of something. Cool. So now it's installed and running. If you want to be sure, let's just make sure. So let's do status, and it's running and it's enabled, and it's all good to go. So this service allows us to enable some performance profiles that allow you to. This is going to, at least in theory, allow you to enable some profiles that will instruct the kernel to give optimum performance for a specific role. So let's do this tuned ADM list. So these are the profiles we can apply. Okay, So I'm not going to go into much of a detail about all of these because take this with a grain of salt, because the only way to know if this is actually giving you any performance benefits or if it's giving you any benefits at all, it's to enable that and see and observe. Okay. So to me, as a personal opinion, for the use cases I have had, this had little to no difference, but it doesn't hurt to experiment. So if you have the time and you are willing to invest into this, because it's going to give you more performance in theory, more power saving in theory, all of that good stuff. So if you really want to test this out and give this a chance, you should actually try that out. But the only way to know if this is going to give you personally some effect, it's to actually try it out yourself. Okay, so there is no way to know that this is going to give you some miracle results. You just need to try it out yourselves in your own application, in your own environment, and see if it actually works or if it's even worth it. Okay, so you just need to apply the profile you really want, or you can just get some more details, like for example, tundi ADM. So let's do profile info, and let's copy paste anything here. Let's put the desktop one here, just to, and you can get more details about all of this. Okay, so wow, profile description, absolutely nothing. So let's try this thing here, because these type of things show up because power saving, it's kind of a big thing nowadays, and some of these profiles may give you some results on that. So let's check my current profile. So tune the IDM. Let's go and see what active profile I have right now. It's virtual guest, which makes sense because this is a virtual machine. And let's get some more information. Profile info. Cannot type today. Okay. What did I mistype? Profile info. So, well, it is what it is. Okay. If you want to apply a different profile, let's for example apply the desktop profile. We can do tune the ADM profile. And it's applying the desktop profile. Am I sensing any big differences? No, but it is what it is. And you can do also the tune the ADM recommends. And this is going to tell you which one is the recommended one for you right now. Virtual guest. So the service itself is going to send or try to guess what is the role that this server it's performing, and it knows it's a virtual guest because it's easy to know, because this is running on a VMware platform. So it's easy to detect that this is VMware or whatever other cloud platform for the most part, and it's going to recommend you guys which one is the profile to use in your use case. So it's going to give you a recommendation of what profile you should use, and you can then apply the profile that it's recommended, and there we go. It's done, it's applied, and ready to go on the next reboot. So is this anything that could be said that it's a miracle worker? Well, actually no. The only way to make sure or to know that this is going to give you any special result or it's going to give you any benefit, it's to try it out and see for yourselves. There is no way to guess. So try it out and see what happens. So let me just get my notes back to see what's next. Oh yeah, I know what's next. I don't need my notes to do that. So the next thing I need to go and check it out, because I don't remember what is the name that they give you on the documentation. So it's called influence process scheduling. Okay. So in order to do so, we're going to discuss something called that is the nice. Okay. What is a process nice or process niceness? It's kind of a priority you can give to a process. Okay. So you probably see Jesus Christ, English. You will see this with two possible value names. You probably see it with the niceness value or the priority value. Okay, let me show you what I mean. So if I go to my top utility here, and for that I need to put my at least try. Well, let me just get the console bigger. You can see that. You can see that. So you can see here the PR and the NE, priority and niceness. Okay, so you will probably see for 99% of the time a niceness value. Okay, a niceness value. Let's focus on the niceness, then I'll discuss with you guys the PR, which means priority. Okay, and I means niceness. And for the kernel, the niceness can go from -20, 0 is kind of the middle of the road, and +19. I'm going to put the plus sign. Don't have to put the plus sign on when you are actually configuring this. I'm just putting the plus sign to make things a little bit more clear in terms of visuals. So this can go from -20 to +19, and the more negative the value, the more nice it's going to be. What does this mean to be nice? So I'm not going to give you in 30 seconds a CPU architecture course, but in simple terms, when the kernel, the Linux kernel, or any operating system's kernel for that matter, when an operating system kernel is setting how to run certain processes, it's going to have different priorities for different processes. So the kernel will prioritize himself so he can survive, obviously. Then it's going to prioritize system drivers, important stuff, and basically the user processes that what is a niceness as actions over. So user processes like Firefox and the command line, etc. It's going to be given some priority, but it's not going to be the most important thing for the kernel. So imagine this like an onion. So the middle of the onion, it's a kernel and important processes, and the more outside the onion levels you progress, the outside layers are going to have less priority in terms of kernel in terms of kernel time. Okay, this niceness is going to influence those outer layers. So don't expect to give a process a very nice priority. Don't expect it to get a very performance boost. This is not a miracle worker. This is not something to be really expecting to give it a better niceness. For example, you have a script running and you give it a niceness of -20. Don't expect that to finish in half the time. That's not what's going to happen. It's going to give it a little bit of a performance boost. It's going to be very optimistic, but just a little bit. Okay. Of course, if the system becomes very overwhelmed, and there is very high competition between the processes, you have many processes competing for one another. The ones that have better niceness are going to have a little bit of performance boost, yes, but don't expect this to be anything of sort of a miracle worker. Okay, it's not going to be like that, but it's worth a try and see if it has any results that are beneficial for you. So the range is going to be -20 to +19, and let's imagine this as going to the left and going to the right. Only root can go left. Okay, which means only root can go left. Which means, sorry, only the root user can give better priorities to a process. Okay, so for example, if I am the student user, if the default priority is 0, for the default priority, the niceness is 0, and the user gives it +10. It cannot go back to 0 again. Okay. So only root can go to the left. Regular users can only go to the right. The regular users can only go to the right. Okay, regular users can only go to the right. So let's say that put right, so which means go to more positive values. They cannot go back to better values. Which means, for example, if the student user puts an access of a process from 0 to +10, cannot go back to 0. Okay, only root can do that. Okay, so That's something to be aware of. A regular user can only, well, first of all, a regular user can only do this to its own processes, not other people's processes, but the root can do to any process, almost any process, because there are processes here that you're going to check on the top. For example, I can go back to the top utility. Let me give you some headroom here. You will see they're not very visible at this point, but if you go to the, let's, I don't know, PSOX, for example, you will see that some processes have like special markings like this one, the square brackets. This means that they are kernel processes, which means that we cannot touch these ones. Well, you can, but you should not try to, because you will break stuff and you don't want to break stuff. So the student can go nice from 0 to +10, can go back to 0, which means a regular user cannot give it better values, only worsen the values. It is what it is. There's nothing you can do about it. It is what it is. Okay? So how do I change nice's values? We have a nice and a renice command. So let's put here a process that I don't care about. Let's put sleep 1000 in the background. I mistyped sleep, of course. Okay, enough I type ps minus ef grep sleep. You see it's there. Okay, if I go to the top utility, hopefully you'll see the sleep somewhere. Oh man, the sleep utility is going to be hard to find. Let's try this again. So let's go to the main page of the PS utility. Let's try and find the nice. How is it triggered to show me the niceness value? It's %n. Let's try and get, where is, let's try and do this. Okay, I'm doing this wrongly. Let's get some examples. Or we can launch Firefox. I mean, it's okay, let's get this going. What is the trigger to okay, ps minus er. Okay, let's, and what it's the n. So let's use this as a reference. What do we get from this? I get this here. Okay, and let's, okay, process ID, let's put this on the last column. Nice, and I can just grep for sleep. See, not a big of a deal. Okay, so this has niceness of 0 because it's the last column here, and which is expected because when I launch a process without care, it's 0 for the most part. Okay, so since the process is already launched, imagine that I want sorry, I want to switch this from 0 to +10, and I am root right now, so I can do whatever I want. So let's do a renice command. Okay, let's give it a process ID and a new nice. It's not a -p. Okay. Oh my god, this is the priority of the terminal, not the sleep. This is giving you the wrong. What? 39560. Old port -20, new port 19. This is not what I want. What I'm doing wrong. Okay, -n. What? Am I stupid here? -p. Okay, let's give it p10. 19. Why? Why it's giving me the priority to the wrong process? Okay, let's try this again. -p, -n. I did it. Okay, I'm making this all wrong. What? Okay, interpreter succeeding error as a process at the default. And -n. Is it the other way around? minus P 10, and the process ID is this one here. Nope. Jesus. Minus N priority minus P. So the N is priority. Okay. Jesus Christ. Finally. I am not going to edit this out for sure, guys. Now let's go to the beginning so you guys can see what I did wrong, so you will not do it again. And my camera just died. Oh my God. What else can go wrong today? Okay. So let's go here. Okay, hopefully everything's going, no edits, guys. You know how this works. Okay. So you know that the sleep has this one, priority, and this has this process ID, and this is the new niceness. I want to change it. So you do renice, the new priority, which is 10 at this point, let's put it 15, minus P and the ID. And it's telling me that it went from 10 to 15. And there it goes. It went from 10 to 15. So again, no edits, guys. This is all for you to learn, and you learn with my mistakes. Because most views out there, everybody's perfect and do everything at first try. This is going to show you I have years, dozens of years of experience, and I still make mistakes, and this is how you fix them. Okay, so there we go. So once again, this is going to show me the process details, including its niceness. It's 15. So if I do the renice, I can change the niceness value of a process, okay, that it's running already. How? Renice, the new priority, and the process ID. And there we go. Let me put it minus 15. There we go. Now to check it out. There we go. Okay. So you are seeing this all in real time with all the real issues occurring, even the camera powering down. And that's how life works. Sometimes it goes well, but for the most part, it doesn't. Okay. So minus 15. As you can see, it's pretty easy to change the process ID, the niceness of a process when it's running. So let me get rid of this sleep process. So kill, go away. It should be gone. Now let's relaunch it. Sleep. Let's put a different value here. Go to the background. Let's get its process ID. And as you can see, it always starts as 0. This is for the most part, the default. So let's get rid of this one. Let's start now with niceness value different from 0. So let's give it minus 10. Oh, God damn it. No minus P here, just the value. So in theory, this sleep process has started with the niceness value of minus 10. So it started with 10, not minus 10. Okay, again, let's get the process ID. Let's kill it. What am I doing now? Wrong. My brain, it's minus N. Okay. Minus 10. See? Again, my brain is fried today. I don't know why, but no edits. You'll see all my mistakes and how I fix them in real time. That's you are the ones to gain with this, because you'll see the mistakes and how to fix them. So, as a review, the nice command allows you to run a command from scratch with a different niceness value with minus 10 and the value you want. Okay. If you say nothing, the default value for the niceness level, it's 0 for all running processes. You will see that some processes have higher priority by default, but that those are kernel processes and drivers and all that good stuff. You can do the renice to change the niceness value of a running process, or the nice to launch a fresh process with a different niceness value. If I go back to the top here, you'll see that we have also the priority. The priority, it's kind of a scale for only the top utility. Only the top utility will show you a priority value. What really matters is the nicest value, -20 to +19. That's what actually matters for the kernel and everything around the kernel. Okay. Top, the priority, it's an alternative scale for the top utility. That's all that is. The real values are nicest values, not priority values. I did not decide this, someone did. As you can see, this is the best nicest we can have, but the priority is not, it's 0. So it's a different scale. The priority value goes from 0 to 1, goes from 100 to 0. So, well, it is what it is. What really matters to you guys is the nicest value that goes from -20 to +19. Only worry about that thing. Priority values are just it's just something visual on the top utility. Is an alternate scale for the nicest value because someone complains and they got a different alternative scale. That's what it is. That's enough of the intro. Hello, welcome back. Welcome to chapter 6. Managing SELinux security. It's the chapter nobody wants to cover because nobody likes SELinux, and that's a fact. Like and subscribe if it helps. The channel grow. Comment down below. Everything. This really helps. And let's kick things off with SELinux. So, but I was just reviewing our test machines, and I was testing the HTTP access to Rocky 2 just to make sure that it's actually up and running, and here it is. And why do you ask? Because I'm going to use HTTP. The HTTPD server has the our test subject about SELinux, and that's why. So I'm going to focus for the time being on our secondary machine, Rocky 2, just because it's where the HTTP server is installed. So that's going to be our main focus. And in a few minutes, you will understand why Rocky 2 is my main subject and why HTTPD it's my kind of my test bed. So I'm gonna get myself some root access, and there we go. And let's just we know that it is up and running, but let's just make sure. So systemctl status HTTPD, there we go, running, enabled. We have done this before in a previous chapter about managing packages and installing services and all of that. So it's functional. So let's discuss what SELinux is. SELinux, it stands for Security Enhanced Linux, and it was built at this point in time, maybe 20 years ago already. That was built to give the Linux kernel the most desired by everybody. I think the urban myth says that it was requested in a way by the NSA. It's just a urban myth. Maybe it's true, to give the Linux kernel the kind of the security stamp of approval, blah 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 blah. It's fine. It's here with us. It's going to stick with us. And in the next few minutes, I'm going to explain to you guys how put it under control and how to understand that it might be causing our issues and how to fix some issues. Because SELinux, it's its own planet, it's its own ecosystem, and it will be there's just too much to cover in this video. But this is just for you guys to understand what it is, how to get it under control, and also to get ready for the EX200 exam or the EX300 exam, whatever your path is. All right. So let's kick things off with the following. So let's just get this under our belt, which is the possible states of SELinux. Okay. So in a nutshell, SELinux can have three states without any order of importance: permissive, enforcing, or disabled. So in a very short description, disabled. Well, I think you know what disabled means. It's completely off. I cannot type. And just make sure you understand this. SELinux is a kernel feature. It means that this is not a service you can stop. This is not an application you can just kill. It's a Linux kernel feature, which means the way to get it under control, it needs to be by its own methods. It's not stop the service or kill the application. So if you want to get this SELinux to disabled, you need to reboot if it is not. So if its current state is permissive or enforcing, to get it disabled, you need to request a reboot at some point. Okay. So if it's permissive or enforcing, to get it disabled, it will require a reboot. Okay. Permissive. It has no action, so it has no interference, but it will log as it was, which means we will get the logs up and running like it was doing something, but in actual terms, it's doing nothing. So it's not preventing stuff to work, but it will log as it was. It's a nice feature to have. Then we have enforcing, which means all power. That means that it will do whatever it will do all he has to do. It will enforce all its actions and still get the logging. Okay, so you need to decide which method you want to use, permissive, enforcing, or disabled, and just set it as accordingly. So let's just understand or find out what is a current state. So get enforce. We'll get this there. So our current state is enforcing, which means that SELinux is doing all its restrictions. It's defending us as hard as it can, even if that hurts us, and delivering all the logging. Okay, so let's do the rest with this in mind. So SELinux, it's doing all he can to protect us, even if it means it breaks our services from working. That's just something you need to live by. Let me get the light here in my direction. There we go. This is just something you need to. Something you need to live with. If it's enforcing, it's trying to protect us, even if it hurts us. So let's use the HTTP service as an example for me to show you guys how you can and try to detect the issue caused by SELinux and how to fix it. So let's do a quick example. So let's go to the var www.html folder. If you should remember this. If you don't, here it goes. So this is the default folder where our HTTP server is going to pull these files from, and we have a file there that we built in a previous chapter that is giving us that -rockies thingy-majiggy. So if I go here, if I do an ls-lz, if you haven't watched how this website came into life, go and check the previous chapters. And it should be on the setting up services chapter. So as you can see here, if I add the capital Z to the ls command, you will see something that it's probably new to most of you guys, which is all of this information. And all of this information is regarding SELinux. I will not dive into much detail about this. I will not dive into all of this, okay, because it's just not necessary for now. But I will focus on this thingy-majiggy here. So this is all files and folders have some sort of SELinux context. In this case, it says httpd syscontent. For example, I can do the same thing to the var folder. I can do the same thing to the etc folder and all the folders. So all files and folders will have some sort of this type of context. Okay. This is where SELinux is going to check if it is okay to use this file or not. And in this case, in our file, it says httpd syscontent, which means that this has some relation to the httpd service. To get that under control, you can go back to the command you already know, which is the ps-ef, and we add the capital Z. If you don't know how to use the ps command, go and check my channel for the managing processes chapter. And I can just grep for httpd, and as you can see, httpd, the process itself, the executable itself, it's going to have an SELinux. It is going to have an SELinux context too. Okay, so it means that all files and folders have an SELinux context, and also the files themselves. And that's how SELinux knows. It crisscrosses everything. He knows, okay, the HTTPD service is trying to touch this file, and it's okay to touch because they belong to the same, let's call it, ecosystem of permissions. As simple as that. Okay, so as you can see, the site is working, which means that, well, it should be working. It was working a second ago, but it is. I just refreshed it a bunch of times. So as you can see here, it's working fine. Hi from blah 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 da da da. The context is it's okay, and it's good to go. So I just this is just making me a bit confusing. 122. Oh, the IP changed in the meantime. That's fine, and it's not a fixed IP. So there we go. Hi from Rocky 2, and we are good to go. So everything is working as expected. Everything is working fine. Everything is fine and dandy, and we are good to go. Why do I have multiple IPs? I don't know, but I just don't care at this point. At this point, it's fine. This is working, and we are happy with this. So the website is working. Just to make you guys show that it's the same thing. It's Hi from Rocky 2. Just to show you guys that this is the thing we are actually working with. Hi from Rocky 2. Hi again. I will save and quit, and you can see it's the same thing. Okay, so it's the exact same website. So let's make this stop. Let's damage this and blame it on SELinux. So I'm going to back here. As you can see, the context is it's okay. So what we're going to do here is something that might happen with you guys, which is I'm going to copy the file from here to the root folder. Okay, and if I check the file on its new location, since it's a copy, okay, it's the same file with same content, the same content, but now it belongs to different context. Now the new file, this is a copy. I still have my original one. Okay, I still have my original one. Okay, but now I have a copy of the file on the root folder, and the file context is completely borked. Well, it's not borked. It's correct for where I copy it to, but for the HTTPD, it's borked. So what I'm going to do now, I'm going to move from the root folder to the current folder, which is variable.html. Oops, and I just did again a boo-boo. So let's fix that. I just moved the whole folder, which is not what I want. So let's move the root folder back to where it belongs to. Let's check the file again. Let's do -lz. I'm sorry, LAZ. And as you can see, the file, it's borked. Okay, so it still has the wrong context. So I'm going to move the file from the root folder. So don't do as I did, specify the file, the var.html, which is basically the one I'm here. And I'm going to overwrite the file. So let's review this. So I'll copy the files to the root's home folder. And since it's a new file, it created a new file with new context. Then I'm going to move it from the root folder back to where it belongs, and I overwrote the one that was already there. So if you're following along, don't do it as don't do this like I did. Don't move the root folder to here. You just want to move the file itself. Now, after moving, the file is here. It has the same content, but the SELinux context, it's borked. So if I refresh here, most likely it will just fail. Okay. If you want to see a more clear information, you can force the website to touch the file, and you can see it's forbidden. Okay. Why? Because the file is there, the regular permissions look okay, but the context, it's borked. So if I do an ls-l to the file as normal, you will not see any problems. It looks fine. You just need to be aware that if you add the capital Z, then you will see the SELinux context being borked. So this is wrong. Admin home T, it's not okay. Admin home T, it's not okay to be touched by the HTTPD server. So it's forbidden. So if you want to check the logs, you can just check tail var log messages. As you can see, there's nothing obvious, but you can just check the secure log, and then you can get something out of this. And even though this is, well, as you can see, we're getting nothing. Okay, and this is expected. I set this up. If I check the secure log again without the tail, we see there's nothing specific about the event that just occurred. So I'll just give a few refreshes and still nothing probably. Okay, this is normal in a way and not normal in a different approach. So this means that we are not getting the SELinux exceptions logged, and that can be expected if you don't have the correct service installed, in this case Rocky 2. So Rocky 2 has a web server. SELinux, it's doing its thing, it's operating as expected, but you don't see any logs. Okay, that's expected in our case because Rocky 2 was installed using the minimal install. Okay, so Rocky 2 was installed using the minimal install, so we don't have the SE troubleshoot service installed. So let's fix that. So let's do search, DNF search, and then let's search for SE troubleshoot. Okay, so this is the service you need to have installed to get the logs and some other tools. So let's do, if you don't see the logs but the SELinux it's acting, SELinux is acting as expected, you just don't see the logs. Okay, so we can do DNF install, add the SE troubleshoot, -y. So if you see SELinux acting as expected, you don't see the logs. This is why. You install the SE troubleshoot D service, and you just wait. Rocky 1 has this already installed because it's a more full install in a way, and we can just let it do its thing. It will take a while because there are a few packages, but they are all smallish, so it shouldn't take too long. I could have done this beforehand, but I wanted to show you guys the things occurring and how to fix them, because that was something that was requested in a comment, that more troubleshooting. So here we are, more troubleshooting. So if you don't see the logs, you just install, and this should be good enough. So let's just do a few refreshes, getting the errors up and running, and you go to the secure, and now you see more stuff. Okay, so you can see here that okay, still no reference to the SELinux thingy. Let's try the messages, and there we go. Now you can see here all the errors are popping up, and you can see this like something around the lines where this is not really okay, here we go. So you can just pause the video here, and you can see that our message is getting created and explaining the reasoning. But if you really want to get the full details, you need to run the this guy here. So this is going to give you all the details of that specific event, and I refreshed multiple times, which means that you're going to see this multiple times to popping up. So this is going to give you all the full details. I'm not going to dive much into this, but if you want to pause the video here or do yourselves work in our test machine and explore. But basically this is telling you that SELinux is blocking the access because it's doing its thing. So that's as simple as that. So how can we fix this? There are many ways you can go about fixing that. And if you check the logs and the EXE alert thingy, you will see that it's going to give you some suggestions on how to fix it. But the suggestions that they give you is not always the best, so trail carefully. But this is my train of thought is like this one. So let's just make sure that SELinux is causing this, make sure that he is. So I can do a command called setenforce, and I can do permissive. And if you remember, the permissive means that it's going to allow everything to occur. So it's not going to restrict, but the logs keep getting written down. So I still get new logs like it was preventing, but he's not preventing. He's letting things happen, but the logs keep getting written down and being created. Okay. So this is these are new events getting written down. So I refresh, and these are new events getting written down. Okay, cool. How do I fix this? So let's make sure that actually is. Oh, we can also do 0 for permissive, 0 for permissive, and 1 for enforcing. So this is easier. We're back on the problem. So okay. So if I go an ls minus lz, you'll see that the context is bad. That's because we caused the issue to occur. So we need to fix this to the correct one. There are 2 ways. I'm going to show you one for now. So let's do the LAZ. So you can see the current folder, and you can see that the current folder, it's fine. So the folder is okay. It's the file that it's damaged. The folder is okay. The file, it's damaged. Damaged in a way. It's not actually damaged. It's just not working properly as expected on the with SELinux. Okay. So let's fix this to match the folder because the folder is okay. So let's do restart con. Minus VR in the file. This is going to tell you that, okay, I'm going to change this from admin to the correct one. As you can see, this was changed from here to there. We refresh, and everything is fixed. See? So this is kind of one of the best case scenarios. That is, the file is not working properly, but it's in the folder. That the folder is okay. So the folder is okay, but contains a damaged file. So you just fix the file according to the folder. If you want to be really, really lazy, you just do this and should fix all the files. It not fix any file just because it was already fixed. Pretty okay. Now let's do a different scenario. So let's create a folder called mkdir -p. So let's call this var sites /www. And you go here and let's call this vi index.html, and let's call it new Rocky 2. This is going to be our new website, our new default website. Okay. Now I'm going to change the configuration. I'm going to do a very simple and crude change. So don't cringe yourself. I'm going to change the default website. I'm not going to do anything really crazy. I'm just going to change the document root. I could be more fancy, but okay, var sites. And I forget the name already. It's called var sites www. Okay. www. I'm going to change the default site. I could do much fancier things, but bear with me. Keep it simple. So var sites www. Whoops. www. And this isn't needed, but var sites www. Okay, this should be good enough. Yeah. So I'm going to write and quit. I'm still looking at the old site because I did not restart the service. So systemctl restart httpd. No news, good news. I refresh and I get the forbidden. Let's put this in permissive mode. And now it works. Now it does not work. Okay. And you guys know why. Because if I go to my new location, If you do ls-llz, you'll see that the file is borked, and in this case, the folder itself is also borked. Okay, so this is a completely new folder, has nothing to do with SELinux, which means that we have a borked folder and a borked file. So we need to fix the folder first, then we can fix the file. Okay. If you want to make sure, you can do smanage. And let me put this a little bit away from my big noggin. You can do smanage f context -l. Am I right? Yeah. And you can just grep for sites. And you'll see that the word sites pops, but it's not our var sites. And you can go for www, and you'll see that the old www folder is already there. So first you need to create an exception for our new location, and then you can fix the file. Okay. So if you search for grep www and then grep for HTML, you see that our older folder, or the default folder, it's already there. So our new folder, it's not. So we need to make sure that our folder will pop in this list. So let's go for sites, then www. So this is just a coincidence. Okay. So we need to make sure that our var sites will show up like this one shows up too, and it doesn't. To do so, you need to do we need to change that context, and thankfully we can just check the man page for that, because they have their quite a good of a guide to do so. So so I just need to go to the completely forgot the command. Jesus Christ, my brain just for a minute kind of frozen. So like I said, I am not going to I'm not going to cut this out. I'm just going to check you'll see me struggling with my own mind, and I'm going to check my notes. That's live. Okay. So my notes, let me get my notes, because I completely forgot the commands, and like I promised, I am not going to edit out my troubleshooting or my thought process. So give me a second. I'm just screaming through my files, so to my notes. Okay, da-di-da-di-da. This is the listing. Yep. Oh yeah, I just remembered. It's not that hard. So if you go to the smanage man page, if you go down, you'll see the sub page for the f context. So this is the one you want to check. So smanage, that's fine. You can fix this. F context. If you go down, you go to the example section, and lucky enough, you have an example here for the HTTP server. Okay, so just copy paste this. Of course, you need to change the context accordingly to what you are troubleshooting. So right now we are troubleshooting the HTTPD service, so it's very convenient that the man page covers the HTTPD service. But that's one of the hardest part of SELinux. It's trying to find the correct context for the correct server or service or application. But that's a different story. So just need to make sure that this matches the service you want to open an exception for. Okay. In this case, it's very convenient because a man page includes an example for the web service, but you just need to check or Google this time Google is your friend, and get which context is correct for the application or service you want to open an exception for. So this is var sites www. Okay. Don't put the end slash. Don't do this. Don't put the end slash. Just leave it open, because the end slash it's already covered by this regular expression. Okay. So this is going to add this new exception to the metadata. So right here, you already see our new location that you were not seeing yet. So the metadata contains an exception for the new context, for the new folder, but the files themselves don't have it yet. So the files themselves still show the old approach. So the files themselves still show the old context, not the new one. Why? Because you need to do the restore con -vr and just do a star, and it should be okay. Now, yeah, everything is fine. So the file is now in its correct context, HTTP content T, which means that if I refresh this, now it works, and you can just get enforce. It's enforcing, and it's working fine. So because the file, or let's do the LZ. So the file now has its correct context. Okay. If you want to do be even better, we can do vr www and all the things in between, just to make sure. But you should be okay. And if you go there, you see that now the file is correct, and we should be good to go. And we are, because the exception was opened, so the new location is now good to go. So it shows on the metadata for the SELinux context database, if you want to call it like that. So this folder, it looks perfectly fine, and the files that are within it are also perfectly okay. So since the file is okay, this is okay, and also in theory at least, all the new files that you add here will also be okay. So let's check the logs just for funsies. Where is my tail for the secure? It should be somewhere around here somewhere. I have used it, and I'm going through the long way. There we go. And nothing is popping up, so which means that there are no issues to show. So we are pretty good to go. So you did the restore con to the folder. You can also do, if you want to be really nicely done, you should go to the sites and do a restore con to the main folder. Okay, so you just go to the sites folder. Now the sites folder should look okay. There we go. See, and now the www folder also looks okay. So the folder itself and the files themselves are shipshape. So you should go to the main folder that contains the subfolders with the subfiles. Do restore con to the folder that contains the files, and everything is shipshape. So the www folder, it's okay, and also the files are okay, and also future files should be okay. Woo! Okay, so SELinux, it's under control. You know how to fix a folder with the correct context. So just make sure, be aware that when you do the f context thingy-majiggy, you need to make sure that this has the correct context. I'm sorry, this here. This needs to be set with the correct context for the correct server or service, and it should be a-okay and good to go in that aspect. If it's HTTPD, if it's anything else, it should list here the other service that suits your needs. Woohoo! All right, so let's go back to the set enforce command. So the set enforce allows you to set between enforcing and permissive. And you may be asking, how do I set this to disabled or enabled? Don't forget that to set this to disabled, you need to reboot. Okay, so if you do like this, get enforce right now it's enforcing, it's fine. So you can swap between enforcing and permissive at your leisure. You can just swap it out from one to the other at your leisure with no issues. But if you're going to put this in disabled state or back to enforcing state, if it's disabled, you need to reboot. So if I wanted to put this as completely disabled, if I want to make sure that the get enforce tells me disabled, you need to reboot the server. But first you need to do this. So just vi the etc default. I'm sorry. This has changed recently. So etc SELinux config, etc SELinux config. You go here to the mode and you just put it to disabled, and then you reboot. And it's disabled. Okay. This is the default mode on the next reboot. So since this list enforcing, it means that in the next reboot, it will be set to enforcing. If you put this to disabled, it means that on the next reboot, it's going to be set to disabled, and so on and so forth. You can also do this with the kernel command. I will not show how it's done, but you can also go to very low level and set the kernel itself, and set this on the kernel level. So you can at the kernel level set it to disabled, but I will not show you this at this point. This is enough for you guys to progress successfully. Ooh, not bad. Just one more thing before we wrap up this video, which are called the booleans. So file context, it's what I just mentioned. Files and folders that need to match the correct binary file, the correct executable, the correct service in a way. So he matches the files or folders to the service, and if they match, they are allowed to interact. But there are more things. There are users that you can interact, firewall rules in a way that you can interact. That's for another video. But now let's discuss booleans. Booleans, it's if you can or want to authorize a certain feature to be a-okay. For example, if you want to allow anonymous uploads for the FTP server, that's not a file context, that's not a folder context, that's just you authorizing something to occur, right? So what we're going to do now is I'm sorry, why? Don't do. Okay, so what we want to do now is to allow a certain feature to occur. So it's not something about permissions or actions or file context or interaction between files, folders, and services. It's just a server feature that can or cannot occur successfully. Like, for example, anonymous uploads. We're not going to do that anonymous upload thingy on the SELinux, on the HTTPD. We're going to enable something called the home folders, which means that if you want, we can allow our users to be able to access their home folders through the web server. For example, I will make sure that the student user can do this and can see the contents of its home folder. You'll understand a little bit better in a few minutes. So let me guide you through how it's done. So first you go here, then you'll find a folder that is called the user dir. It's already here. So just edit this file, and you go here, user dir. It shows disabled. You just need to do and add the option that is there. It's not enabled. It says disabled, but it's not enabled. You add this. I fell on that mistake many times. So even though the default says disabled, you don't put enabled here. You put public HTML. Oops, sorry. Let me fix that. And now restart. But it's not enough still. Okay? Because SELinux it's kind of not liking the thingy. Let's do the following. Let's do set enforce permissive. So we can fix the service itself. So it's permissive. Let's make sure. Permissive. So this is not SELinux doing its thing. This is just the service itself and finish it. It's not still correctly configured. So if I go, let me then go back to my student user, to my home folder. So now I'm not root now. I'm back as student. I'm going to do create a folder called public HTML. Okay. And I'm going to do something really simple like Dutch file. If I refresh, I should not be able to see it yet. Let's just do a new, because the permissions are not correctly set on my home folder. So to fix them, going back to root. If I can type my own password. I'm going back to my home to the home folder. I'm going to do chmod. I'm going to set the others can read to the student user and its subfolders. So others have read access. So if I go to the student users home folder, the public HTML has read for the others. And I still get the forbidden. Okay. Let's troubleshoot, shall we? Okay, so am I typing this correctly? Student. Okay. So let's go back here. Let's troubleshoot this further. Let's go to the home folder. -L, and everybody has reads. Oh, I need to give him also the execute permission, because read is not enough. So let's go Rx. You should be now. Okay, it works. So read is not enough. You need to also give them the execute so they can actually access the folder. Okay. So now it's working. If I go to my student users home folder, public HTML, the others have write and execute so they can actually access this folder. And now it's working. As you can see, I can see it. Let's do set enforce 1. Now I should fail. Forbidden. See? Now if I check the logs, you just see the jibber jabber blah 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 about all of this and all about the all about that failing access that is actually occurring, because you know the answer, because it's the get enforce. You'll see that it's enforcing, which means that we are not being able to access because SELinux is just preventing the access. So this is not a file we can fix. This is not a folder we can fix. This is not nothing. It's not none of that. Okay, it's a boolean. There is no problems with the file contexts or the folder contexts. This is a problem with the boolean that is not authorizing users to access their home folder through HTTP. How do I check that? Get SEBool, and we get the -L, capital L. How do I get no, I'm sorry. SEManage boolean -L. Why is my keyboard now not? Well, I will just work around this. I'm typing this badly. It's boolean with 2 O's. Okay, so with this command here, which is this SEManage boolean -L, you get all the booleans, all the OKs and no OKs of the system. If I do a pipe more, why is my keyboard completely not correct? Okay, pipe more. And you can see you have 2 states, the states and the default. This is a current state of the boolean. This is the state on the consequent reboots. So this is a current state. This is at the reboot level. So let's do a grep, the quick grep about that. So home, let's search for home. And this is the one we want. So this, I know I went directly to the correct one because I know what I'm looking for. That's one of the many challenges about SELinux, is to find what you are looking for. Okay. In this case, I went straight to what I wanted because I know what I was looking for. If you didn't know that, this requires some research, some googling, and all of that, so you can find the one that you actually want, or the Google or the man pages. But this is the one we want. So you want this to be on. So on right now and on the next reboots. So let's do that. Let's do set enforce enable home DIRs on. I'm sorry. I'm so dumb. Set SEA bool. That's how we do it. Okay. And now we should go back to the listing. Enable home DIRs. There it is. So it's on right now, but it's not on the reboot. Why? Because I need to do a -p here. P means permanent, which means now it should look on, which means that it's right now it's on. On the next reboot, it's also going to be on. And now this is back at a working state. Why is the intro popping? So let's go back. Well, let's type in the terminal right now. Okay, I'm going to work on my second machine, which is also called Rocky 2 for the most part. Okay, so that's where we're going to spend most of our time in this chapter. And we're going to discuss all about disks and partitions. Okay, that's it's going to be the main theme here. It's all about disks and partitions. We're going to discuss disks, we're going to discuss partitions, swap partitions, MBRs, and GPTs. Okay, global partition tables. And also MBR, the master boot record partitions. So we're not going to dive into all the nitty and gritty details. We're just going to discuss the main part, the main configuration things that this course will cover, or covers, and this will also get you up and running for the exam if that's what you fancy right now, and I believe many of you guys do. So that's kind of what we're going to do here. It's prepare you guys to have success in your exams. Okay, so let's start with Rocky 2. Let me just get myself into some root access here. Just double checking everything's fine. And yeah, so let's start with some tools that help you check the current state about disks and partitions. So we're going to see some terminal commands, some executables, of course, that will help us identify our current state about disks and partitions. I'm going to show you three: the lsblk commands, the blkid commands, and also we will get the proc partitions file. Okay. So this is going to more commands will follow, but let's discuss these three first. Okay. So this sort is fine. So lsblk. So this is going to show us how our hard drives, how many hard drives you have. When I say hard drives, I can say it's SSDs, NVMEs, all the storage types that this specific server can see. So here I have SR0. SR0, it's all about optical drives like CD-ROMs and DVD-ROMs when that's something you are using. But if you're using a physical one or a virtual one from the cloud, SR0, it's usually something about CD-ROMs or DVD-ROMs, okay? Also, we'll have here the NVMe. So NVMe, it's the first 1 second. Let me just get a couple things ready. This, then that. Okay. So NVMEs are the most current, quote unquote, current storage types. It's the NVMe drives. And you can see here different things like SR0 are optical. Then you can also see NVMe, of course, NVMe drives, and it will show as NVMe with the number. You can also see SDXs. SDXs, it references SATA and SCSI. Okay. You also probably see, some of you will see ADD0. This it references IDE drives. IDE drives are it's something really dated and old, but you might still see it. So SR0s are opticals, NVMEs are NVMEs, SDs are SATA or SCSI. I'm sorry, this is not correct. This is correct, and this is correct. Okay. So SDA, SDB, SDC, etc. Let me put it here for reference. So SDA, SDC, SDD, etc. are going to be your SATA or SCSI drives. And these are going to be HDA, HDB, HDC, etc. are going to be your IDE drives. Okay. Probably most of you guys will not see IDEs if you have not seen them before. unless you have something specific to work with. So SATA or SCSC or SCSI drives, okay? So as you can see here, you'll usually see NVMe and the number, or SDA, STC, STD. If by some accident or by some situation you reach the SDZ and you need another drive, you will see the SDAA, SDBB, SDCC, and so on and so forth. And also this applies to your SATA, okay? And not SATA, I'm sorry, all the HDs also. So HDB. If you reach HDZ, you'll see the HDAA, HDBB, and so on and so forth. Okay, so you have a big range of drive assignments in a way that you can have. So you can be rest assured that you probably will, in a real situation, you most likely won't run across some limitations or problems regarding identifying your storage devices. So you should be A-OK 99.9% of the time. Okay, so this is what lsblk gives us. I can also do lsblk minus fs. Fs means file system. It's going to show us some other information, like for example the ID of the file system. Okay, you can also see what was the file system used to format those drives. I know that in Linux we don't say formatting, we say create a file system, but tomato, tomato, potato, potato, there is no big of a difference. So when you format or create a file system, this is going to show how you did it. XFS, nowadays XFS is kind of the most common one, but you probably see others like EX200, 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 or other more specific file systems depending on the use case. But XFX, it's kind of the standard one, if you want to call it standard. It's kind of, if you are going to format a drive or partition using Linux file systems, XFS is kind of the de facto default, unless you need something more specific. Then you can also do the cat proc partitions. I have talked about the proc file system in this course beforehand, so check the other videos to get more details. So here the partitions, we have the same, not the same, but a big approximation of information that you get from the other commands. And also, we also have here the DM0. DM0 is all about Logical Volume Manager, and now we'll discuss Logical Volume Manager on chapter 7, the next one. I think the next one is 7. And I will tell you more details about that when we reach chapter 7. So ignore this for now, and let's focus on the lsblk command with or without the fs option. You can also use the blk ID. The blk ID, it's kind of a cousin from lsblk. It's going to show you similar information with a different output. So there are no better, or there is no good or bad. So just take your pick on the command you prefer, or just use the command you remember. Okay, there is no right or wrong here. Just use the one you prefer, or use the one you actually wish to use at your own leisure. Okay, so let's go back to lsblk. And let's analyze this. So here I can see that I have the optical drive. So let's let this one stay as it is. NVMe, it's our first drive. And I can see that the NVMe has two partitions. And the partition I will explain a little bit better in a second. But the partition is kind of a division. You have the main drive with an X amount of space. And the partition, it's just, you can divide that in different slices. Then you can use each slice for your own effective use. So I have here two partitions. Here you can see I have the device name NVMe 00. Okay. Then I have the partition 1 and have the partition 2. Partition 1, it's 1 GB big. Partition 2, it's 19 GB big. Okay. And as you can see here, I have this partition. It's kind of a special one because it's divided into LVMs, and LVMs I'll discuss on the next chapter. Like and subscribe to get on top of that. Okay. But in a nutshell, we have two partitions, P1 and P2. This partition is 1 GB big. This one is 19 GB big. The usefulness of this partition is to boot the system, and the usefulness of this partition is to give space to the Logical Volume Manager subsystem. So let's leave the Logical Volume Manager subsystem for the next chapter. So let's focus on normal partitions, okay? And usually normal partitions are MBR partitions or GPT partitions, okay? So MBR, it's the older one, the older method. It does not mean that it's useless. It's just older. The global partition, the GOID partition table, or GPT, it's the most recent one. So it is. I'm not saying that the MBR is to be discarded, not at all. You can use one or the other, but the MBR it's a little bit more dated, which means that the partition sizing it's a little bit smaller, and with some limitations. GPT it's the most recent one with less limitations. You'll understand why in a couple of minutes. The differences, they are pretty simple to understand. Then if I go back here, I have two storage devices, NVMe N2 and N3. So this is N1, this is N2, this is N3. And you can see that N2 is 22 gigabyte big in my case. N3 is 23 gigabyte big. This will vary depending on your case. These are my NVMEs, my secondary NVMEs. So this is my primary NVMe. This is one of my secondary NVMEs. This is the other secondary NVMe. This is my computer, my server. It does not mean that yours is going to be the same thing. Okay, so this is my situation. Your situation will be different. That's why you need to use these commands to explore your use case, so you can find out your specific server, what is its current situation. My server has one device, one storage device, second storage device, and third storage device. This is the first one, second one, third one. They happen to be all NVMEs, but it doesn't have to be like that. You can have mix and match between NVMEs, SATAs, SCSIs, whatever the case. It's all fine. Just need to be aware of its limitations and correct features. This major and minor, do not give it much importance. It's not all that's relevant for this discussion right now. These are just kernel references. Okay, each one will have its own kernel reference, which is normal. Don't dive too much into this. Don't try to understand too much of this. It's fine. You don't need it for now. Just focus on this, the name and the sizing and the type. Okay, so this is a disk, NVMe is 22 gigabytes big, and it's a disk. No surprises here. It's a standard disk. We have the N2, which is 23 gigabytes big and is also a standard disk. So I can also see that apparently, and this is most accurate as possible. This is a storage device that has no partitions and it doesn't have mount points. I will explain what a mount point is in a few minutes. But since it has no mount points, it means that most likely it's not being used for nothing. It has no use. So the mount point means this has no use, no current use. So it's a physical device that exists, but it's being used for nothing. Okay, it just exists. So that's why we're going to use this one. We're going to focus on this one here. So I'm going to get this one, and this is going to be partitioned into MBR partitions, master boot record. Okay, so I'm going to get this disk, and I'm going to partition this disk into master boot record partitions. Okay, but before you do that, let me explain a few concepts. So let's get some space on my notebook. Give me a second. Then you can just jump into here, get my pen, and I can explain. So we're going to discuss here the MBR, the master boot record. Okay, and MBR has a few limitations, and I'm going to explain to you guys what those limitations are. Okay, so in MBR we have 3 partition types, and the naming scheme can be a little bit controversial, just because it depends on who's explaining those names. There may be some differences, but play along with me and you'll understand. So one of those types, it's called primary partitions. Primary partitions can be called like the main type of partition we have here, and the primary partitions are used typically to boot the system. Okay, this is in generic terms. In standard terms, they are used to boot the system. Okay, then you have extended partitions. Extended partitions are used to house or to keep, to cocoon what's called the logical partitions. Okay, so what's happening here? So the extended partition only exists so you can house the logical partitions. So it's kind of an enclosure for a second partition type, which is called the logical partitions. So if you create an extended partition to house the logical ones, you cannot put data directly onto the extended ones. Okay, you cannot put data directly onto the extended ones. Okay, you will just create extended to house the logicals. You'll understand this better in a few minutes, I assure you. There are more limitations. You can only have 4 partitions on one disk, and what counts as a partition are primaries and extendeds. But you can only have 4 of those types, and of these 4, only one can be the extended type. So, in simple terms, let's say you have 4 partitions. 4 primary partitions. Okay? So you have 4 primary partitions, you are done. More than 4, you cannot create. Cannot. Then you can have 3 primary and 1 extended. This gives us a magical number 4. You have 4 partitions now. Okay? You have run out of options. But only one can be extended. You cannot have 2 extended partitions. So the magical number is always 4, and of those 4, only one can be extended. So if you create 3 primary partitions and 1 extended, okay? If you create 3 primary partitions and 1 extended, you have reached the number 4. And of those 4, 1 is already extended, okay? Now you can put inside the extended some logical ones, correct? If you have 2 primary partitions and 1 extended, okay, and 1 extended, you have 3 partitions. You can still create 1 more if it's not extended, if it is primary, and if you have enough free space. So magical number is 4, one of those 4 can only be 1 extended. Do you get the idea? So can have maximum 4 partitions and only 1 can be extended. So for example, if I have here a device, a storage device, if I have 1 primary, 2 primaries, 3 primaries, if I am careful, I can use the remainder of the space for an extended partition. Then I can just create logical partitions within it. And the most common number is that you can have 16 logical partitions for most situations. So you can actually kind of see that the creation of the extended partition and the possibility of creating logical partitions within it, it was kind of a way to get around the number 4 limitation. Okay? But if you do something like this, primary, 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 and this is free space, you are SOL. You are dead in the water because you cannot create a 5th partition. This is free space that you cannot allocate unless you delete this partition and use it like this, or create an extended with logical ones within it. Okay? So never forget, you have the limit is 4, the magic number is 4, and of those 4, only 1 can be extended. Okay? So the magic number is 4, and only one of those 4 can be extended. Okay? If you have 3 partitions, you can create more partitions. If you can create a 4th primary, an extended, etc. if you have free space. So 4 is a magic number, and of those 4, only 1 can be extended, and the extended partition exists so you can house logical ones. Typically, maximum of 16 logicals. What is GPT? Well, GPT is similar. I can jump the gun a little bit. If you opt for GPT, you don't have primaries, you don't have logicals, you don't have extendeds. They are just considered partitions. You don't have different partition types. They are all just partitions. And you can have a maximum of 128 partitions. That's GPT for you. So 128 partitions, they are just partitions. They're not considered primary, extended, or logical. They just exist. You can have the maximum of 128, which is a quite nice number. And also the partition size can be much, much larger. You don't have to remember how big can it be because the tools will guide you. You don't have to be too much worried about, well, you should always worry a little bit, sorry. But all of these limits, all of these ceilings, the number 4 partitions, only 1 extended, etc., it's quite impossible to go overboard with this. You are always, if you use the correct tools, and I hope you do, you're always directed, always oriented to stick within the limits. It's kind of hard using those tools to damage something or go over the limits. Of course, if you want very much, you can go over the limits if you really want to. But if you use the correct tools, which we will use here, the tools will just let you know that the limits were reached and you cannot go any further than that. So let's go to MBR first. And then my MBR, my tool of election to deal with MBR is the fdisk tool. Okay. So I do fdisk, then I do /dev device. I hope you remember at this point what is the device folder. If you don't, go back to my other videos, like and subscribe. And I can then specify the device to manage. Okay. And as simple as that. Now I am editing the partition table of this storage device. Okay. I'm not going to bore you too much with the fdisk tool. This video is already long enough, so I don't want to go too much overboard, even though I really like to go overboard, but I will just control myself. And I'm going to use our fdisk tool to create a couple of partitions. Let's create a primary partition. So let's create a primary partition on this device. I like to start with the P option. Well, we can always type the H. H will just I'm sorry, not HM. Now it's M. It used to be H. It's here. If you type M in this case, you'll see all the nitty and gritty details. But I like to start with the P option. This will print, and by printing, I just see what I already know, which is an empty drive. How big it is? It was here in the LSBLK. You were actually just seeing that it's a 22 gigabyte disk, so we already knew that from the get-go. So let's print. Now I want to create a new partition. I want to create a new primary partition. I use the N option, N for new. Okay. As you can see, I'm always guided to the good end. Okay. I want a primary partition. Nowadays you can boot from any partition, but it's highly recommended for other reasons. I will not dive into that right now, but it's highly recommended if you are doing a boot partition to be primary, if you are using MBR. Okay. As you know, GPT, there are no different partition types. They are just partitions, but primary partition is the recommended partition type to boot the system from. So we will create a primary partition. He will ask you for the partition number 124. If I hit enter, he's going to use the default option, which is partition number 1, and I will. And now he asks me for the sectors. Let me give you an idea how I interpret sectors. This is going to make many people angry because this is not very accurate, but honestly I don't care. So imagine a storage device like sliced bread. Okay, we have sliced bread. Everybody loves sliced bread. So what is a sector? A sector is a slice. So if you imagine this as your hard drive or storage device, whatever the case, a sector is a slice. So let's think about this in absolute terms. So what is the smallest bread piece you can eat from this sliced bread? What is the smallest bread piece? Yeah, I know you can cut the slice in half. I know that, but let's think through this in absolute terms. So the smallest piece of bread you can eat, it's a slice. So that's what the sector represents. A sector, it's a slice of the storage device. You cannot allocate less than the slice. And that's what the sector is. So fdisk is asking me what is the first, where is going to start the partition, in which slice sector. So he's suggesting you to start, this is just an imaginary thing, right? He's telling you, okay, the partition should start here. Okay. So why is he reserving 2 slices for something? He's reserving 2 slices for the MBR itself, okay? MBR requires some space to get its data written down to. So this is fdisk just reserving some space for the MBR. That's why he's saying, I recommend you to start on slice 248, okay? That's why he's not recommending you to start on slice 0, and you cannot do that. You cannot start on slice 0 in this case because he needs the space to make MBR work, okay? So you cannot really start on slice 0 because you cannot start on slice 0 because it was technically impossible. The disk would just be useless. So we start here. If you look carefully, you can start further down the line. If you wanted, you could start here, here, or here, whatever the case. It will depend on the situation. In this case, I just want to create a normal standard partition, so I will start on where he suggests. and hit that to start here on sector 2048, and that's fine. Which means that if I have here my drive, this is more or less going to be the MBR. My first partition will start here, and I will hit enter to accept a suggestion. And now he's going to ask me how big this partition is. So I can say how big by saying how many slices, sectors, or using more human readable names like gigabyte, petabyte, terabyte, and all of that stuff. Okay. So let's say I want a partition 1 gigabyte big. So I just type plus 1G, and now I have a 1 gigabyte big partition. So if I go back to my drawing, we started at sector 2048. I said 1 gigabyte big partition, and the fdisk application just decided how many sectors he would need to give me a 1 gigabyte big partition. So I said 1 gigabyte, and he said, okay, this is our start, this is our end, and he did the math for me. When I said 1 gigabyte, I could also say the sectors, so I can be very precise where the partition starts and where the partition ends. Sometimes it's needed, but for now, that's not important for us. I just want a 1 gigabyte big partition, and the partition type needs to be primary, and that's what we did. So primary partition, I accepted the number 1. I accepted to start when he suggested it, and I said I want a 1 gigabyte partition big, and he did the math and decided how many sectors we would need. Pretty simple. To confirm, I like to use the P option to print. Now, nothing happened. This is much like VI. I have not saved yet, right? So, which means that since I did not save, nothing happens. If I hit Control-C now, or the Q option to quit, nothing was saved. It's fine, but I want to save, so I will use the W option to save. This is no news, good news. This is if there was something wrong, I would just know it immediately. So I will just go back to my LSBLK. New partition is there. I come back to my proc partitions, and you'll just see the new partition being there, and all is good. So we have created a new partition. Okay, I will do this twice so you can see, but let's go down the line. So we have created the partition. Now we need to make a file system. Some people call it a format, which is fine, but in Linux you call it, let's create the file system. That's basically the same thing. I don't care what you say. So to create a file system, use the mkfs. So it's called the make file system. This is one way to do it. Then you can do -T to say that the file system type, and you will specify the partition you just created. This is what we get from noon. These are good news. Don't try to interpret all of this. It doesn't really matter right now. If there was a problem, you will just know it in your face. This is all good. Okay. If you want it, there are also some shortcuts like the .xfs. This will format in XFS, EX200, and others. So if I hit tab, you'll see there are some shorthand shortcuts to format in a specific file system. Or just type -T, and you are good to go, and you're off to the races. If you do this, you can specify which one. It's exactly the same thing. If I go to lsblk-fs, you see our partition was formatted using XFS and looks A-OK. blkid also shows us the same thing, so we are A-OK. So we have created the file system. We have created the primary partition, and we have created the file system. Fine. In order to use this new partition, you need to create a mount point. A mount point, it's like in Windows, you have the drive letters. Okay, in Windows you have drive letters. Here you have mount points. The short version is a mount point. It's a folder that maps to the device. Every time you read or write from that folder, you are reading or writing from that device. It's like a drive letter on Windows. Okay, so if I go back here, I have a 1 gigabyte primary partition created successfully, and you are ready to use it. It's formatted with XFS. Okay. Now we will mount it. To mount it, we need to create a folder first, and usually you have the mkdir, and usually you have the mnt. You have a folder called mnt, which means mount. You can use this folder or any other folder. Only root can do this, of course, but I'm going to call it partition 1. Just to make things a little bit simpler. And now I just type mount. You can mount on any folder, but I highly recommend that at this stage of your probably less experienced, create a folder just for that on the MNT. It's you will be mostly safe. So /dev, the partition you just created, the file system and the folder. And now if I go back to lsblk, there you go. This partition now is mounted there, which means that everything I read or write from there is from this partition. Okay. So let's say this was your USB drive, your USB pen drive. It will be the same process. Just make sure that you're mounting on an unmounted mount point. So mount it on a folder that is not listed here, because if you mount a partition twice on the same folder, problems may occur. So make sure you mount on a folder that is not listed here. Don't mount things twice. It can be really bad, really fast. We are done. But be aware that this is not going to survive the reboot. If you reboot the server now, the mount action will not occur automatically. Okay? The folder is there, the partition is there with all its data within. So the data is there and safe, the folder exists. This connection between the partition and the folder, it's not existent. Data is safe there, but the folder will be just empty without any connection to the partition. So if you want to make this connection at boot, let me just copy this and you will understand why I'm copying this. You need to edit a file called etcfs-tab, because this file is the one is going to be executed in a way in the next boot. So keep what is already there, just keep it there. Just get some space for you guys. I'm going to do some cosmetics. So my custom partitions. This is just optional, but I like to do it. Partitions. This is just cosmetic, but I find it comfortable for me. Okay, then I will just put my custom ones. And this is really easy. You just need to put your device and the folder. Or you can also use the ID. It's fine. Let me show you. If you do -blk -fs, you can also actually use this ID. Okay. There are some use cases for the ID, but for now I will not explain why the ID can be useful. Just understand that you can use it. Okay. Next, I can just look here and use this as a reference. So XFS is how I formatted it. We will use the default options. These options are used for performance options, security options, quotas, but use the default ones. And these numbers nowadays, 00 or 101, it's plenty enough and you are good to go. So the device or ID, the folder, the file system we use to format, special options if you want any, or just type defaults and are good to go. 00 or 11-ish, you are perfectly fine. So we'll save and quit. Now you can do mount -a. What this will do is it's going to read this file and apply it. If there are any errors, you will get notified if there are errors. If there are no errors, spit it out. You are good to go and it's good. There are no problems, which means that you have 99.9% of a good chance of rebooting the server successfully without any issues. Cool? Cool. So let's create a new one. That's not the one I want. I want this. So let's create 1 GB primary partition with XFS. Okay? I mean, why not? So we just go back where we were. To the fdisk. Okay, print. It's giving you a warning that says that this disk is currently in use, which is true. It is in use. We just gave it use. So new partition, primary partition. I can type P, or I can just I can type the P letter or just hit enter. It's the same thing. Number 2, I'll accept the suggestion, which is he's going to say, okay, this partition will start just after the first one right here, and I'm happy with that. I'm fine with that. So I will accept it. The size again +1G, 1 GB, print. There it is. We save. Now we format mkfs. Just look for the mkfs command we used before. I don't have it here, do I? I don't have it here anyways. mkfs -t xfs, and the second partition, all good. Don't worry, it's hard to format a partition twice. If you try to format a partition twice, you'll get a warning. So cool. Now you have created a partition, we have formatted the partition. Now we can just create a folder. And now we can just go to the FS tab directly. I will just copy paste this line and just be lazy and just change a couple the specific things. We save ls blk is not mounted, mount -a, ignore that, and it's mounted. So, and so on and so forth. Pretty okay. So let's just create a special, now let's create a special partition type. It's called the swap partition. The swap partition, it's not mandatory to create. You can live without the swap partition just fine. But it can be handy when to manage crashing systems. It can be handy to on laptops for hibernating. So even though it's not mandatory, in some situations it can be handy. And the good news is you can create a swap partition. You can create a swap partition on demand when you need it, and remove if you don't need it. So it doesn't have to be always there. You can also create a swap file if you don't want or cannot create a swap partition. There is an option to create a swap file instead of a swap partition. Let's say it's impossible to create a partition, you don't have enough hard drives or enough partition types, whatever. It's impossible to create a swap partition, but you want to create a swap file. You can create a swap file. I will not show you how to create a swap file on this chapter, but I am going to make a video outside of the scope of the RH134, how to create a swap file. Like and subscribe to get notified of that. Okay, so let's create a swap partition. Let's first see if you have any. So we can use a free command. As you can see, we already have a swap partition. That's fine. Let's create a new one. Since it's a swap partition, it's like a partition like any other. You just go to the fdisk, print, new partition. I mean, it can be, I can create a primary partition. That's fine. Let's say 3, it's fine. You can start here. Let's make it 1 GB big 2. Print, fine. Now, before we continue, you should change the type from Linux to swap. How? T, set the partition number 3, and type, you can do capital L to get the list, and the swap is 82. Print. There we go. So type, partition number, and type 82. And this is a swap partition now. Not yet, it's not finished, but we are doing well. So let's save. We are fine again. Now, what is the sequence? Create a partition, format, and mount, right? So let's format a partition with the command mkswap. And we will create like this. There we go. It's done. Now you go to the FS tab. Okay, let me just get this reference here. Oh, let me just copy this. I need this reference. I will go to the FS tab again. Now let me show you something. It's not yet seen as space, as swap space. It's created and it's formatted, but it's not exposed to the kernel as swap space yet. So let's go to the FS tab via etc FS tab. Let's create a new section to be organized. My custom swaps. Why not? You go here like this. We paste. Oh, damn it. Let me save and quit. Let me get this information back. Go back there and just paste this. Now since we already have a swap, you can just cheat a little bit. They use none swap, but you can also do swap defaults 00. Yeah, I'm lazy. Copy paste. It's king. If you are careful, of course. So let's just make things a little bit visually more appealing. You don't have to do that. You just can. So yeah, I mean, it was better beforehand. It's fine. So let's save and quit. Now you don't do mount -a, you do swap on, swap on -A to activate and -S to status. Now we have two. We have the one we already had and the one you just exposed. If you go to the free, you will see that the swap partition has increased. And now we have two swap partitions. The one we already had and the one we just added. You can add partition, you can add swap partitions, you can disconnect and power off swap partitions, but I'm not going to cover that on this chapter. That's for a separate video. Like and subscribe to get notified of that. But now we know how to create a new swap partition and extend our swap space. You can create swap files. I will show you how on a separate video, not on the sequence of the RH134. Like and subscribe to get notified of that, and you'll learn all about it. Cool. Now, to wrap things up, because this video, it's already getting a little bit big, which is fine. We're going to create partitions using GPT, the global partition table. But since you're already here on MBR, let me show how to create an extended partition with logical partitions. So I can just go to the FS tab, fdisk. Now, watch this. If I type N for new partition, it's going to ask me for primary or extended. I can create a fourth primary and I hit my limit. Or I can create an extended partition so I can put logical partitions within it. Okay? So, for example, if I go here, I have my, it's here. So I have primary. This is a swap, right? If I create a primary with 1 GB, then I have space I will not make use of. It's just an example. I'm not limited to 1 GB. This is just an example. What I'm going to do here is I'm going to create an extended partition and create a slice of 1 GB. Then I can further down the line create further slices of 1 GB. Okay. So I'll say E, and now I'll just hit enter. What this did is that I'm using all the remaining space for an extended partition. And don't forget, that we cannot put data into extended partitions. You can just use it extended to create logical partitions. And then you format the logical and put data within it. Now I hit N, and no questions will be asked to me because the only option is to create a logical within the extended. That's that. Now the questions are the same. Start here, make it 1 GB, and there we go. I'm not limited to 1 GB partitions. I'm using 1 GB just to make things smoother and with some standard sizing. But you can do all the sizing you want if there is enough space on your hard drive. All right? Cool. Now, this is my new partition. I'm going to save. Now I will just mkfs -t xfs partition. It's the same thing. Okay? Now I just can create the mkdir thingy-majiggy. mkdir, not this one. mkdir. Let's call this logical 1. Logical 1. Okay, I have it selected so I can paste it. Let's go back to our VI, to the FS tab, micros and partitions. Kacham /mnt/logical 1. Okay, XFS. The spacing doesn't really matter, it's just cosmetics. Defaults 00. Mount -A. No errors. LES-BLK. This is not an error, this is just a warning. LES-BLK. There we go. And so on and so forth. Okay. Now you have something like this here. These are not. I have made an extended one, and I just created one slice of logical, which means I have all this space to create further logical ones. Now, last but not least, let's create a GPT partition table on a different hard drive. I have here a spare one that I'm not using yet. Even though you can convert MBR to GPT and vice versa, they are convertible, but be careful that things may just not occur that well. If you are in a pinch, you can convert, but avoid that. That's my recommendation. Technically possible, but not recommended. By me, by Ozoi Bits. Cool. Now let's go to edit this as GPT, and in this case I like to use a tool called gdisk and not fdisk /dev and the disk. This is not installed, that's fine. So dnf install gdisk. You know how this works. Let's go try again. No problem. No partition tables. I'm going to print. I have no partitions, no surprises, but it's this very similar tool. New partition. See, there are no primary partitions or extended or logicals. There are just partitions. First sector. I like this one. I want a 1 GB partition. Type, it's the default one, 83. I print. I confirm. I save. Yes. So slightly different, but the same, like in the movie. So lsblk, there we go. This is the partition. What next? We format mkfs -t xfs /dev prepepel folder mkdir /mnt gpt pt1 because there is no concept of primaries. Then vi etc fs tab. And wait, I don't have it copied. This is this one. Cool. There. mnt gpt1 xfs default 00. Whoops. Mount -a ls do not exist. So what did I call it? So it's uppercase tpt. That's fine. You saw the error. You saw me troubleshoot it, and just correct it. It's fine. gpt1 done. lsblk. There it is. Let's just wrap things up. Let's create a swap partition using GPT. So we'll go back to the gdisk. New partition. 2. Start here. Let's put it +2g just to be different. The type, we type L. And should be... I know which one it is. I just want you... Okay, it's this one. Print, swap, save, yes, mkswap /dev. Well, let's just copy paste the whole thing. Repel. Okay, okay. We have any warning saying that we cannot expose. I'm glad we did this because this is different, right? We haven't seen very more simpler messages. So as you can see, it's telling you that I cannot access this partition even though it says it's there. But if I check the proc partitions, you don't see the 0 and 3. Okay, it's not there. Okay, it's really not there. This new partition 2, it's not there. P2, it's not there. See? Let's try again just to make sure that I'm doing nothing. I forgot the P1, but okay. It's mounted, it's P2. Okay, it's not there. So even though P2 exists, it's not, the kernel is not aware. Okay, so we should see P2 here, which is the one you just created. P2, it's created, but does not exist. Why? Because gdisk was not able to inform the kernel of these changes. That's what he's telling you here. So the safest way to expose this new partition to the kernel, so it shows up here, is to reboot. Reboot is the safest option. Get some time in your day that the reboot is safe to do and do the reboot, okay? If you are in a pinch, like I am right now, I don't really care. I can use this command here, partpro. This will expose the new one to the kernel. So use partpro at your own risk. The reboot is the safest way to expose new partition to the kernel. If they are not exposed immediately by the tool, for example, fdisk or gdisk, if fdisk or gdisk is not able to expose it. So if gdisk or fdisk it's not able to immediately expose the partition to the kernel. For example, you do the W option on fdisk or gdisk, you go to the proc partitions file and it's not visible. The partition exists, but the kernel was not made aware of it. So to make things work, the safest way in this situation, or you see this message here, for example. So partition is created, but it's not exposed to the kernel, okay? It exists, but the kernel does not see it. The safest way is to reboot the server to expose the new partition to the kernel. This is the safest way, okay? But if you are in the pinch, you are comfortable, it's something that you can survive if something wrong occurs, which is my case. You do parts probe and the partition is forcibly exposed to the kernel. It's usually safe, but do it at your own risk. Now I can format it. And now you know the drill. I'm just going to get this. I'm going to go to my FS tab here and get it there. And it's basically the same thing. And swap on minus status to see it's not there. I'll activate status and it's there. See, pretty simple. So MBR GPT, pick your poison, it's all good and dandy. And woo, almost 1 hour video, so but lots of good information here. So let's directly go to, I don't know, here maybe. Looks nice. So let's get our Rocky 2 back here. So this is this is on the same exact point where I believe the previous video was dropped off. It was, I said it was chapter 5, but it was 6. It's in the title and on the thumbnail, it's fine. So yeah, so let's discuss what is the name of the chapter again? I forget. Manage storage stack. So in other words, we're going to discuss two things. One is LVM and the other one is Statis. Okay, I'm going to go through LVM and Statis, but let me tell you right now, I don't like Statis at all. I think that if you are running a production environment, just avoid Statis, because that's not something I would trust at this point, but I will show you quickly how to set up Statis. And I highly advise you to test everything out for yourself, like any other subject of this video series, of course. But Statis, just be careful, because Statis, it's I don't trust Statis. Okay, sorry, Statis people. It's just too early to trust. So, LVM. LVM it stands for Logical Volume Manager. It's been here with us for the last, I'm not sure exactly, but 20, maybe almost 20 years. So it's very trustworthy, and it's also a kernel feature, which means that it's something it's embedded on the kernel. And it's a kernel that manages, there are kernel level drivers and all of that good stuff. So you just reboot the server and the drives are there, no big of a deal. While Statis, it's a service, it depends on the service. So, well, but then again, I'm not going to try to influence your mind too much, but I don't trust Statis, but I do trust LVM. It's been here for a while and it's really trustworthy. It's a kernel feature LVM. Statis is it's a service level service, so it depends on the service to work properly, and it kind of makes me nervous and I don't like it, but I will show you anyways how to set it up. But let's discuss LVM first and foremost. If you remember, not yesterday, well, I recorded that video yesterday, so it's if you do LSBLK, you'll see that in our case here, you have these LVM drives here. I will get into that detail in a second. And also, if I go to the partitions, you can see that you have here these DM0 thingamajiggies. So these are the actual LVM drives on the perspective of the kernel. All right. So let's let them be. This is the exact point where we left off yesterday. The machine just rebooted a couple of times and it's fine. Everything is mounted automatically through the FS tab file. So everything, it's pretty great. Now, we have some space here on both drives, on the GPT and, sorry, this is the MBR, on the MBR drive and on the GPT drive. So let's fool around a little bit with those to set up LVM. But before we do set up LVM, let me just give you a quick rundown of what we're going to do here. Really, it's really simple. when you get the hang of it. So what is the one of the main advantages of LVM? There are more, okay? The more picky guys around here. Don't get nervous, okay? This is just me specifying, explaining things in simple terms. Don't get too nervous about this. These are just simplified versions of the thingies so people can understand. So one of the things that you can do that you cannot do with regular partitions, either being primary, extended logical, or GPTs. So one of the things you cannot do with those type of partitions is resizing. Again, some of you guys are going to say, but I know how to expand and shrink regular partitions. I know how to do it. There are tools to do. Okay, fine, but they are not. Those tools exist, but they need to be used with care. They are not supposed partitions like primary, extended, logical, GPTs. They're not designed to be resized once they were created. I'm not telling that it's not possible. Everything's possible in life if you put your mind into it. But you should not resize primary, logical, extended, or GPT partitions. They're not designed to be resized after creation. Yes, they can be done, but I don't recommend that. But LVM, yes. So LVM, it's a way to get to a partition that is resizable. Okay, you can shrink and you can expand. Being expansion the most common thing because of obvious reasons. But logical volume manager partitions can be resized, and that's something it's supposed to happen. For example, if you have a support contract with Red Hat and something goes wrong with the LVM resizing, they will help you out because that's not normal. You get support and all of that good stuff. If you try to resize primary partitions, extended partitions, logical partitions, GPT partitions using some crazy tool that you saw off the internet or someone that promised you that it would happily occur, or you don't read the fine print on those tools, you may get yourself into trouble. So how does this work? Well, first, let me just get my mic out of the way. I really need to use my wireless mic, but let's carry on. So first, you just get some space, okay? This is physical space, so this is called, let's call this a physical partition, okay? So this is just a partition, or like we create one of the ones we created on the last video, or a full disk. Okay, you don't have to partition your disks in order to create LVMs. You can just use a full disk. Just either being a physical disk or being a cloud-based disk. You just need to get some free space, some physical space to the kernel. It can be a partition. It can be the full disk. Doesn't really matter. Okay, so let's say this this is a 1 GB big physical partition or a physical disk. Just free space, whatever it comes from. The system does not care. Proc partition shows it, LSPLK shows it, you are okay to use it, okay? Physical space, something physical space that the kernel can work with. It can be a full disk or it can be a partition. It doesn't really matter, okay? Then you're going to promote this to a PV, and PV, it's a physical volume, okay? Let me try and write this down a little bit better. It's a physical volume, and it's going to have the same space of the partition. So physical volume, it's kind of you load in a special driver that is going to represent this, show to the kernel that these are available spaces. Okay, so you start with a physical partition, and then you will afterwards promote this to physical volume. Physical volume, it's LVM driver loaded. It's just a special driver that the kernel loads, so it can be seen as something special so all of the rest of the thingy-majiggy will work properly. Then you will create a VG, which is a volume group, and a volume group has the capability of grouping multiple physical volumes. Okay, for now I'm going to create a very sad volume group with only one physical volume. But in this case, it's going to have a 1 GB size because it's as big as the ones below it. Okay? Volume groups are great because you can, well, they are groups, right? So if this gigabyte runs out of space, you can just get more storage and expand this VG, something you cannot do with physical normal partitions. Okay? Then on the top of this, you'll have an LV, finally the logical volume. And logical volume, it's kind of, if you think about what you saw in the last video, that were the logical drives. So logical volume is kind of a logical drive. So it's a kind of the end of the road. This is what you format. You will format this and mount this. So you make mkfs here, and you mount here. This is the thing you format or make a file system, and the thing you mount. This is going to expose this to the user. Okay. What is the upside of this? I will show you in the second step. We'll do this step by step. But the good thing is, if this runs out of space, this is full. Okay. You just need to go to the bottom of the line where we started off. For example, so this doesn't have space. You need to provide some extra space here. Let's say another gigabyte. You just load the physical volume driver of 1 gigabyte, and then you expand this over here. Now our VG is 2 gigabyte big, which is made of two 1 gigabyte spaces, which means this thing can grow as big as this or creates 2 extra ones, etc. If this runs out of space, you just go back on the bottom, get some free space, load the special driver, expand the volume group, then you can give space to the rest of the family. Okay? That's one of the main things that you can do with the logical volumes, is to the expandability and the flexibility of managing your free space. Okay? But let's say this guy here, you can shrink one to expand another. So this is kind of a pool of space where the LVs can grow and shrink at your leisure. If this space runs out, this is kind of the base things, right? My head just fell off. Okay, let's see him fall off again. Okay, so then you can, if this runs out, you just need to add some space in the bottom and some space here. This will grow, and so on and so forth. This is a one volume group, but you can have multiple volume groups in your system for different purposes. It's all fine. Okay, so rewind the video a couple of times and rewatch and rehear me explain this if you didn't got this clearly. Or wait for me to do the practical demo and just rewatch it again. Let's put here a white space so I can just keep drawing what I'm actually doing in the console. So if I go here, what do I have? So I could use this because this disk is 22 gigabytes big. I still have some space for logical partitions. You can use logical partitions, you can use primary partitions or full disks. It's all good, doesn't really matter. But I'm going to use a GPT one just because I can, okay? So let's go to gdisk, and let's start to edit this guy here. You guys can see it? Yeah. So let's print out what we already know. New partition, it can be number 3, I don't care. We can start here. It's going to be, let's keep the 1 gigabyte thingy-majiggy. Let me get some, clear my view. Cool. Now, here you could use any type. 8300, which is the standard word, will work fine. But I do recommend you guys use the LVM one. So I know it from the top of my head, but 8E00, it's not still visible. It's there, okay? So this is the one we want. Oops. Quit. 8E00. Print. All good. So this is not mandatory. Okay, this is not mandatory. It's fine. You can use standard ones. You don't have to mark this as LVM, but on the long run, it's recommended. Okay. So I'm going to save this. Yes. It's making the changes. Let's do the part pro like we did on the last video to synchronize the changes to the kernel. If I do SBLK, there we go. It's there. It's fine. It's happy. And we should be pretty good to go. Okay, let's just do an SBLK. It's ID. Let's go to the gdisk once more. If we print Linux LVM, it's fine, and we quit. Cool. Now, what we have now? Let's go back to our specific drawing. Now, what we did here was create a physical partition. It can be the full, don't forget this. It can be the full disk. You don't have to partition things. And this is the 1 gigabyte. Okay, easy enough. We did it yesterday, many times. Not yesterday. Last video I recorded yesterday, but we did it many times, and it's all good. Now, let me add this here. Let's promote this to a physical volume. So this is basically going to upgrade the status of this partition to a special kernel device, which is going to be used on LVMs. And I'm going to use the command called pvcreate, and I'm going to specify the full path to this guy here. Okay, so first, oops, let me just do an lsblk here, so I get some way to copy paste. So pvcreate /dev this guy there, and now I want to list all my physical volumes. There are many ways you can do. Let me show you. We can do pvs. We can do pv display. There's another one, pv scan. I forgot the pv scan. Sorry, pv scan or pv scan. So I'm going to use one or other or the other. It doesn't really matter. All will show the same information. Some in a way, some in a different way. It doesn't really matter. Let's do pvs, and I can see now that this is the one I just added here. This was the one that was already there. Okay. If I go do lsblk, you'll see that the p21, it's this guy here. It's already a volume group that has two logical volumes. One is the root, so you can boot, and the other not to boot. This is the root file system, and this is the swap partition. So this one here, it's that one there. This is a primary partition for the boot. Like on the last video, I recommended that. Boot your system from a standard primary partition because it's easier to troubleshoot and it's just more reliable to boot. But you pick whatever you want because nowadays you can boot from LVM. It's fine. But I do prefer to boot from a primary partition. And this guy here, sorry, not that guy there. This guy here, it's this guy here, which means that there was an already present physical volume, which is fine, and that's okay. So if I go, this is my one here, this is mine, which represents now this structure here, okay? Now, I'm going to create a volume group on top of this. So it's going to be a group of one. It's kind of lonely, but that's okay. To create, I do a vg create. You kind of get the idea, right? And I'm going to call it vg new. Why not? And I'm going to use this guy here. Now to see, I can do vgs, vgscan, or vg display. I'm not going to tell you which one is the best because they are good in their own way. Just experiment. So vgs. I have a volume group. This is the one I have created. This is the one that was already there, where the root file system and the swap partitions are. So this volume group has two logical volumes. One is the root file system. The other one is the swap partition. One of the swap partitions, now we have multiple. Let's watch. Let's check. Swap on -s. So this is one of the logical volumes. You'll see that in a second. I'm building my way from the bottom to the top. Cool. Next, I'm going to create, this is our volume group here called vgnew. Okay. And now I'm going to create here, I'm going to use half the space to create a logical volume here with 500 megabytes. Okay. So this is the one I'm going to format, and this is the one I'm going to mount. Okay. Cool. Now let's do lv create. You kind of get the idea, right? I'm going to give it a name called lv1, no, lvnew1. It's fine. And this is a part where I usually make a mistake. I usually need to check the main page on the lvnew. Okay, so this is not enough. I understand. So let's do a vgscan. Oh, okay. I need to specify the sizing first. Okay, cool. Now I need to say how big it is. I said it was 500 megabytes. There are many ways to do this. I'm going to use the capital L to specify the actual size. Okay. So this is capital L allows me to say the sizing in a more human readable way. Megabytes, kilobytes, gigabytes, blah 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 bytes. If you use the lowercase l, you can say things like half the size of the volume group, or 1/3 of a size, or you can be a little bit more specific of your sizing. So because megabytes and kilobytes are a little bit too generic nowadays. If you use a lowercase l, you can actually say, be more picky about the sizing of your logical volume. In this case, I have created one successfully. So let's do an LVS. I'm going to put it here because I have to, but LVS, LVscan, LV display. Okay, it's the same thing. So LVS, sorry. And there we go. I have here my LV new that I have created on top of VG new, which basically represents this. So this is my LV new on top of VG new. Quite nice. And it's 500 megabytes big, which means that if I do a VGS, I will see that my VG new now has only, quote unquote, only 500 megabytes big because this guy took half of it. See, it's pretty simple. So now I will format this, mount this, and blah, 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 blah. Now I'll do a LV scan just so that you guys can see why is LV scan useful now. Because I am going to make the file system here, so I can just copy paste the full path of the kernel device. It's just that. So LV scan mkfs -t xfs, and I'm just going to copy paste this. Ciao. Done. Now I just need, as usual, mkdir mat lv lv l. Let me just copy paste lv1. Okay. Now I really wish I could copy paste everything, and I can. So I want to put this on an FS tab. So I'm just going to create a cheat sheet of sorts. There and there. Don't forget I'm using the commenting out. So I'm just going to edit this FS tab file, and I'm going to keep this handy because I'm going to need this. So you know the drill. This is going to be my custom LVMs. You don't have to do this, but it looks pretty. And it's easy on the eyes. So, bam. Again, you can use the UIDs if you want. It's fine. It will do LSBLK and you use the UIDs. XFS defaults 00. Looks good. I'm going to save and quit. LSBLK. If you think I'm doing some steps really fast, it's the good thing about videos and YouTube and all of that good stuff. You can just pause it and go back. And as you can see, it's not mounted yet. But if I do mount -A, I'm sorry, this is the set for status, -A. This is, I can ignore this easily. And now it's mounted. Okay, which means that every file I put here, or, well, when I read or write from here, I'm reading and writing from the device. So, LVS, there we go. Now, what is a good thing about this is that if this runs out, I can add space to it. Okay, so let's make believe something like that happen. So let's do a disk free -H. This is showing me that this is how big it is. This is how big is available. I know I have available space, not much by today's standards, but I have some space available there, right? Let's make believe this is just ran out, or I need more for some reason. So what I need to do now is look at this and see what do I have. Okay, so the LV, it's let me put this one here. So the LV, it's 400 megabytes big or 500 megabytes big on top of VG that is 1 gigabyte. So hopefully I have some space here available to grow this one here, right? Hopefully I can grow this because this probably has some more extra space. Let's verify. So if I do VGS, for example, I can see that VG new where LV new is on top. If I do LVS, you can see that my logical volume is on top of this VG. So the LV, it's 500 gigabytes. The VG has 500 gigabytes still available, which means I can grow my LV. So I'm going to grow the LV as big as the VG can give me. So I'm going to run out of space on the VG on purpose. So let's resize the LV first. To do so, I do LV extend. Okay. At any time, of course, you know this, but let me show you LV extend. At any time, you can go to the main page, and nowadays this main page is pretty cool because it has pretty decent examples. Okay, you can just come here and get inspired. Well, let me just copy paste this as inspiration. So let's do an LVS so I can know which one is which. So LV extend. Okay, I can say this in megabytes, kilobytes, or In this case, I'm giving it more 50 more megabytes, but I can do something like LV extend. So let's do a small L. Let's say 100% free. Okay. Of our LV. Let me go back here so I don't remember. Let's try this. Okay, cool. I'm sorry, I forgot a little detail. You need to put here the plus so we can add, because as you can see, it barely grew. Okay, let's do this. Now it's big enough. So add the plus to add space. So basically let me just rephrase that. So I'm extending this structure. This structure is showing me that the VG new has an LV. So this LV is on top of this, which is true. This LV is on top of this. So what I did here was to extend this guy using all the free space of this guy. So expand this using 100% free space of this. Don't forget the plus. The plus is very important. That's why the manual page has a plus. I just did not add it because I'm a dum-dum. Don't be like me. So this is going to extend this LV using all the free space that the VG can get me, because this LV is on top of this VG. If I go back to my LVS, you'll see that my LV now is 1 GB big, because we started with 500 gigabytes. I gave him another 500 gigabytes, so it's around about 1 GB. But my VG new, probably, it's completely empty. Okay, so my VG has no space to give, because my LV used 100% of the. Sorry, let's check this one. My LV used 100% free space of my VG, so I ran out of space on my VG. So if I go here, basically we are at this point. So our LV is using all the available VG space, which is fine. We can sort this out later. However, if I go to my df-h, you will see that even though the partition is 1 GB big, the file system, it's still half that size. Can you guys think about why? Why is my partition resized? My partition clearly is 1 GB, but the file system still thinks it's on the old one. Can you guys think about the answer? I know the answer, of course. So let me dive in that, okay? So basically, when we created the partition, it was 500 megabytes, right? And we made the mkfs command at this point. Now we have expanded this. Oh, you guys are not seeing. It's this one here. I'm sorry. So when we built the partition, we formatted using the command with the partition with 500 megabytes, right? In the meantime, we have expanded it, but the file system still thinks it's at 500 megabytes. So you need to insert the file system to say, hey, guy, please, I have more space now. Go and check it out. So you just have to do xfs grepfs. Why? Because we have the file system we created was xfs, so it makes sense. And in the perfect world, you just do this, and he will just understand the message. Okay. So we'll just make since the file system we made was xfs, you just say grow, please grow, and he grows to the maximum possible size, which is the 1 GB. No formatting, no rebooting, nothing of that sort. The file system just grew, and we are good to go. And this is, if indeed it was a 500 terabytes file system, it will grow as fast as this. Okay, it's really snappy, especially if you are using cloud resources. Cool. Now let's go back to our drawing board here. So let's say I want to create an LV2 here. I want to create a second LV. Can I do that? No, because my VG it has run out. So I want to expand another gigabyte here. To expand here, I need to go here, I need to go here. So let's create a new partition 1 GB big, convert it to a VG and convert it to a PV and expand our VG. Okay, so let's go back to the beginning. Gdisk. Let me just, I forget the name, but I can do this gdisk. This guy here, yeah. we will print new 4 fine 1 GB. 8, you know what this is? It's 8000, and it's LVM. We write, we say yes, we part probe. Be careful using part probe. And the whys are on my previous video. Go and check it out. Like and subscribe. And I do the cat proc partitions just to be safe. It's there. My P4 is there. Nice. So clear the screen. PVS. My P4 is not there. So PV create. It's going to be the 4. PVS. Very nice. Now this is my device belongs to no one. I want to expand this one. I could create a new VG, but I want to expand my VG to another gigabyte. So VG extends. This guy, I'm sorry. This guy gets this guy. Nice. VGS. Cool. Now it has free space. If I go back to my PVS, my VG new has 2 devices, 2 of 1 GB. So total space is 2 GB. So VGS, it's, well, free 1, but total 2. So which means that if I go to my LVS, this is the guy I already have there. I can create an extra one. Let's do LV create -n LV new 2. It's going to be 500 megabytes big, and it's going to use VG new. LVS. So my LV new 2, it's on top of VG new and using 500 megabytes. So if my VG new had 1 GB free space, I took 500 megabytes. So this is going to show me 500 megabytes of free space now. Makes sense. Now everything, it's back to the drawing board. You create a file system. LVS, LV scan. For mkfs -t xfs. This is the new. Remember, if you format twice, you will get notified. So it's kind of almost impossible to format a drive twice without getting warned. So you should be good to go. So nkdir mnt lv new 2. Let's take our cheat sheet here as usual, so we can copy paste to fs tab, v-atc fs tab. Now I have my custom thingamajiggies, looking pretty nice and pretty. I copy paste things incomplete, that's fine. Let's go back here and copy again. Let's go back here. My custom LVMs, bow, ka-chow. If you want to be as lazy as me, I will copy paste this. Oops. Mount -a. LES. Yeah, -h. There we go. And now I have my new logical volume mounted, which is don't forget my VG new has 500 gigabytes free right now, right? Which means I can expand this one, I can expand this one, or I can create a third one on top of this. See? This is how dynamic this can be. I could create a swap partition, I could create whatever. It's just when you do all the steps, and the main part here is on the formatting. So until you get here, you do the create, and then this can be a swap partition, it can be a regular partition. It all depends how you format and how you mount. All right? Pretty cool. So, if you want to rewatch this as many times as you want, you should. Ask down below any questions you may have about LVM and about this quick example that I just shown you. I have been using partitions, but you can use full drives. You can use the full hard drive for that. You don't have to use partitions. You can just PVS the hard drive or the storage device, and you're good to go. You don't have to partition in order to do so. So next, I'm going to do Statis. I'm going to look at my cheat sheet because I don't remember from the top of my head. But Statis, it tries to work as the same as LVM, but it uses a service. In theory, it's more simplified and more streamlined, which I don't agree on 100%, but it's fine. I don't use Statis in production. I don't think you should do it in production either. But anyways, I'm going to show how can you use Statis in a similar way. I'm going to look at my cheat sheet, so I might just stumble a little bit on my commands, but it's fine. And basically, this is going to create a data pool. So it's kind of quote unquote simplifying the PV create, VG create, and LV create. I don't think it simplifies nothing. It just complicates by adding a service in the meantime, in between. So get yourself comfortable with LVM. It's not that hard after a few tries, and Statis will just become a little bit uninteresting. But I would not forget myself if I wouldn't show you. So here we go. So first, make sure that it's installed. I probably don't have it installed. So DNF install. What is called Statis something. Statis CLI, I think. This is a command line, and Statis D. It's the service. I think I'm correct. No, I mistyped something. Statis. Okay. You say yes. I don't like this, but I have to show you. This is the goal of this chapter. Cool. Now, let's make sure this is enabled and started at the reboots. Not that. Systemctl. Enable. Minus now. Statis D. I know it is, but let me just make sure. Status. Okay. Yeah, looks fine. Cool. Now, what we're going to do here is add devices to the pool. Okay. So I need to do similar things like I did for LVM. So let's see. LESBLK. So I'm going to create a couple of partitions. Primary partitions would be good enough. I could use GPT. I could use MBR. I could use full drives. You don't have to be partitions. Take your pick. So, I mean, I have space here. So let's go to the gdisk. We're going to print. So let's create a couple of partitions. Just to make it different, let's do it a 2 gig new partition. Regular partitions are good enough, right? Yes. Parts probe. LSBLK. Cool. I have 2 partitions here that I can just add to the Statis pool. And let me go to my cheat sheet. Okay, so let's create a pool. Statis pool create /dev. This guy. No, not this guy. This guy here. Okay. Pool create, Statis pool create. I need to give it a name. Let's call it pool 1. Okay, we created pool 1. Now we used to do Statis pool, Statis. I hate this. Statis pool list. I have a pool that is made of 1 device. And it's 2 GB big because the device was 2 GB big. So this is kind of a PV create plus VG create in one sitting. I mean, it is what it is. Okay. Now, if I wanted to add a second one in the future, so an LVX stand of sorts, we can do Statis pool add data pool 1. And you specify the device. And if you do the pool list, now it's made of 4 GB big because it's 2 GB partitions. So this is kind of a PV create plus VG create. This is LVX stand. It's kind of I mean, I don't like it that much. Then you can create a file system. So Statis file system. Create, I believe, create. Let's give it the name of the pool, of the VG in a way, right? and let's call it fs1. So this is our mkfs. As you can see, I was not able to specify which file system because Statis uses XFS exclusively. So Statis file system list. There we go. Okay, it's always XFS, and will always show you a 1 terabyte big file system. I mean, it's not something you can just say whatever you want. Nope, it's XFS always, and it shows you always as 1 terabyte big. Okay, what we do next? We mount it, right? So in order to mount this, you need to do fstab things. mkdir, etc fstab. No, never mind. mkdir mnt. Let's call it Statis. Okay, mkdir. Let's get our sheet going. So this is our device. We can use the ID again. It's fine. And the folder. Now you just do etc fstab. Cool. Now let's do. Let's put it here. My custom Statis. And go here. Shazam. Oh, again, I forgot to copy paste this part here. Delete this, add this here. Bam. Cool. Now, you need to be careful because if it was a regular partition using kernel drivers like LVM, it will just do the thing you did here, right? But nope. This is a special one. So you need to do defaults. It's so far so good, right? Defaults. But now you have to tell the system you need to wait for Statis. So basically, since these are all kernel drivers, you just boot the system and the kernel takes care of everything. In this case, to have access to this, you need to wait on the reboot for the systemd to be served to systemd, which is, if you remember correctly, the thing that gem manages services. You need to wait for systemd to start the Statis service so you can mount this. I don't like this at all. Okay, these are kernel drivers; they are ready to go most of the time. Here, it depends on the service to have access to your drives. I say nothing else. It's fine, it's there, it works, it looks great. 1 terabyte, it always shows up as 1 terabyte, even though it's just 4 gigabyte. It always shows as XFS because that's kind of, you need to use XFS for the Statis things to work. So it is what it is. So this is Statis at its best. So going back to the commands, if your Statis pool runs out of space, you just get a new device, partition or full hard drive, and you just add to the pool and you're good to go. So it's kind of in my mind at least, it's a hyper simplified version of LVM with, well, too much simplified. The fact that it's depending on the service, it kind of makes me nervous, but it's me. I would not trust test with production level stuff, but for a quick data pool that's expandable, it's okay. But make sure your backups are up to date. Yeah. So I have been messing up a little bit the chapter numbers, but you see the thumbnail, you see the title. That's what it counts. So let's go back. Let's go here immediately. And what you're going to do what we are going to do now is going to discuss chapter 9, access network attached storage. In other words, you're going to set up. We're going to set up really quick an NFS server. Sorry. NFS server and an NFS client in simple terms, okay? And we're also going to discuss autofs. So this is all about the NFS server and NFS client. In simple terms, NFS is network file system, and this is used to share files. Okay, so if you are very anal about all of this stuff, and you know I'm not, we are going to set up a NFS server and network file system or network file server. You can call it whatever you want to call it. I forgot to set up my RGB light there, so while I'll do that because that actually bothers me. So if you are really anal with all of this stuff, you probably will disagree with my next description, but it is what it is. So NFS is a native and usually considered Linux native NFS file sharing service. So we're going to share some files. In Linux, in a network file system, we don't call it share a file. We call it export a folder. I mean, tomato, potato, whatever the case. So we are going to get a folder on our file system, on our designated NFS server, and we're going to export that folder, and that folder will be accessible through the network. So that's basically what NFS is. If you want some more nitty-gritty details, this is not the video for that. We're just going to set up a really quick NFS server. And basically our server, our Rocky 2 is going to be our NFS server, and it's going to be our NFS server. It's going to export a folder, and exporting that folder, it will be accessible through the network to other client machines. That's as simple as that, okay? So it's similar to sharing your folder on Windows, okay? It's similar. It's not technically the same thing. It has some blah, 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 differences and details. And I mean, it's different. Of course it is, or else it will be the same. But you are exporting a folder, and by exporting that, you are making it visible to the network using the NFS protocol. And that's what you have to know. Okay. So we're going to use Rocky 2 as our NFS test subject. And I don't really know if NFS server is installed or not. So let's find that out. So there are many ways to do that. So let's do rpm -qa grep -I NFS. So apparently it's not installed. So let's install it. systemctl. Oh my god. So dnf install NFS. Let's hit the tab key a couple of times just to see what we get. And you have NFS utils, client utils, CoreOS. It's probably, well, I know what packages it is. I'm just kind of making this a little bit of a scene. So let's install this, and let's do this. People have been asking me to do as most as possible on the videos, and that's what I'm doing. So let's pull this up a little bit. Cool. Nice. Now, how do I set up an NFS server? Well, I mean, you can do a simple setup or more advanced setup. I'm going to do, as you know, a simple setup for now. So I'm going to do a really simple NFS server setup. So it's well, simple. So the easiest way to do that, it's just do vi the etc exports folder or file. I'm sorry. Which is empty. So if it exists but it's empty, you are on the correct path. I mean, even with the server installed, with the service installed, it should be present but empty, which is fine. Next, to just tell the system what you want to export. So in this case, I'm going to go back to my previous stuff. And this is wow. Let's do this df-h. It's a little bit simpler to interpret. And I'm going to use this folder as an example, the lvnu2s folder. I want to export this. Let's call this lvm file dot file, whatever. Just have to have something there. And I'm going to export this folder. So I'm going to go here to the exports. I'm going to export this. And this should be plenty. Okay, this is all you need to do for a very simple NFS export. You can add more options here, but I just don't. You can do, like, for example, read write or read only sync. Well, I can, since I'm typing it, I can just keep it. Okay, and let's see what happens. So read only and sync are, well, read only, you know what that means. Sync is to keep everything in sync in terms of client and server. Don't worry too much about that. Just let's see if its server starts. Systemctl start NFS server. No news, good news. Status. And it started. I see no issues, and we are good to go. So as you can see, it's a very simple thing just to do a quick NFS server. So we just go to the etc exports, and you add what you want to export, and if you want to add extra options, you can. These are optional. You don't have to put them down there. If you don't, the NFS server will apply some default ones for you. Okay, so we are pretty okay with that. But if you want to be a little bit more, pretty, this is going to make it amount read-only. You cannot change. It's a read-only export or share, and this is going to synchronize the client and server. Don't worry too much about what async means. Just live happy. Okay, and we should be good to go. The status shows no problems. Cool. So let's assume the NFS server it's good. It's a-okay and good to go. Cool. Let's go to the client, and my client here is going to be Rocky1. And there are a few utilities I want to use. I want to use a command called show mount. I don't know if it's installed. Show mount, it's not installed. Okay, so let's try do it and do that. So let's try and find out. Okay, DNF, what provides? I know the package. Okay, I'm just doing a little bit of a show. Show mount. Well, no pun intended. Cool. And the show mount utility, it's available with the NFS utils, which is fine. So DNF install -y NFS utils. Ciao. And we are good to go. So the show mount command, what it does is that it's going to show us NFS shares or NFS exports on the specified server. So I know what I have shared, okay? And I know that some of you guys are just getting really nervous because I'm saying a shared folder. It's an export, but who cares? So I'm going to do the show mount, and I'm going to do the -e option and specify Rocky2. And this is going to show me what NFS exports or shares Rocky2 has, okay? This is giving me a RPC unable to receive message. Can you guys think about what might be causing this? What can be causing this? What can be causing this? The firewall. You are correct. So in order for the show mounts to work, and also for me to be able to mount some NFS shares on the server, this camera is way too red. I need to control the contrast. That's fine. I get lost sometimes. Sure. So I need to allow the show mount to work, which means that the firewall on Rocky2 is a little bit too restrictive. So I need to open some ports. And since I know what ports I need to open, let me walk you through that. So firewall cmd --add service and RPC bind. So this is going to allow the show mount command to work from the client. Okay, so firewall cmd --reload, and this should be able to. Okay, we still don't have all the ports open because we need another one, which is the mount D. Now we do the reload, and this should be enough. Okay, so going back to the history on the server, and if you open the where is it? The RPC bind port and the mount D port, RPC bind mount D, this will allow the show mount command to work. Okay, this is not going to enable NFS to work. Okay, this is not going to allow. This is not. You don't need this if you just want to access the shared folders or the shared export. You don't need this. You don't need the show mount to be able to access exported file systems. If you want the show mount to show you the exports, show mount will show you It's in the name, come on, right? So the show mount is going to show you exports, what's being exported by a server, okay? If you want to have this functionality, if you want this comfort in a way, you need to open RPC bind and mount D on the server, okay? You don't need that in order to access the files. You just need to have this possibility to show your mounting options, the files or folders that are shared by the server, okay? So you just need to open RPC bind and open the mount D if you actually want to use the show mount command and similar things. To access the files, you don't need that, okay? In order to access the files, you're going to use the mount command. So mkdir mnt share. So this is on the client, okay? This is on the client. Now just do the mount command. So do mount. You specify the server. I forget the full host name. Which is the full host name? It's lab on host name. Okay, it's like this. Okay, mount rock column, the shared folder, and the local file system, and you will see what happens. So you are just using the mount command to mount an FS share on this local folder. It's like mounting a mounting a partition, but NFS. Well, as you can see, this is just hanging. And do you know why the cause? Why it is hanging? Why do you think I'm connecting to the Rocky 2 server? I'm hanging. Do you see any errors on my syntax here? The mount command badly built. Nice English. No, it's fine. You just need to open another port here on the server, which is NFS. Now you should be able to mount. See, no biggie. The F-H on the client, and there we go. This is mounted, and it's mounted on this folder. Now, which means that every time I list this, I will see what was there, which I am. Pretty cool. I like it. I like it a lot. I'm overexposed here. Yeah, I digress. Cool. I can fix that. It's not good. Either I'm overexposed or my skincare is really good. I'll go for the second one. Cool. And I bet my logo being off-center is bothering some people out there, but deal with it. Cool. Yeah. So every time I read or write from here, I'm writing from this NFS server /share. This is not going to happen on the boot. Nope. You need to put this on the FS tab. So I'll just get this. If you want to mount it on the boot, if you want to mount on boot, you don't have to. I'll just show you how it's done. etc FS tab. Let's open here a pretty section. NFS shares. And bam. NFS defaults 00. How hard can it be? It's not. So mount -A, and this for sure will be mounted at boot. Just be careful, because since this is a network dependent stuff. Oops, I'm a dum-dum. Just to make it things a little bit more nice on the eyes. And in every reboot, this is going to be mounted through the network. Congratulations, you just have set up a simple NFS server and connected to that share from a client. Cool. Now, one thing that you probably have noticed is that, or you should know at this point, the mount command can only be used by root. Okay, so the mount command, only root can do the mount, which means only root can do this. But there is a way to allow non-root users to be able to access NFS shares without using the actual mount command, and that's by using a service called autofs. So autofs, it's a service that the root can set up for non-root users, so that non-root users can actually access NFS shares and other shares. Autofs, it can be enabled for NFS, can be enabled for SAMBA, partitions, regular disks, and well, other stuff. So autofs relates to mount, but by mounting without the needs or the need to be the root user. So only root can mount, only the root can mount. Okay, but if you set up the autofs service properly, you can allow non-root users to be able to access shares like NFS, SAMBA, or partitions. So let's set this up as root. So let's install it. Then install autofs. Yes. Okay, systemctl enable -- now autofs. Cool. Now it's installed and it's set up. Just by being set up, let me show you something. Right now, I am a non-root user, right? I am the student user. I am non-root. If I do the cd/net, there's a folder that does not exist. For example, Rocky2 does not have the autofs service installed. If I ls the / folder, there is no net folder. Okay? But in here, I have installed the autofs and I have started it as root. Now, regular users can do this, cd/net. And it's a folder that is only maintained by the autofs service while it's running. It does not exist on the disk. It's just something maintained by the autofs service by default. You can disable it if you wish. If I list, I see nothing. But if I type in the hostname of the NFS server, it actually does the mount command for me. Okay? So if the root allows this, because the root can, if needed, can disallow this, but the root installed the service, the root made it available, and by default the autofs creates the net folder, and within the net folder you can cd to the host name of the NFS server, and you can actually see the NFS mounts. Okay, if the root user allows that. So I'm not root, and I'm able to see the contents of the NFS server by just using the net folder. This is maintained by the autofs. So let me show you. So I go back to root. Okay, so if I see the master file, which is the main file of the autofs service, you see that I have some other options, of course. And this is the option that gives this capability of the root or any other user does /net and can then connect to NFS servers by using the hostname of the servers. Pretty cool if you ask me. If you want something more custom, and that's what I'm going to try. This is what I'm going to try now, because often at times, oh, my skin tones here are good. I need to check the camera. Okay. So often at times, you cannot, or it's not the best thing to use the net. I want something more custom. Okay. And that's something we can do. And now you are probably going to see me struggle with this, because I often cannot do this from memory. But people ask me for me to troubleshoot, so you'll see me troubleshoot. Cool. Now what do we do? So I know that I have this share, so I will try to do the following. Instead of going through the /net default share, I want to do cd/files, for example. And my /files folder will mount this folder and not the full net path. Let me try. If I fail, I fail. If I succeed, I succeed. I don't care. So auto.master, let's open here a section for us. My custom. This is just cosmetics, okay? You don't have to do this. My custom. So let's see. Let's see if I can do this. So if I do something like, something like this. This is called a direct map, I believe. Then I just go auto etc auto.files. What this means is that I'm going to have this file to configure a specific mount. Let me go through and you will understand. Cool. Now I'll build that file. etc auto.files. And here's I'm going to make it the files. Okay. It's going to mount the Rocky2 .example.com. And the share is, I forget because I am a dum-dum. And it's like, let me copy paste it. Okay. Bam. You can add the custom options of read write, read only, whatever. It doesn't really matter that much. Okay, so let's restart the service. Restart autofs. This is looking at so far so good, no errors. So my major syntax, it looks okay. Now if I do cd/files, okay, no such file. So let's review. That's fine. Okay, so let's try going to the master and do like this. Let's restart. There we go. Cool. Now what happens here is that let's review the configuration. Wait, -h. Let's unmount this because I'm mounting the same thing twice. What? No mount. Oh dear Lord. Okay, so let's systemctl. This systemctl. We start autofs /files. This is not looking good. The folder is there, but the contents are not. Okay, let me check my notes because I'm not far off. This is just probably some mistake of mine. Okay, let's install. Yeah. Yep. What did I do wrong? Okay, I think I know what I did wrong. Let's try this again. Let's go to the master file once more. And this is, I did it right at first. This is like this. This is what my cheat sheet tells me. Then I go to the secondary file. Okay, let's just move this around a little bit and put this here. Maybe it makes a difference. Or read only. Sync Rocky2 example.com mn2 lvenue2. Okay, let's restart. Now we're cooking. I was almost there at the first try. I just needed to add the options. I thought it was. Never mind. Okay, so let's get out of here. Let me show you the master file. So here we just need to do this. This is called a direct map. So you say I'm going to map a folder, and the configuration details are going to be here. And if you check this, you say okay, every time someone does cd/files, you mount this NFS folder with these options. So my mistake was I was putting this in the end. I think it was the first time in my life I put it in the end. Nice timing here, right? But yeah, I put it here because it's where it belongs. Okay. Probably the log file was showing me something and I just didn't check the log file. So don't do as I do as I say. Cool. So now every time I'm using the root. Every time someone does this, it's showing the contents of the file of the shared folder through NFS. So which means that if root sets this up, okay, then non-root users can just do cd into a specified folder, and that folder will have the contents of NFS share. Pretty cool. And this can be used for NFS, can be used for SAMBA, can be used for shared folders, whatever the case. See, this is basically mounting for us in a different path. So autofs, it's your friend. If you want to give non-root users the option to get some custom files from an NFS server on a specific path. Whew, so that was chapter 9. We have been through a lot together. I'm really happy to have you with me. Like and subscribe, it really helps. But before I do that, let me thank you for all the comments, likes, and the subscription that I have been having so far. It's been a really nice adventure to going through the RH124 134. We still have lots to go through the 134, but let me thank you in advance all of that support, all the support. I hope this channel grows even further to get this into more and more people out there in the world. Hello and welcome to chapter 10, control the boot process, roll the intro. Like and subscribe, comment down below, it really helps the channel to grow, and that's enough for the intro. So this is going to be all about chapter 10, control the boot process, and it's going to be 3 subjects: recover the root password, not by disorder, let's put it on the correct order, set the boot target, reset the root password, and repair file system issues at boot. I have covered the reset root password and repair file system issues at boot. I had covered that on a separate video. I'm going to link it here. I'm going to put it in the comments below. I'm going to put it in the end screen. But if I forget, which I might, that's how I am, just let me know in the comments below and I will correct that. But I have covered that on a separate video, so I will not cover that in this one because I already have covered. But I will cover the select boot target right now. So here you can see in the foreground you'll see root Rocky 1's console. Okay. In the background, you'll see Rocky 1's physical console. So this is SSH in the foreground, and in the background, you have the actual physical console of the server, because I'm going to do stuff here that actually is going to impact the physical console, and like that, you can actually see the things occurring. So let me get some root access first, and of course, I typed a password which is really short, and I still managed to get it wrong. There we go. So yeah, so we're going to cover what a boot target is and how can you set it. So if you come from other more older but not least important Linux, RedHat or other Linuxes, you are probably familiar with the term called the run level. Okay, so that was before we had systemd as our main process, if you remember. So systemd is kind of our mothership here, is a main process that manages everything else, or most other things else. And in the old days, I forget, but until rel 6, I think rel 6. So we had a process called the init. So if you are using a Linux of that old, or you are still using other Linuxes, which is perfectly valid, if you do the same thing like this, the ps means fpipe more, you will not see systemd as your main process, but you'll see the init. So the init process, it's not that, it just got replaced in some Linuxes by systemd, and that's fine. I'm going to cover systemd here because that's what it's about. This training is all about. It's about the rel 9, and it's systemd kind of the main thing. But it will rel 9, but this is way back systemd, and way forward systemd also. So yeah, at the time we had init, which was the process that manages all the stuff. It was init. Right now it's systemd, but at the time we had init and we had run levels. Okay, so run levels were kind of states where the machine could be. Okay, so run levels were a state where the machine could be found. So imagine this. I'm going to say something that, again, the most anxious of you will just be completely pissed, but I don't care. So, for example, in Windows you have safe mode or some of other recovery options. Safe mode with networking, safe mode without networking, and all of that. So run levels were similar things. I'm not saying it's the same thing. Calm yourself, okay? But for the less experienced, it's just a way for them to get an idea of what you are talking about. All right? So it was a machine state. It was a state where the machine could be, like a hardware profile, a software profile. And we had a few. So run level 0 was the shutdown state, shutdown. You had the run level 1 was called single user. I don't know if I remember all, but let me try. 2 was unused on rel, unused on rel at least. Because this could vary between Linuxes. So these are the ones that were using rel, but other Linuxes could use different numbers for different states. 3 was single use, not use, it was, let's call it normal. Normal, but no GUI. No GUI, okay. Then you have 4, which I completely forget. I forget what 4 was. And 5 was normal with GUI. Okay. It's not that important because I forget number 4. I truly forget what number 4 was. Never mind. What they were actually most important were the 0, which is shutdown. Okay. Oh, I forgot 1, and it had 6, which was reboot. Okay. Okay. So the main ones for now are going to be shutdown and reboot. So at the time, I'm not going to do that because I will just cause a shutdown or a reboot. If you did init 0, the system would just power off. If you did init 6, the system would just reboot. Okay. Or any other of the substates, 1, 2, 3, 4, or 5. 4 was unused. 2, I forget what it is. I think, oh my god, I'm so stubborn. No, 4 was unused. That's correct. And 2 was normal, no networking. Yeah, that's correct. Yeah, this is correct. Okay. So unused. Cool. So yeah, this one is correct. Shutdown 0 was shutdown, 1 single user, 2 normal, no networking, 3 normal, no GUI, 4 was unused, 5 normal with GUI, and 6 was reboot. Now this is correct. This is actually absolutely correct. Okay. That's why we did init 0 or init 6. These 2 would just start a shutdown or start a reboot or any other of the substates. But now, even though if you do init 0, it will power off. If I do init 6, it will reboot. That's just a kind of a retrocompatibility thing offered by systemd. Okay, you can do that. It will work. You can do that. You can do init 6, init 1, blah blah blah. Systemd will understand that and will do that for you because he's a good guy. But if you want to be by the book, if you want to reboot, you should do systemctl reboot. Okay, or power off to power off. Okay, so if you want to be completely cutting edge, you should do the systemctl. However, if by reflex or by habit you do init 0, it will just be fine. The server will easily power off or reboot with no issues, and you'll be perfectly okay. Don't worry too much about it. But what brings us here are the boot targets. So boot targets are basically similar to this. Okay. Calm yourself if you are eager to go to the comment section, blah, 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 blah. Calm yourself. It's not exactly the same thing. I know. But to get things a little bit more clear, that's what I'm going to say. So boot targets are goals to achieve. Where do I want to put my server at? And it's not that different in terms of results from the run levels. Okay, calm yourself. So, but we have much more targets than we had run levels. So run levels we had 7. You have much more targets on systemd. It's much more intricate than run levels. Okay, but calm yourself. So basically, I have shown you how to shut down and how to reboot. Systemctl power off, systemctl reboot. That's the similar thing. And I'm going to show you we have seen the equivalent per single user. That's where the recover roots password video comes in. Go and check it out. You'll get similar results of a single user mode. Similar, not the same, but similar. That reminds me, I have to make a separate video for all the Linuxes. Good idea. And I'm going to show you for how to get normal no GUI and normal with GUI, which are the 2 main states. Okay, so if you do systemctl isolate, this is going to choose or put yourself in a specific target, and you have the multi-user.target. Okay, now I want you to check out on the background what's going to happen on the server here on the background. If I do multi-user.target, and this server is right now in the graphical mode, which is a graphical target. If I do isolate, you'll see that now it dropped back to a non-graphical console. So that's the equivalent to normal. to normal with no GUI. So isolate multi-user target is going to put you on a non-GUI system. Even though the GUI is installed, it's not running. But if you do the graphical, if you isolate to the graphical, it will just boot up the graphical user interface. Okay, so if you isolate yourself to the multi-user, you will get the non-graphical console by default immediately. If you isolate to graphical, you will go to the graphical console as usual if you have the default going to the graphical. And how do you set the default? Well, systemctl set default, and you choose I want to go to this one or I'll go to this one. Right now, which one do I have? Well, you can get it. So by default, my default target is graphical target, which means on every reboot is going to boot into this state. Okay, and it's going to put yourself into a graphical interface on every reboot. So the default on Rocky 1 is graphical, but the default on Rocky 2, it's the multi-user target. We can check it out right now. Rocky 2. Oh, I cannot log in with root, but you can do this. Type in the password. Let's check it out. Systemctl, can you see it? Yeah. Systemctl get default. And as you can see, our Rocky 2 is going to the multi-user target by default because Rocky 2 does not have any graphical interface installed, which makes sense. So it's going to get it will not be too harmful if you put a graphical, just drop back to multi-user. But to be nice and well behaved, we have set the Rocky 2 to by default to go to multi-user. And these are the two ones that you actually need to know. I'm going to sneeze. I will not edit this. Hi. So yeah. So isolate will put yourselves into a specific target, and you have multiple targets that you can use. You can list them, etc. But these are the two you are most interested in. Multi-user, it's a non-graphical mode. Graphical in target, it's a graphical mode. If you if you use the get default, you will see which ones is going to get on every reboot. If you want to set a different one, you do set default. Okay. I'm going to set default for the same one. It's already there because I don't want to change it, but you would do set default and the target you want to go to on every reboot. Not every target is usable to be the default one. Some targets are kind of subsystem targets, so it's for the system to use. But these are the two ones I want you to learn and experiment with. Graphical targets, it will just go to the graphical interface if installed. Multi-user target, it will go to the non-graphical console. And that's that. It's easy enough. If you do the set default, you will set the one that you will get enabled on all reboots, and that's the one you choose. If it's a workstation where we work at every single day, the graphical interface makes sense. If it's a server that's kind of behind the scenes and you don't look at it, the multi-user interface seems to me it's kind of what makes sense. That's all about chapter 10, controllable target, root password reset, and other stuff. Go and check my other video. So the other subject I did not cover here are covered there. Watch it, rewatch it all the times you want or need. Like and subscribe, it really helps, and comment out also. So like, subscribe, and comment, it really helps. Hello and welcome to chapter 11, manage network security. Roll the intro, like and subscribe, and comment, it really helps. And that's quite enough. Okay, cool. So I'm going to discuss here two things: how to make basic firewall rules and how to manage SELinux network or port labeling. Okay, so let's start with something we already know. You have seen me use this before in previous chapters, which is how to create basic firewall rules. Okay, so let's get. I'm on Rocky 2, but this works on any Linux actually. So, okay, cool. Again, I cannot type a simple password because that's how I am. Now, I have here in the background the site we have configured a few chapters back, just to show that actually it's actually working. We did this on the SELinux chapter, so go and check it out to see how this actually came into play. And let me just show you how you can do simple firewall rules. So nowadays we use one of three possible tools. You have firewall CMD, okay? You have firewall CMD. You have the cockpit. If you haven't seen me set up cockpit, go and check it out, the RH134 course. And you can sometimes also install the text user interface version. Here we're going to use the CMD for some simple firewall rules. That's all you need to know for now. So let's first of all list the current firewall rules. So firewall CMD -- list all zones. Okay, this is how I do it. So what are zones in firewall? These zones are a bunch of rules. Okay, zones are a bunch of rules grouped together. So you create zones, and those zones have a bunch of rules grouped together. That's as simple as that. Then you can get those zones and associate them to interface. Okay, of course, there's more than that. Stop wiggling your chair and typing hate comments on a comment section. This is just a simple explanation. What zones are just groups of firewall rules, like things that you allow, things that you deny, grouped together, and those groups can then be associated to a specific interface or interfaces. You can set a zone for NAT, for example. All right, so calm yourself. So these are all the rules that exist, and these exist at this point. So these are all the rules that can be considered the default ones, okay, which are the ones that come with the default installation of the firewall CMD thingy-majiggy. All right. So these are all the firewall rules that we have by default. So I have not created any other rules, and let's focus this one because the default it's kind of the default. So when you create new rules, they are placed here unless you specify something different. And as you can see here, I have enabled a few rules: cockpit, DHCP. Some were already there, some I have added. I added this one on the SELinux chapter. I added this one, and this one when you discuss the network attached storage course chapter. So go and check those out so you can learn why I use them and why were they useful. Okay. And of course, like, subscribe, and comment. It really helps. Okay, cool. Now, let's start by this. Where do these names come from? Well, these are called service profiles, and you can get them by going to etc. No, sorry, not etc. USR, lib, I forget. Let's find out. Firewall these services. Well, I did not forget. I actually know. Cool. So these are XML files. So if I check the HTTP protocol, so these are XML files you can actually customize, create new ones with the command line. I'm going to show you how, or through the cockpit. So you can just create simple profiles. So when you add a port, you don't need to know the port number exactly. You just add a profile with its name, and it's kind of a simple way to enable more common rules in your network, which is quite nice if you ask me. So how do I create custom ones? Well, this is my process. So I will not touch this. I will copy any file. I'm going to use this one because it's the one I usually use, and I'm going to use it like a template and copy to etc. firewall D. I cannot type. Firewall D services, and I will put it there. Why not add it here? Because this folder may be updated on, let's say you update the Firewall D package. Okay, you update a Firewall D package either directly, either through some other bigger update. This folder may be overwritten by the update. This one is kept safe. So any custom stuff, you should put it there because you have a greater chance of survival. Then I will rename it. Let's call it custom.xml. Okay. Then I just need to edit. You get the idea. Okay, I don't have VIM installed here, which is fine. Okay, so I'm going to, this is fine, service, let's call it cust. Okay, then I would just delete this and put something, well, more Yeah, there are easier ways and faster ways to delete all of this. Calm yourself, okay? Calm yourself. So custom service, it's not that serious. Then I just add the port. So I'm going just to make this up a little bit. 81, for example. Let's 82. I'm not going to use this rule. Well, I can. It's not harmful. I can put here UDP. I mean, it's fine. You get the drift. Now I just save and quit. If I want to add this service, I will do firewall cmd -- reload. This is going to refresh everything, including the new rules, the new service. Then I can just add it, firewall cmd -- add service. And now I can actually use the tab custom and permanent. I can, just for you guys to see, I can add it to the zone. DMZ, for example. So it doesn't go to the default one. Then I just go firewall cmd -- reload. And I can just go back and list it, like I did in the first command here. Now, if you want to be a little bit less confusing, you can grep for DMZ. Okay, but you can do the after 15. So this is going to print the DMZ zone and the following 15 lines or less. Okay, or less. As you can see on the DMZ, let me put the comment back here. So I said add service to my custom one on the zone DMZ and make it permanent, and I just did it, and I did the reload, and it's there. If you want to add a port, well, you can do add port. Let's say add port, let's say, I don't know, 100/TCP or UDP. Then reload, then you list. There you go. Ports are there, custom is there. See, not big of a deal, very doable, very straightforward. Well, if you come from the IP tables era, in a way, you may feel a little bit out of your league, out of your element, because we were so used to use the IP tables thingamajiggies that may cause that type of discomfort. But it's all okay. Take your time and get used to it. And you can also use Cockpit if you feel in a pinch to get things done, if you are kind of forgetful or something like that. So yeah, you can just use Cockpit for that and make your life a little bit easier. There's no shame in that. So use Cockpit because it's there for a reason. All right, cool. That's very simple firewall rules. You can enable NAT. You can specify source IPs, destination IPs, source networking, source networks, destination networks, all of that good stuff. Just use and abuse the tab key, and I'm sure, or go to the Cockpit in a pinch, and you are fine. Next one for chapter 11, it's SELinux port labeling. So what is port labeling? Well, as you know, as you remember, because I have covered that on the SELinux chapter. Go and check it out if you haven't. There are several things where SELinux it's in charge. File labeling, port labeling, and port labeling, it's kind of a bind between the process and its network port. Okay, so if a service that has a specific talk context, HTTPD, for example, does not have the correct port labeling, he will not be able to explore that network port in a way. So I will show you that in a second. I'm going to put, I'll try. I'm going to put the HTTP service on a non-standard port, TCP port, and even though it's allowed on the firewall, okay, SELinux will not allow it to function because the binary of the process cannot attach to that port because SELinux does not allow it. So it's not a matter of the firewall allowing or not that port. It's a matter of the kernel allowing that binary to attach itself to a specific port, which is even more aggressive. So in a way, this supersedes the firewall rules. It may happen you have a firewall rule saying yes for that specific port, but the server does not work, even though the firewall rule allows it, because SELinux did not allow that specific service to bind itself to a specific port number. So, for example, in this case, I'm going to change HTTP to bind himself on a non-allowed port, and it will fail. I will disable the firewall, and you see that it failed the same because it's on the kernel level and not at the firewall level. I know the firewall is also on the kernel level. I know, calm yourself, but it's at different stages. So even though the firewall says yes, if SELinux says no, it's a no. That's the bottom line. So firewall say, for example, port 100, just an example. So if the firewall says port 100, it's okay, but SELinux says this process cannot bind itself to port 100, it's not okay. The firewall allows it, SELinux does not, SELinux supersedes. Okay? Cool. Easy enough. So let's get this. So it's clear enough that port 80 is working, right? Because it's the default one. Makes sense. So let me change the HTTP service to work on a different port. Let me try and think. Let's try. Is port 85 okay? I forget. So let's check. The file called etc services. So this file lists kind of the stay away network ports. So I don't want to use a port that may be used by other services, so I don't get myself into troubles down the line. So let's say port 89. Okay, 89 seems to be safe. I will not get myself into troubles with other services. 89. So I'm going to go to tpd conf htd.conf, and I'm going to find the listen. It's there. Okay, so I'm going to do this. I'm going to copy paste, and I'm going to 89. Now I'm going to restart the service. Restart httpd. It will fail, hopefully. Yeah, it failed. Now, if you check the logs, which we will, you will see, well, I don't have everything installed. So, but you see here, you cannot see the full message because it's kind of too big, but it's basically saying that SELinux is preventing blah, blah, blah to bind itself, okay? And even suggests the solution, but we'll get the solution in a second. So let's see if we can check it out here. See, SELinux is preventing the HTTP service to bind itself to the port 89. Okay, so basically, I want, but let's say you want this to work. Okay, this is not working because the HTTP binary service is not allowed. It's not allowed by SELinux to attach itself to port 89. I will create a rule saying yes. So I'm going to add port 89 TCP to the default zone, because I know I will need it in the down the line. Reload. Fine, it's there. Let's confirm, because I know some of you guys are really suspicious. Let's go to public. And as you can see here, port 189 was actually added. It's fine, but the service still will not restart. Okay, and obviously, if it's not restarted successfully, then I cannot access it. Okay, why? Because SELinux is not allowing the process to bind to the port. So this says yes, SELinux says no, it's no. There are different stages on the kernel. All right. Okay, cool. Let's fix this. So SManage port minus L. This is going to list the ports, and I'm going to grep for HTTPD. Sorry, HTTP, not the protocol itself. Cool. Now, as you can see, port 89 it's not here, so we need to add port 89 to the list. So to help you out, let me show you this. SELinux. Let's go to the bottom, and let's find the sub page for that. or is it Boolean, don't audit, SMNH export, fcontext, import, interface, login, module. They don't have it here. Okay, that's nice. They used to have here a sub page for the ports. Oh well. Oh well. Port maybe? Oh, we got lucky. Good. It was there. Was it there and I'm just blind? No, it's not here on the subpages. It used to be. Oh, it's there. Yeah, I'm blind. All right. If you go here, you can go to the examples and you actually see a good example on how to overcome this. Bam. Just need to add your port. Double check. Restart the service. Now it's okay. And we can actually use port 89 to check our website. That's it. So if SELinux says no, it's no. Okay, so you have two entities working for our own benefits, which is a firewall and SELinux. So don't just focus yourself on the firewall, because sometimes SELinux is also doing its thing. They're just trying to protect us. They mean no harm. So just make sure that everybody is on the same page. Well, that was Chapter 11, Management for Security, all about simple firewall rules and simple port labeling about SELinux. We are quickly reaching the end. We have 2 chapters on RH134 to cover. Install RedHat Enterprise Linux and containers. Thanks for sticking with me throughout this adventure. I'm enjoying this a lot. I'm enjoying the comments. Like, subscribe, and comment. It really helps. Hello and welcome back once more. Chapter 12, the one you have been waiting for. And maybe not, but well, it is Chapter 12, which is install RedHat Enterprise Linux. Well, the procedure I'm going to show you applies to many other Linuxes, not only RedHat, but I will focus on RedHat, of course. That's the purpose of this video series, but this applies to many others, so all this info can actually be recycled in other situations, not only on RHEL. I'm going to focus, well, this is about two procedures. One is a regular install of RHEL Linux using the interactive way, the standard way, which I'm going to show you, but I'm going to put that on a separate video. Okay, so like and subscribe to get notified about that. So I'm going to make a separate video about installing an interactive normal, that's called like that, RHEL installation or any other Linux installation. This is going to be all about the unattended install, also known as a kickstart install. Okay, so I'm going to jump here to my terminals. And at this time, I'm not going to use SSH, just because I feel more natural doing this directly on a console. So this time I'm going to use my usual 2 machines, the Rocky 1 and Rocky 2, and I'm going to install Rocky 3, but I'm going to show you in a second. So the unattended install of RedHat Enterprise Linux or Rocky Linux or any other Linux, for the most part, is based on the creation of a kickstart file. Okay, the file does not have to be called kickstart file. It can be called whatever you like. I usually call it ks.cfg. ks kickstart makes sense. cfg config, but you can call it whatever you want to call it. You can call it sql.cfg, web server CFG, workstation.cfg, whatever you feel like. Okay. After getting that file done, and I'll show you how it's done in a second. After getting that file done, you need to get that file, put that file somewhere, a pen drive, hard drive, whatever, and of course on the network, which is going to be the one I'm going to use here. It can be an HTTP server or an FTP server. This most often is used in conjunction with the PXE-boot. If you don't know what PXE-boot is, I can make a separate video about that. But PXE-boot allows you to boot from the BIOS through the network. you obtain an IP address and other stuff, and you don't really need any boot media like a USB or CD or DVD to boot successfully your machine. You just boot your machine from the network directly from the PXE boot. It's also called PXE by PXE. It can boot from the BIOS directly from the network and you don't need any install media whatsoever. But that's for another moment. Now I'm going to show you how to create a kickstart file. How can we just read the kickstart file, verify that the kickstart file is okay, and make it available and use it. Okay, cool. So I'm gonna show you how to build a kickstart file. So you have many options to build a kickstart file. The first being you just shoot or open your VI utility or PIC or Nano, whatever or whatever utility, and you off to the races. You build from scratch. You can, if you want, and I'm going to put the link down in the description below. Go to the official RedHat website that they have like a config tool to create a kickstart file using your web interface. However, you need to have a subscription to see that tool. A regular login is not enough. You need to have the regular login, and also a subscription. I know, call myself. I know that there are free subscriptions, okay, that you can obtain. So it's not that big of a deal, but still it's still a hassle. So at this point in time, this is the only way I know how to kind of get a web interface or any kind of interface, so you can get this tool up and running. So this tool is going to help you through the graphical interface or through a graphical interface to create a kickstart file so you can use on your deployments. Okay, there are no other ways that I know. I mean, I know the way that it's free, that is using older versions of Linux to get that going. But if you want to get informed and learn how to use a free utility to create kickstart files, like and subscribe and get notified, because I will make a separate video about that. So you don't depend on this site or any other site. You will just depend on yourself and get a nice tool to get you started, kickstarted. A nice tool to get you started and to create your custom kickstart files with some help of an interface. So you don't have to build the files from scratch yourself. Another option is you just Google, and there are many sample files that you can work with and use it for your benefit. Okay, so I'm going to make a separate video all about the free tool to generate kickstart files that you don't depend on this tool that RedHat provides with exchange for a subscription. But get subscribed, comment and like, so get notified about that new video coming out really soon. But at this point in time, let's use the old school way, because I have here a file ready for you guys, and I'm going to share this through the web interface. So I'm going to put the third machine, Rocky 3, through the regular DVD, okay, or in this case the ISO, okay. And at that point in time, our installation process has network access. So at that point in time, we can use network resources, and the resource I'm going to use is going to be the HTTP server that we previously installed on Rocky 2. Okay, so we have Rocky 2 installed, and if you remember, we have here the web interface ready to go at port 89. If you have not seen that, go a few videos back and watch the whole series so you can get notified, okay? Or informed about how did we manage to get here. I would advise you to watch the video about installing new services and how to control SELinux. Go back there, check those out, and come back here, and you will understand how this server came to life. Then, during that video, I actually created this folder, the var sites www folder, and here I have my default index file that we created in that video. Okay, that allows us to have a simple custom file and a simple website. I mean, and this guy here, that ks.cfg file, is the one I have created from scratch. So I'm not a kickstart file creation guru, but I know a few things, and I have some cheat sheets here that I used, so I could create a custom key, a very simple custom kickstart file, and I'm going to show you. And I'm going to check the file. This is a very simplified version of a kickstart file that can get very complicated. Okay, in good terms. So this version thingamajiggy, it's commented out, so it's doing nothing major. It's just for the most part, my personal reference. And my microphone was speaking. I'm sorry. It's for the most part, that first line is for my personal reference. This one here, I'm going to add some comments here. Maybe it's help. This is going to be language of install. Language of the install. Okay. This is my keyboard layout. Keyboard layout. Using doing the installation. I mean, for most part, these are kind of what you see, what you get. My time zone, NTP. The password for the root user, okay. Which is in this case, I have some notes here because I'm going to. This is the line I am using, the root pw, and this is the password for the root. It's in clear text in the file, but it's going to be encrypted, or not encrypted. It's going to be protected. Call it encrypted if you prefer. It's fine. So even though it's set as clear text here, okay, it's going to be set on the shadow file protected. So here it's clear text. When the shadow file is created, is encrypted. So it's okay after the install. Okay. You can also use this previous line here to crypt this requires a separate procedure. I can cover that on a separate video if you like. But this is how to create a protected password to be included on this file. So it's encrypted in the file and in the shadow file. In this case, I'm using a clear text file here on the file, just to make my life simpler. Reboot means reboot after install. Okay. After install. So this means that you put things going unattendedly. So kickstart is to make an installation without intervention. So things are just get installed. You just go have lunch, come back, and everything is done, and the reboot is done. This is going to use a text installation. It can also be graphical. I do prefer text, but that's my preference. This is where the files are. Okay, this can be I can be using. This is telling I'm telling okay, this is going to be using our CD-ROM, or in this case I'm using a VMware virtual machine, so it's going to use a virtual CD-ROM, and in that virtual CD-ROM I have my ISO of the RedHat Linux installed. It can be an FTP server, an HTTP server, a local location, anywhere, well, anywhere for the most part where the files can be found. This is things you want to add to the bootloader. In this case, I don't want to add anything. This is just for me for my reference. 0 MBR means clear disk. Clear disk before install. Okay, so if you have a disk with something there, it's going to clean the disk before starting the installation. It's kind of good practice to avoid installation errors because it's just a fresh start, so you don't get prompted for some fixes. You don't want to get prompted, right? You want to install this to start and finish, and without hesitation and without pauses. 0 MBR, clear part. So this is going to clear everything. This is going to make auto partition. So Anaconda, which is the installation that software is going to install RHEL, is going to decide it's himself or herself, I don't know, how to partition, and that's fine by me. Then you have the network part. Network config. Let me just resize this because I'm losing a few parts here. There we go. Better. Cool. And this is all about SELinux and Firewall. It's pretty self-explanatory. And then this is what to install. Okay, you can use packages, which is what the add symbol means. Minimal install, core, base. I mean, you need to check what are the packages that are available. The easiest way to do it is to go to a already installed machine, any machine, and just do DNF group list. Okay. And in this case, I'm using the minimal install taken from the environment groups. Okay. So this is the bare minimal installation, which is pretty enough for me. Be careful, because even though everything is rel based, the environment groups can have different names. Sometimes we have the core, base, minimal install. Go and check the name of your specific one. Server with GUI also. So you can find the name of your group of packages you want to deploy, or you can just simply put here a list. I want to install Firefox. So an actual list of what you want to install one by one. And if you put a minus like this, for example, this will not install Firefox. Okay, this is going to avoid Firefox the Firefox installation. Okay, you put a minus and it won't install. But like this, I want to install the minimal install just to make things quicker. And that's a pretty simple and effective example kickstart file. Okay, so let me just pull my notes. There we go. Cool. So just a quick review. Language, keyboard, time zone, password. This is in clear text, but it will be put in the shadow file protected after the installation. Reboot offer install, text mode install. The files are on the CD-ROM, or in this case, it is the ISO that plays the part of the CD-ROM. Clear everything on the disk. Reset everything on the SELinux, very standard. So this is going to be enforcing and enable firewall with the exception for SSH, which is pretty standard. How to initialize the network card, and the installation is going to be the base install. Okay, I'm going to save this, and there it is. Now, in order to test this, I can use the kps validator, which is not installed here. So I have this set up. So you can do kps provides to see how can you obtain this, and you know this already, but I like to show you guys install. So this package will make available the KS validator, which is a tool that's going to validate our kickstart file. Yeah, hurry up, please. People have things to do. So KS validator, ks.cfg. So no news are good news. If there was any problems, let me show you. For example, I can do this enc. Hopefully it will show us the error. Okay. So no news are good news. Of course, any syntax errors he will not detect. So typos, for example, if you have here the password badly typed, for example, so things that are user error, he will not detect. Things that are actually syntax error, it will detect. It's not foolproof, but at least it's a good reference, so you guys can kind of know, okay, this is going to go well, this is going to go not that well, but it's something good to use. Okay, cool. Next, now we have everything ready. So I'm just double checking to see if the file it's obtainable through Rocky1. So if Rocky1 can read the file, Rocky3 is going to be able to read the file too. I don't see why not. So here I have a test machine called Kickstart Test. I'm going to boot it as normal. I'm going to stop here, and I have the usual install menu. And I'm going to highlight the first option. And instead of hitting enter, don't hit enter here, hit tab for extra options. And I'm going to instruct the installation procedure where the file is. So inst.ks. So if you are an old school guy like me, you probably are used to do ks equals, go directly to the file, but now you need to do inst.ks. If you don't do this, you get bombed on the installation procedure saying this is deprecated, you need to use blah blah blah. So just use inst and just get it over with. So http :// and the IP address 192.168.1.251. So basically I'm typing the same thing I was typing here. Okay. In this case, I don't have a DNS server on my network yet. So I'm just using the IPs, which is just fine. And I forget the port. The port is column 89. Okay. Column 89. Okay. And I'm going to do /ks.cfg. I'm just going to double check this. So ins.ks, http, looks fine. I'm going to hit enter, and now I just wait, because if I can contact the kickstart file, either being through storage or through the web server, FTP, HTTP, whatever, I think if the file is accessible, you're off to the races. You just need to wait. And there we go. He's retrieving the KS file. It's going to take what the time it has to take. I saw no errors at that stage. If you see no errors on that stage, you are in good standing. So for the most part, the KS file was found and doesn't have any serious errors. Things are going to kick off. Text installation. This is already being pulled from the kickstart file. And there you go. You are just getting... this is just a matter of patience and wait. This is normal. Again, normal. Checking storage. Now it's checking to see if there's a hard drive or whatever storage available. So it's done. It got everything you wanted from the file. It cleared the disk, and now it's starting the installation. And I'm going to put this here, and I will not edit this out. I am not going to fast forward. I'm going to let you guys watch this in real time. And there you go. You just need to wait. I could just sing for you guys, but I don't sing at all, at least not in public. And I'm going to just quickly mute my microphone so you don't have to hear me breathe while this is installing. And you just need to wait it up for it to install. You can just fast forward this on YouTube and just till the end, because it's going to be basically this for the next 5 minutes or less. And it's going to reboot and give me the console. And I'll come back when this is done. And you can just fast forward or play it in 2 times in YouTube so you can get this over with if you are just feeling a little bit nauseous. And I'll see you in a few seconds. Yeah, I'm doing nothing. I'm just observing. He's doing everything for me. Isn't that wonderful? Almost done. There we go. So final reboot, and we should have a fully functional freshly installed machine. I'm going to log in as root so you guys can just have confirmation, but there is no reason for it not to work. Okay. There we go. Fully functional with unattended procedure of our Rocky 3. So this was chapter 12, all about installing Red Hat Enterprise Linux or any other Linux for that matter. I have basically done an unattended installation. This is going to be the main theme of this chapter. I'm going to make a separate video outside of the RH134 sequence about the normal installation, but you can also like and subscribe to get notified. I mean, like, subscribe, and comment out. It really helps the channel to grow, to get this to the most people as possible. Welcome to chapter 13, running containers. This is going to be all about the execution. We'll jump on the console itself in a second. Let me just give you a quick rundown of what a container is. So basically nowadays you have three ways to run applications, pieces of software. You have a physical machine, which is a bare bones hardware-based machine where you can run your solution. You have virtual machines that require a hypervisor to be installed, or you have containers. Very short, physical machines means that if you imagine you want to run a web server. A web server, if you install a full-fledged PC, 64 gigs of RAM, blah, 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 then you run the web server, you are underusing that machine very much, because the web server does not require a full machine to be run most of the time, and you are underusing the physical machine. This is a very short version, okay? This is just a very short version. There's much more to be said, of course. Then you have virtual machines, where you have a hypervisor, okay, and you can have multiple machines running on one single hypervisor. That's much better in terms of resources optimization. But again, you'll have a full virtual machine just to be running a simple HTTP server. You can do it and it's fine. Or you can run it in a container. Simple terms, a container, it's a tarball file. Sorry. It's a tarball file. Cannot type today. I'm tired. Long day. Creating content. It's a tarball file. It's basically a zip file of sorts, and within it, you have the bare bones minimal information to run the application. If it's an HTTP server, it's the bare bones code to run an HTTP server. For example, a web server can be a tarball as small as 500 megabytes or less. Okay, it's a zip file with the elements just needed for this container to be considered a solution, a web server. Kernel things, drivers, and everything else, it's running on the host. And the host does not need to be a full-fledged hypervisor. It just needs to install the container environment. For example, Podman. Okay, Podman is one, and Docker is another. Okay, these are very common names. So these are pieces of software, Podman, Docker, and any other. Add any other you like here. They are all good. They are very simple pieces of software that will run the container. Raspberry Pis can run container very effectively. Raspberry Pis will not run a hypervisor very effectively. You can have multiple containers running on a simple Raspberry Pi. Things like a web server, a DNS server, and stuff like that. You can run multiple containers successfully on Raspberry Pi. You cannot run multiple virtual machines on a hypervisor on a Raspberry Pi. Yeah, I'm going on a little bit on the extreme, but you get the idea. So it's called containers are a very, very simple way to run applications. They are very discardable, which means I can delete a container and rebuild it very simple in a very fast and effective way. You'll see that in a lab in a second. You can update containers very fast. You cannot update VMs very fast. Well, you can in some situations. Okay, this is just a very simple explanation. Don't be a keyboard warrior and say bad things here. Very simple explanation. So it's a very simplified way to deploy solutions, update, and do an upgrade, for example, to our web servers or our fleet of web servers. So here you're going to learn how can we obtain a container. One way, there are multiple ways to obtain a container, get it running, and get it running as a systemd service. So yeah, the first thing we should do is just install stuff. I would suggest just do the following: dnf install. Let's install this one here. And this guy here, we should be good, and we should be good to go. Just let it rip, and just wait. And we have installation complete. If you have packages already installed, cool. If you don't, just install it, and we'll probably most likely have 100% of the tools that we need to carry on. So now let's search for an image that is based on, that can offer us HTTPD, okay? And I really want to find one that is RedHat based, okay? So let's try to get this one, Podman pool. Let's try, I don't care about the version, they work similarly. So let's get this one. And let's see if we can pull this image. And here we have it. So we have the UBI version 8. This is coming up nicely. Just to be a little bit more up to date, let's try after this one finishes. Let's try and pull the UBI 9 to see if you are successful. This is a universal base image. This is basically the bare bones image, but this one includes the Apache web server, which is the one we want to use to our testing. Let's try that one. Maybe you can get a little bit more up to date. Let's see if you can get it. So yeah, so I think I'm happy with that. So the registry RedHat.com, it's the registry access.RedHat.com. You can use that. It's free and it requires no login. It's basically open, anonymous. You can pull it. Okay. So we have some images now. So let's do Podman images. We have a few. So this one, it's based on Ubuntu, which is fine, but I really want to use something based on Red Hat. So next we will start a test image with this one just to poke around and see what you can get. So let's start just a quick container with this image just to poke around the container. So Podman run, this will run the container. We will specify the -d. This is the daemon option. This is make sure that the container is running on the background. You can give it the names like test web. Cool. I will not do anything about ports or local folder mapping. I just want to run it and see what gives here. Oh, I already have one. Strange. Podman PS. Oh, I have one spawned. I didn't remember that. So Podman RM, and we can just get rid of it. Okay, Podman stop first. That's fine, and then remove it. Podman PS. Cool. Now let's try again with this RedHat based image. So Podman PS. It's running. It looks good, and it looks to be running on port 8080. Which is fine. Let's just get a shell going. So Podman exec -it, did, and bin bash. I think we have bin bash here. Do we have bin bash? We do. Cool. So this is the container itself. So cd etc http d conf hd.conf. Okay, not a directory. Yep, correct. So this is a text file. Let's grep for port. Let's clean the screen. And is this the correct one? Let's vi into that. I don't really remember what is a parameter to confirm it, but you can just poke around of the config file. VM is not installed. Yeah, it's a basic container. So server root. I'm tired. It's listen. Of course, not support. It's listen. I'm just old and tired. I'm tired. Long day. So yeah, port 8080. So we know what port is listening to, even though we already knew that because the podman ps output actually confirmed that. So cool. So let's forward our port 8080 to the test server. Okay, and let's map also a local folder on the next steps. So it's time to run our test container. So now we have podman images. We're going to use this one here, and we're going to map a local folder to remote folder. I have my local folder already set up, so it's here, home, student, what I call it, web server, and this is going to have a simple index.html file. So basically, sorry, this is going to be our root folder of our container, var.ww.html. Okay, so let's do podman run done. Podman run, demonize this guy, -- name web server, forward the port 8080 to 8080, the remote server as we just found out. We'll map the local folder, so home, student, web server, and web server to the remote var www HTML. Okay. Please fix all the SELinux thingamajiggies. And the image you're going to use, it's going to be that guy there. So let's just review. Podman run, demonize it. It's going to call web server, forward the port 8080, and map the local folder to the remote folder. var.whtml, which is the default URL, fix all the SELinux stuff, and use this image there, which is awesome. So let's do podman ps, looking good. So let's do curl http server a.lab.example.com, port 8080. I missed that. Curl server a.lab.example.com, port 8080. Okay, something is that going south here. Yeah, it's not server A, it's server B. I am a dum-dum. Server B is running the container, not server A. And there you go. So I'll keep this in just so you guys, if you run into some similar issues, you know what's causing this. So I'm on server B, not on server A. As simple as that. And we have now a running container that is running a local folder, has a remote folder. It has all its SELinux contacts working fine, okay? And it's running HTTP, and it's forwarding port 80 of the local server to port 80 of the container. So we have now a successfully running container. And now that we have a successfully running container, it's time to make it sure that it runs as a service, so it comes up automatically at server reboot. So people, this is one way to get the container up and running at when the server reboots. So let's do the procedure. So basically, you're going to create some structures for systemd to enable this container to be dealt with as a service, so it can stop, start, enable, and all of that good stuff. So I do this very seldom, so I need to check at my notes. But basically, you will create with the container running. You just do mkdir
mkdir -p and create a folder on home, whatever the user. I'm using student, use your own. The config folder should already exist. Systemd user. Then I'll navigate there. And we're going to use a procedure that is currently deprecated, but still works. But I will make an updated video about that in the future. But for now, this still works. We'll get a warning. I will get a video update in the future. Like, subscribe, and comment to get notified. So podman generate systemd --new --files. New files name, yeah, web server. Cool. So this shortcut using podman it's deprecated, still works, but in the future I will make an update about the quadlets, what they are and how can I use them. But for now, it will work. This is going to create a new service file that you can dealt with this container as a service. So we can use systemd to start, stop, and enable this container as a service. Okay. And that's exactly what we want. Now we stopped the container. Podman stop web server. Okay, then we just remove the container altogether. Cool. Then we confirm that it's off. It is. We reload the configurations of systemd -user daemon reload. Okay. If you get something like cannot connect to the bus, cannot I don't remember the exact message, but cannot connect to the bus error or something like that, just Control-D, close all SSH sessions, reopen a fresh one as the user that has the service, and try to come in again. So if you get something like dbus error or connect to bus error in red or something like that, log out of your session and log in back with your user. Close off any su sessions, any sudo sessions. Fresh start from the beginning with the user without su or sudo, and this would work. It can happen if you sudo many times, and the system just gets confused. So let's just enable this. So systemctl -user enable --now container web server. Okay, looking good. Now if you do a podman ps, you have it there. Okay, and if this works, it should be perfectly okay. Now you need to enable the linger option, so you don't lose the credentials. So login ctl enable linger. Cool. And let's list that everything's okay. Login ctl and show user student. Perfect. Linger should be yes. I just saw it. It's there. Okay. And now you can just try again. Curl http://serverb.lab.example.com 8080. There we go. So systemctl ctl --user status. What was it called? I forget. Container something. Okay, container. And it's active and running. It's enabled, which means when we restart the server, this container will be automatically up and running and enabled through systemd. So that's how you configure a container, make it a web server, forward your ports, forward your folders, and make it run as a service. Like, subscribe, and comment. Especially comment part. I really want you guys to share all your knowledge with me and everybody else in the community. But for now, like, subscribe, and comment, and I'll see you in the next one. Thanks for watching my RH134 training course. I hope you enjoyed this. Like, subscribe, and comment. Ask any questions you may have. I'm really happy to answer you guys everything you might be asking. And don't forget to check my EX200 playlist, where I do a test exam, present the solutions, and show you how to work out most or all possible questions that you may have on our EX200, the RHCSA exam for Red Hat 9 and Red Hat 10. So thanks for watching my RH124 training course. Thanks for watching my RH134 training course. Don't forget to check the EX200 playlist, where much more I'm going to add much more to that. I already have added much more to that. Plenty of exercises, explanations, and tips. I see you there. Okay, like, subscribe, and comment, and I'll see you in the next one, guys. Cheers, man. Many thanks.